we're not going to get it down to anything like clinical here, though, are we? This is just exploring the possibilities.
You know, I could say, well, it's because I had a rubber duck on my windowsill that day. You know, it could be something. You know, that's got as equal validity.
You're not trying very hard.
You know, but no, I mean, I was using a ridiculous example.
No, but like, did you hear what I said about my mum earlier?
No, I've literally just joined. I had the drunk in the garden and something being interested in a drunk in your garden who was probably having a pee.
Yeah, well, he was trying to sleep, and then he was trying to climb over my fence, which was really funny because it was like he was just half of him was outside my garden and half of him was inside my garden, and he was like that for a few minutes. Yeah, that was pretty funny. But no, like my mum had an out of body experience. I was saying, and I was like, that's probably why it's like ticked off. Like something she knows now, so that she doesn't need to be interested in it. But she also saw a ghost at work. She worked at a very, very old building. I think it was Victorian or probably older. It could have been George. I'm not sure. But, her and another member of staff both saw a ghost. Same ghost. And it was similar to you because the ghost was like an old lady in old attire and with like a hand holding like a candle, yeah, like and walking like not aware of my mum and the other member of staff. So to me, again, kind of like a memory being played out, like, but so and not by a door, but by a window, right? So this lady's trying to walk out of a window. But yeah, the other member of staff was absolutely, shitting herself, going crazy. Oh, there's a ghost! There's a ghost! My mum's just watching it and laughing at the other member of staff because she's screaming. So again, in another way, it's kind of clarified it for me, but not properly. I still want to see one like that. I've never seen one like that.
I think places have memories. You know, I think why we see what we see. You know, whether it's an alignment, whether it's due to our mood, whether it's due to being in a state. You know, I do think that places have memories of things that have happened, especially if they're powerful things.
Emotion, like etched onto the physicality.
Yeah, and I mean, I've felt that in many locations. Whether that's me wanting to feel it or whether that's actually being real, who knows? But I mean, I can only take my own steer on that. I'm quite a skeptic on a lot of things. But I do have a theistic view of the world. I just recognize that an awful lot of my theism is based on faith, not on evidential. And it's when we start to look for the evidential, I think it actually moves away from us.
Yeah, that's interesting. I mean, I don't.
Sorry, go.
Yeah, just real quick on the whole, use of the term faith. I mean, would you say that your faith is based on something that is at least empirical, and by that I mean something that you can point to, even if it's
I'd say experiential is a better word than evidential, because I think the whole point is, I mean, I have a problem with some of the more hardcore kind of Christian-y types and Islamic types, and who say, I know this is true, and I'm thinking, technically, according to your own doctrine, you're consigning yourself to hell by saying that. Because if you take just the Christian faith, the two requirements to get into heaven is faith and grace. And if you're proclaiming certainty, you're denying faith, because you cannot have a certain faith. Faith becomes irrelevant in the position of certainty. And one of the things you find in an awful lot of doctrine, whether it's Christian, Islamic, Greek, Hinduism, Jainism, whatever, is this idea of humility, about recognizing the fallibility of our nature, which is why it creates that leap of faith position that, as a theist, you need to take, because these are the things you are not certain about. And hubris is always described as one of the real problems in the human psyche. Yeah, Sisyphus rolling that rock up the hill, he's in there because of hubris. Well, that and for cooking some people and feeding them to his audience, but we won't go into the weeds of it. So that's one thing I always take in mind. So I've spoken to a lot of atheists, and I said, you hold a position of atheism for the same reason that I hold a position of theism. And that gets quite an interesting reaction a lot of the time. What do you mean? No, I've no evidence. I said, yeah, exactly. It's a faith-based position. You have no evidence for the proposition of God, but equally, or gods, or however you want to view it, but equally, you have no evidence to support the negation of that proposition. So in fact, we all hold an agnostic position because we don't have a point of knowledge to know that certainty piece, but what we do have is a position of tentative acceptance. Hence faith.
Well, I think that's
not a conversation you expect from me.
I don't have any expectations, but I think that's an interesting analogy to usually what we say about the globe Earth versus flat Earth. It's just as much the same kind of epistemological decision. So I guess what I'm saying is, one of the things is that scientism is a religion, and like one of the criticisms is, the heliocentric model is just a religious group. You guys have certain beliefs, or they have certain beliefs that are just as, I suppose, valid to hold as flat Earth. But that disconnect, like you said, if you're talking to an atheist and you try to describe their commitment to their system, and you say it's just the same as mine, we're both expressing a commitment to something that we believe to be true, but that we actually can't prove.
Yeah, I kind of disagree with that. I kind of disagree with that quite strongly, because one, I'm talking about something that is non-evidential in the first sort of position that I hold, and in the second one, I'm holding a position based on the evidence.
Okay, so that's where you and I are. That's where I would disagree with you in terms of what faith is. So, I've always had a problem, even when I was a Christian, when I heard other Christians, say that faith is just I can't. I don't have any reason to believe this. It's just faith.
You have reasons to believe it. As a Christian, I think you definitely have reasons to hold to a Christian doctrine. And you can talk about the history of the religion, you can talk about the doctrine of the religion, you can talk about the efficacy of the religion. So those are your reasons. They're not really, as you would say, evidential, because there's no sort of demonstration of the miraculous through that. But that's the leap of faith you take from your doctrine. Whereas, my position on the shape of the world is based through my personal experience and testing it. It's based on the evidence produced and provided by others. And the consistency of the outcomes of those positions. So, you know, is it impossible that it's all, you know, faked? Yeah, well, anything's possible. You know, there could be a pink unicorn orbiting Venus. That's possible. I don't think it's true, but it's possible. You know, so I don't think that the flat Earth has the same I don't think there's an equality of validity.
So one of my responses, I don't ever bring up NASA. I don't ever bring up space when I argue my commitment to flat Earth. But if I were put in a situation where I was having a conversation about that, I've always said that if I were, you know, back in the 60s, before they went to the moon, before they had a picture, and then they allegedly go to the moon and have a picture, my argument would be that the picture is absolutely fabricated. I wouldn't call it CGI. They didn't have CGI back then. Okay, I'm not arguing the method of how they created.
No, I'm not even gonna hold you to that.
No, but my point is, my argument against the globe would remain the same. So in 1968, my argument against the theory that the Earth was a globe would be hydrostatic physics, the nature of water. So simply because you can then show me a picture and go, look, the Earth is round and the water is sticking to it, I'd be like, yeah, that's not reality. That's fake because of what we know water does.
Well, no, water acts based upon the forces acting upon it, doesn't it?
Can you give me an example?
Sure. You know, I can, you know, so we can, let's take it down to the small scale. The meniscus of the water will stop it being flat.
Right, and so then my argument would move away from the contact that the water has with the edges of the container to the surface of the water.
No, I'm talking about no container.
Right, okay, so spin that water. Put it on a piece of paper and put it on a machine that'll spin it.
Now I'm adding more forces in, so it's going to react to those forces. I agree.
Sure. Yeah. So I do agree that water does react to forces acting on it. Absolutely.
What I can prove in my day-to-day life is, you know, things seem to fall down towards the surface of the Earth regardless of what they are. You know, as they go up, they lose kinetic energy. As they come down, they gain kinetic energy.
Yeah.
So there is obviously something causing that downity. You know, obviously we label that as gravity.
But the medium is mainly gas, and the things you're thinking of that fall are, of course,
I'm including gas in that. You know, and then you've got buoyancy, which is a function of that dropity. Because everything's trying to go down, but some things are lighter, so they're going to go up. You know, to me that's logical. It's repeatable. It's demonstrable. Whether I use water, whether I use a more viscous liquid, or whether I use gas, you know, it's fluid dynamics. Sorry, go on.
Well, I just to carry on, then my argument would then be that the nature of water, when it is contained, is that the surface of that water is level. So we've all gone to, you know, we've all gone to school, and they have an aquarium filled half with water, and they drop objects in it to demonstrate, you know, the principle of what's the word I was looking for? But you know what I'm talking about. Displacement. Yeah, displacement. You know, volume displacement. So you drop in a heavy rock, and the water rises. But I remember one of the things that we were, encouraged to think about was that if you drop a shape, a heavy shape into the water surface doesn't conform to the shape of the object once it's under the water. You know what I mean? So like if you had a large enough aquarium and you dropped a bowling ball, a rather large object, the water wouldn't be convex at the top. It would still remain level.
Yeah, I agree.
Okay, great. So if we just simply create a larger body of water, it's always going to be level no matter what the surface of the container is doing underneath the water.
Yeah, I agree.
So it will never curve.
But now you're confusing the level concept, aren't you? Because level is perpendicular to the force acting upon it.
No, now you're changing the definition of level.
No, I'm not. I'm really not.
Okay, so how does the definition of level apply to an aquarium?
Aquarium, again, level, it will be acting on the forces operating upon it. That's where. So when we're looking at the when you take it, that's the classic sort of Newtonian physics, which is the fact that things are accelerating downwards. That's kind of was the observation. We know that those vectors are not all in the same direction, and we proved that with plumb bobs. When you compare plumb bobs to each other, they're not parallel. So we know that the vector is changing, and the water's conforming to that vector, and it does it quite accurately.
Okay, so let's go back to what I was trying to go back to, and that is when we are in a discussion of an aquarium, what is your understanding of level and the physics of water in an aquarium?
Yeah, sure. Make that aquarium big enough, and you take plums on that aquarium. Every point on that aquarium will conform to the plum.
But it's dependent upon the container itself.
No, it's not.
It's not?
If you made one big enough, no, it's not.
Okay, so
if you made an aquarium a mile long,
yeah,
you would be able to measure the curvature on that water, and just by using plums, just by comparing whether those plums are parallel and whether you're perpendicular.
Okay,
let's say you can make that aquarium perfectly still. That's the other problem, because we don't have any still water.
So let's create a container that has a beveled bottom. So the bottom of the container is curved; it's convex.
Mm-hmm.
If you put water into it, the water surface is not going to be convex. So
if you made that convexity, 1 degree every sort of 60 nautical miles, then you would find that the water would conform exactly to that.
No,
that would be my argument. And as I say, you can measure that with plumb by comparing plumb lines to each other. Okay.
So again, as I started with a smaller container with a beveled bottom, so it has a convex bottom.
Mm-hmm.
And let's say it's a 10-gallon or a 10-liter container, and then we simply make that container bigger and bigger and bigger, and the bottom is always convex. No matter how big you make that aquarium, the water at the top will never conform to the surface of the bottom.
If you made it perpendicular to the force, it would be.
Okay. It's always going to be perpendicular. It's always going to be upright. So if, let's say I go back to the 10-liter size aquarium, and I have the entire aquarium level, right? So it's on a level floor or on a level table. If I tilt the container will not be level, but the surface of the water will.
Yeah, because it's acting on the forces acting upon it, which conforms to plumb. And when I'm going to go back to the same answer, which is when you compare plumb lines to each other, they're not parallel.
Okay. Then again, that is an absurd claim, right? You have no evidence.
It's an evidential claim.
Okay, so again, it's a conceptual claim.
No, it's a measured claim.
Great. Show us your evidence.
What do you mean, my evidence?
I don't want you to produce someone's diagram or someone's alleged measurements that they are putting forth to express a concept. I would like you to demonstrate that you have measured that two plumb lines have deviation from one another.
I've never personally measured the distance between here and New York, but can I use a map to get a really good idea of what that distance is?
It's a false equivocation.
No, it's not. It's an exact equivocation.
It's absolutely
it's a non-equivocation.
It's absolutely not. You're talking about. I was just about to tell you. You're talking about, as far as I understood what you said, I'm going to respond and say, you're talking about distance. I'm talking about the position of two vertical plumbs. Yeah. So in my world, my response to your suggestion that two vertical plumb lines at different locations on the Earth will have a deviation between those plumb lines, my understanding of physics is absolutely not.
So again, I would ask you, I'll respond and say, when have you personally measured that then? Because I've never personally measured the distance between here and New York.
Right. So
I don't think you have either. I have never personally measured reciprocal zenith angles between plumbs, but I've seen it done. And I've looked at the methodology, the same as I've looked at the methodology of how cartography works. Both seem pretty consistent, both seem pretty good. So I would repeat that challenge. You say, according to you, you know this. So does that mean you've personally measured reciprocal zenith angles on plumb lines? I'll put the same challenge back to you.
Yeah. No, that's a fair challenge to bring back to me, and the answer is no. So my question though is, I would be interested if you have the ability to find what video you did see. I'd be interested in looking at it, because I would have to evaluate, all of the data that they presented to you. But for my example, so like I said with Jim Jam earlier, my transition into flat Earth took me 30 seconds because of an argument based on physics. So my argument to you is simply deductive, right? So if I am standing on
it's inductive, isn't it?
Okay, well, if you want to wait until I finish and then show me what you mean, I'll be happy to hear. Okay, so if I'm standing on an elevated piece of land and I drop a plumb on an uneven part of that land, so that my tripod for the plumb, I have to adjust the legs. They're all different lengths because of the unevenness, right? But that plumb is going to be 90 degrees. So then if I then move away from that elevated piece of land to a more level piece of land and drop a plumb, that plumb is 90 degrees. The other plumb is 90 degrees. They are parallel. If I continue to make... Yes.
Well, the only way sorry, go on. I was just going to say very, very quickly, the only way you'd know that is by actually doing a proper comparison, and that's by establishing, as we do, using that creating that plumb, creating a horizontal for that plumb, and then doing a return measurement, well, a series of return measurements there, a series of return measurements back, and then seeing if those horizontals meet at 180 degrees. Would you agree that that's a fair way of testing it?
What do you mean the horizontals meet at 180 degrees? I'm trying to understand. What do you mean by that? I think I know, but... Yeah.
Which is fine. I really like the way you're asking your questions, by the way, Copernicus. I think this is a good way of discussing it. So let's just say we draw an imaginary line between 2 points. So if those two plumb lines, if they're both verticals to each other, you know, both parallel to each other, then one line drawn from the plumb to that horizontal, and another line drawn back from that plumb to the another line drawn back to the let me rephrase this. So we draw a horizontal from point A to point B. We draw another horizontal back from point B to point A. Those two lines should meet, and it should be 180 degrees would be the angle we'll measure across the totality of that line.
I get you. So basically, when you say 180 degrees,
flat line.
Yeah, right. When you say 180 degrees, you mean horizontal line. Yeah, okay.
Yeah.
So
they'll basically be they'll meet nice and perfectly, and they won't be meeting at any form of angle, so there'll be no crossing over of those two lines. Effectively.
Right. So in my example, the first plumb line is going to be at a higher elevation.
Doesn't matter.
No. I get. I'm just describing the scenario. So they're not on the same level, but they are parallel to each other.
Can we say the same altitude or the same elevation? They're going to be on different elevations, because otherwise we're going to start mixing up our words and getting confused.
If you need to make those distinctions, I suppose I'll make whatever distinctions you need to make. My differentiation between elevation and altitude is elevation is ground based, altitude is in the air, right?
Well, normally when I'd say elevation, I mean from mean sea level.
Right, but that's on the ground. So as soon as I get in an airplane, I don't have elevation anymore. I have altitude. Right?
Yeah, but that's fine. That doesn't really matter to me. In this example, it doesn't really have any bearing. So,
right. But my point then would be that your qualification is without distinction, because there's no reason to be like you brought up the terms elevation and altitude. But now
I'm happy with elevation. I'll use that to be consistent.
Okay.
So as I say, if plumbs are parallel, we would then expect those horizontal lines to happily sort of show the fact that the reciprocal angles will add up to 180 degrees. If we have less than 180 degrees, it means the Earth's concave. And if they're more than 180 degrees, it's convex. Fair?
Conceptually, yes, that's fair.
In geometry, yes, maybe.
Right, but see, so again, imagine that I'm in the country 300 years ago. I'm not aware of the scientific discussions that are happening, blah, blah, blah. And I am surveying my land. And it's a quite substantial piece of land. And, you and I haven't talked to each other in quite some time, and you've gone away to university, and you come back with everything that you've learned. And you see me out dropping plumbs and doing elevation and reciprocal angles and all this kind of stuff. And you're like, hey, have you ever thought about this? And I'm like, hey, what are you talking about? What are you going to get me thinking about now, man? And you said, did you know that those plumbs that you're dropping, that they're not parallel to each other? So everything that I did before that, nothing in my empirical understanding would ever have made me think that when I drop a plumb at this part of my property and I move away to another part and drop a plumb, I never would have thought that those two plumbs deviated. Nothing would ever make me think that would be possible.
Can I ask a quick question?
Sure.
What makes you initially think that they are parallel?
Because they're both plumb. They're both vertical.
Yeah, so you assume that that they are parallel.
That's why it's inductive and not deductive.
Hold on. No. There's no assumption. If I excuse me, if I'm going to start to build a barn, and I establish my foundation, and then I start to raise up posts in the four corners, and I establish that each of those posts is plumb, then they are parallel. That's a no-brainer.
If you assume that the Earth is flat, then sure, yeah, it's a no-brainer.
Okay, let me say this again, because I already said it. When I am dropping plums, nothing in my direct empirical experience would make me even consider that those plums are not parallel.
Yeah,
I'm not
which is why it's an assumption.
Hold on. It's okay. You interrupted me. Now I lost what I was going to say. But
sorry, I apologize. There was nothing in your empirical experience that would suggest.
Yeah, I don't know that it might come back to me. I can't get the point that I was going to try to make, and I don't want to. Even though I love to hear the sultry sound of my voice, I don't want to repeat myself over and over again.
Well, that's why I was just also demonstrating I was actually listening to what you were saying.
Oh no, that's fair. That's fair. But
I was hoping to provoke your memory, because normally repeating someone's last sentence helps.
No, yeah, and I understood what you were doing as well. Yeah, so when you come along now and you make a suggestion that would go against what I understand to be the nature of reality, I would say that you hold the burden to now prove to me your claim.
Yeah, and I would actually totally again agree with that. I don't think that's an unreasonable position, because that's how we get rid of assumptions and we move to a measured conclusion. And even then, that's within the tolerance. I mean, one of the things I love talking about is the fact that all instruments we use. I used the example of my desk. So my desk, reasonably speaking, is 170 centimeters long. I've measured it a few times. But the question I would then say, is it actually 170 centimeters long? And I would actually say, probably not. To within the tolerance of my tape measure, yeah, it pretty much reads at 170. Maybe 169.9 or 170.3, somewhere around there. But let's say that the wiggle room on my tape measure against a good standard is actually, say, half a centimeter. So it's plus or minus half a centimeter. So now what I've got to say is that, what I do know is that the length of my table is between 169.5 and 170.5. So that's the first thing I look at. So we look at the instruments we're using to take the measurement. So my tape measure is pretty shit for measuring 1/1000th of an inch. One, it's in centimeters, and two, it's not that refined as a measuring tool. So I'll get a micrometer out, and then I can take finer measurements to sort of reduce that level of wiggle room down. And it's the same when we use instruments for things like survey. Those instruments operate within a particular tolerance, and if the amount of deviation on that measurement is less than our tolerance, then we can't say fuck all about it apart from it's between X and Y. So that's
right.
kind of where I start when I look at instrumentation.
Sure, and I, in my opinion, the greatest instrumentation for establishing level is water. Because water is not going to have a higher elevation than another if it's standing. Right.
So let's go back to the classical figures. So let's make, just for this hypothetical, not asking you to agree with it, but just for this hypothetical, let's say that we've established the force of gravity and what it does, and the fact that water conforms to the forces acting upon it. And what we're looking at is a very large amount of distance required to show a fairly small amount of variation, that 1 degree per 60 miles. Is that something you think you can eyeball in a 10-gallon tank?
Okay. I don't think that I'm able to answer your question because a 10-gallon tank doesn't have the volume or space area.
So it's not a refined enough instrument to do that measurement with.
No, absolutely not. It is.
So what's the tolerance on your measurement for your tank?
What's the tolerance? I'm not sure I understand what you mean. Okay. So the tolerance for a tape measure, I understood. Your example of your desk. Okay, so the tolerance there, you're talking about the what's the other way of saying that?
The plus or minus.
The margin of error. The tolerance is
Yes.
the margin of error. Is that what you're saying?
Yeah.
So I suppose that my answer, in a layman's sort of way, if I have a 10-gallon aquarium, there is no tolerance of error. Once I put water into it, that water will have...
We're talking about a differential, though, aren't we? So let's say that we establish a true horizontal line on the surface of the water of that tank. What's your dropity from one end, from the middle to either end?
0.
No, if the Earth was a ball.
I'm not going to concede that.
No, I'm not asking you to concede it. I'm creating a hypothetical thought experiment, because what I'm trying to demonstrate is the amount of tolerance required, or the amount of margin of error required, to invalidate your measurement.
So I'm comfortable with creating a physical sphere, a physical object that is spherical. That can be measured. We can measure the circumference. We can do all the measurements we need from that. So the drop in a I don't know how to say this. I'll just say basketball is going to be less than the drop of a baseball. The baseball's smaller, so the drop is going to be more acute.
Pronounced. Yeah, it's much easier to see. I can use a 12-inch ruler. It's very clear. I can use a 12-inch ruler on a basketball. Now, if I get a 12-inch ruler and I create a ball that's a mile in diameter, then that's a bit harder to see. Now I create that ball to be 10 miles, it's going to be harder to see. Now I create a ball that's 100 miles, that's even harder to see. Probably not detectable with the ruler maybe at that point, I don't know. We might be able to rock it a little bit and say, ooh, it doesn't feel particularly good. Now I create that ball to have a circumference of thousands of miles, perfect sphere. Chances are my ruler is now no longer going to be an object that's going to allow me to show that it has curvature. That's your problem.
No, you know that it has curvature because it's a sphere.
No. You're trying to measure it. That's what I'm talking. We're talking about measurements here. Yeah, I may know it's a sphere. What I'm trying to do is to see if my ruler, which was perfectly capable of showing that sort of drop, or indicating that there is a drop between the midpoint of the ruler and either end, was really, really clear on a baseball. And as you scale up that object, it becomes less and less and less clear. This is the same analogy as your fish tank. Your fish tank is your 12-inch ruler, and you're sitting it on an object that is thousands of miles in diameter.
Yes, and water will always be level.
Yeah, it will conform to the forces acting upon it. So if we have a force that is pulling towards the center of that sphere, which is the argument from gravity, then it's going to conform to it. But the trouble is, as you make that ball or that sphere bigger and bigger and bigger, the ability for you to see that curvature on that water becomes less and less and less, the same way as the rocking of the ruler on that ball will become less and less and less as you make that ball bigger and bigger and bigger.
I understand the argument.
I thought it was quite a good way of explaining it.
I understand the explanation.
Do you see a problem with it?
Yeah, water does not curve. Water remains
well, that's
level.
just repeating the same thing. But if we say that you're sitting that fish tank on a surface that is that large, and that force is being pulled down towards the center of that sphere, it would become harder and harder to see as the object gets bigger and bigger, wouldn't it?
Not if I not if I had a large enough aquarium that could function as a ruler. That water would never curve. It would always remain level.
How have you measured that?
I haven't.
So that's why you have an inductive argument and not a deductive argument, because you actually have, it's an assumption that you're making that you live on a flat plane. It's not something you've actually tested in reality.
Okay. It's not inductive, it's deductive. So based on what I know,
deductive would be that your premises in the argument are true, so you'd have to demonstrate that the planet is flat and not curved.
Yeah, okay. We've both been in this discussion before. As you said, I'm just going to repeat myself. So if I have a small scale demonstration that water, standing water that is contained, has a level surface, if I tilt the container will change its orientation, but the water will not. Now, if we have this sphere that you're talking about, and I pour water onto it, that water will run off because it's going to react, as you say, to the forces acting on it. It will not conform to the shape of that sphere, no matter how big you make it.
I think the problem is maybe we're discussing deductive and inductive arguments in a different way than maybe is valuable to it. So I'll give you an example of one of the simplest deductive arguments that I know of. All men are mortal. Socrates is a man. Therefore, Socrates is mortal. Now, if all men are mortal is proved true, Socrates as a man is proved true, then the conclusion is true.
Okay, so now change that into a if-then statement with a...
If all men are mortal and Socrates is a man, therefore Socrates is mortal.
No, I want you to change that now into...
That's modus tollens.
I'm not disagreeing. I'm asking you to now apply that if-then to the discussion we're having with water.
Sure.
So,
if the planet is flat and water always finds its level, therefore the Earth is flat.
No, I wouldn't approach the argumentation that way.
Fine. I mean, it's your argument, not mine. But
no,
what I'm saying
no, that's not my argument. You're
claiming the Earth is flat based on the fact that water is level.
No, I didn't make that claim in this discussion.
Oh, in that case, so you're not claiming the Earth is flat.
In this discussion, we're talking simply about the physics of water.
Yeah, but I'm trying to find out. Okay, right. So water always finds its level. We both agree on that. Then we're done.
Okay, so let's make that. Let's do our if-then. If water always finds its level, then no matter how big the container is in which you place that water, the surface of water will be level.
Yeah, I agree.
I agree too.
There you go.
Surface of the sphere is level.
Yeah, but that doesn't mean it's flat.
That doesn't mean what is flat?
The water.
Oh, I didn't use the term flat. I used the term level.
Yeah, I know, but level and flat are not synonymous.
That's why I didn't use. Okay, that's why I didn't use the term flat.
Cool. So cool. So we don't agree. So whether it's flat or a globe, that's not part of your discussion.
At this point, no. I'm talking about contained standing water.
Mm-hmm. Cool. So what?
Okay.
Yeah, that would be my next place to go. Well, great. We both agree on the basic terms and premises. So is there a conclusion that you want to draw from that observation?
I've already made my if-then statement.
No. I mean that, yeah, which we all agree with.
Water on the Earth is level.
Well, water at rest.
That's why we have mean sea level.
Yeah. And we have to take mean because it's an average.
Yeah, but there's also interesting discrepancies within the oceans. I mean, they're never level, but like in the Panama Canal.
Because of the forces acting upon it.
Yeah, in the Panama Canal, the Pacific side is 20 centimeters higher than the Atlantic side. Which baffled people in Next Level Discord. I guess the agreement killed it.
Well, we have consensus, we have concord, or concordance. So let me ask you a question, Copernicus, because I think you made some good points. Do you think horizontal and level are the same thing?
That's a good question. I think that they can be correlated, but I think that they are different terms for different reasons, right? So I've thought about that. I'm like, man, why do we use the term level? Why do we use the term horizontal? I think I would say level has to do with a physical demonstration, and horizontal is more conceptual, right? So if I'm using a theodolite, I can create an apparent horizontal that's not physical, right? It's a line in the eyepiece that once I've established that my my theodolite is is plumb, then I can feel comfortable saying that the marking in the eyepiece is horizontal, giving me the ability to understand that to extend that horizontal in front of me conceptually is horizontal. So horizontal to me would be a conceptual designation. Level would have to do with a physical representation of horizontal.
I liked where you were going right up until the last few words of that sentence.
Okay, well, help me refine it if I need to. Go ahead.
So I think again, that's an interesting thing, because if we take that horizontal, so we can use that local plumb, create that line, and what we tend to find is if we had a true consensus between level and horizontal, then we wouldn't start seeing drop towards the horizon as we gain altitude. That would be one of the problems that I would see with that observation. Because perspective will draw everything up to the eye line. That horizontal, that eye line, should therefore meet the horizon.
So, in my experience, when I go out to the Chesapeake Bay and I take a photograph of a distant shoreline,
is this Travis?
Yeah.
Oh fuck, man! Sorry, I didn't realise you. Hello, happy New Year.
And to you. I don't know. Yeah.
Bruh.
So, yeah, I know who you are. Yeah. Yeah. So when I go out to shoot the Chesapeake, and I stand on the shoreline and I look straight ahead of me, apparently the distant shoreline is at my eye level. because I'm just standing there looking straight ahead.
Mhm.
So if I look to my left and I have something close to my proximity, that if I look far enough away, I'm looking straight ahead of me a mile away, and I see the shoreline a mile away. And I can take a picture of that shoreline, and I actually can see the water hitting the shore. So I'll say I've got a direct line of sight to the shoreline a mile away.
Mhm.
And then I move my camera to a position 3 miles away. I cannot make out the distinction of the water lapping against the shore, but I can see apparently where the shoreline meets the water. So I'm going to say I have a direct line of sight to the shoreline. If I then move to the other object, which is now 6 miles away, and I have less clarity to distinguish where the water meets the shoreline, but I have an apparent shoreline at my eye level, I have a direct line of sight to the shoreline. So then if I move that to the 9 mile observation, the argument is still the same. I'm looking straight ahead and I can see the shoreline. It's in front of me. But I don't have the clarity that I did at a mile, but I'm still seeing the shoreline directly in front of me.
Yeah, and we've talked about the problems of viewing stuff over water, especially where you've got large differentiation between the water temperatures and the air temperatures and the rest of it, which is, why I was saying, the higher up we go, the less kind of interference we get.
Okay.
Which is why I was making that observation that, if we draw that horizontal out, the horizon should always come up to our eye line if the Earth is flat. Technically speaking, it should be a little bit above it because of kind of refraction. But what we find as we go up in altitude is the horizon drops below our eye line, below that horizontal, and it does so at a very predictable rate.
Okay. So let's go back to the 6 mile observation. And for quite some time, I had distortion and lack of clarity. And in another series of photographs on a different day, I actually have a direct line of sight to the shore. I can actually see it.
Yeah, the atmospheric conditions, the refraction allows you on that particular day to get a better image, and it may be lifting up that stuff in the background a bit more, so you can see a bit further. Cool.
No.
We already agree with the properties of
No.
how conditions change day by day. But I don't feel you're actually addressing the point that I'm making, which is as you increase in altitude, the horizon drops below your eye line in a very predictable and measurable way. It sounds like you're answering a different question.
Okay. Well, I didn't bring up changing my altitude, so
no, I asked a specific question, and then you went off on a tangent.
No, it's not a tangent. It's not a tangent. So I disagree that the refraction lifted up the shoreline so that I could see it.
Cool. But I'm much prepared to address the argument I'm putting forward, which was the question I asked at the start of this sort of piece, rather than going back down into sort of heavy levels of density change as you get closer towards the surface of a body of water, and especially in the Chesapeake Bay, where you have quite large differentials between the water temperatures and the atmospheric temperatures.
Okay.
Actually, you've taught me a lot about that location, by the way.
So I'm trying to establish something from a shorter distance and a lower elevation to then be carried over to address your point about increasing your elevation as well as the distance over which you're looking. So my argument...
That's not what I'm saying. So what I'm saying is, as we increase in elevation, the angle that we observe to the horizon drops below the eye line at a very predictable rate. Not the fact that we can just see further, which is a given, but it's the fact that the angle to that horizon drops at a predictable rate. That's my argument.
Okay, so my answer to you would be the horizon isn't dropping. The horizon is being obscured by the medium so that you aren't able to see into the distance. So the horizon didn't drop. The refraction in the medium created obstruction so that you couldn't see farther than you would be able to if there were no atmosphere. So let me try to say it again, because it makes, I think it's a pretty reasonable argument to make. So if I went across the Chesapeake to the other shoreline and the refraction was intense enough so that I'm standing on the shoreline and waving my arms, and my friend is shooting right at me, but he can't see me. And then we go out 4 months later and the conditions are different. And I'm on the shoreline waving my arms and he says, "I can see you, man. I can see you." I said, "My feet are right in the water. I am standing on the shoreline. You can see me?" "Yeah, I can see you." So he has a direct line of sight. The refraction isn't lifting me up so that he can see me. The refraction is less so that the obstruction is no longer there, because the reason he couldn't see me before was because of the refraction in the air. I was still there, straight in front of him, horizontal to him. His feet were in the water. My feet were in the water. We were directly horizontal to one another.
Yeah, cool. I mean, again, don't deny the observation.
Okay.
And I agree with you that the amount of, to use the Jeremy word, turbidity in the atmosphere and the refraction that's happening is going to change what we can see on a day-to-day basis as we do those kind of observations where we're in the thickest part of the medium. Don't have a problem with that. What I'm saying is, as I go up in height and I'm reducing the amount of medium, I'm reducing the amount of effect. Oh, I am.
You're not. No, you're not.
Oh, I so fucking am.
Oh, you so fucking aren't.
That's where I have a problem. So you're saying that if I'm at 1,000 feet, that I've got the same atmospheric pressure and density that I have at sea level?
No, absolutely. I didn't say that.
Okay, so maybe I'm misunderstanding you, and I should listen.
So when you increase, okay, so let's say you're at sea level and you have a buoy that is out, let's say 3 miles away.
I would much prefer to stick at wide 1,000 feet that I don't have X, because you keep altering and going off on kind of like a what I feel to be a tangent.
Okay, so I didn't understand what you said you would prefer. What would you prefer?
I much prefer we'll talk about, when we gain an altitude.
I'm going to get there. I'm going to get there. Can I get there?
Yeah. That's why I stopped.
Okay, so I have an object out on the water that I can't see very well. So then I am looking at a specific marker on the water that's not going to move in terms of distance. Like, it's going to bob up and down, certainly. And it might have a certain play in the tether that's keeping it grounded. So it could even move in a circumference of, say, 3 meters, right? But it's not going to change its distance so greatly that it's going to be substantial. But from the sea level, I can't see it very well. So then I raise my elevation and I still look the same distance. I'm going to now see that object with more clarity. But if I then say, "Oh, I would like to look farther away at this elevation now," I'm going to create the same kind of difficulty with an oil platform that is now farther away than the buoy is, so that even though I raised my elevation to see the buoy with clarity, the now more distant oil platform is now obscured. So even though I raised my elevation, when I'm now looking at an object that's farther away, I'm now creating another scenario in which I'm looking through an atmosphere or aether band that is going to displace and distort that oil rig. So now I'm going to raise my elevation, but still look the same distance. And now I'm going to see that object with more clarity. And then if I move my observation now farther away to a ship that is farther away, that ship is now going to be distorted, because as you increase in
But
elevation...
we're not looking at a specific object, we're looking at the horizon line. So we're not talking about the problems of angular resolution or, you know, being able to get a clear image of the number on the side of a ship. We're talking about the actual physical horizon line and the drop to that horizon line, and it's really, really predictable. It's really predictable. There is so little variation once you get above 1,000 feet on that horizon line. And the angle to it, that's where I'm having a problem, because the angle to it is defining the range, you know, basic trick.
All right, that's all fine. That's all well and good. I understand what you're saying. So when you're bringing in making a prediction, that's now something that I am not making a claim to. You may make that claim, and you're perfectly free to do that. So my response has been, in the past, when others have made these rhetorical claims, that is, they're using the rhetoric that it is a predictable drop, I would say, great. We would have to, you and I, or someone else who supports your claim, go out to a specific location and perform experiments to validate your claim. I'm simply
I think that's reasonable.
Okay. I'm simply trying to demonstrate. So now let me change it this way. We're going to have 3 or 4 different ships. I'm going
to have to drop. I'm really sorry. I've got a 2 o'clock.
That's okay. I'll keep. If anybody wants,
mailman may understand my point. May carry on that convo. It's just I don't want to just suddenly disappear and you think, oh, what the hell's going on?
I appreciate that. So
really good discussion. I actually like the way you're thinking through this. I kind of disagree with you, obviously, on certain points. But I like the way you're trying to argue through it. I think you're trying to at least be reasonable and logical.
Well, let it stand for the record that Druss has given me affirmation that I am actually pretty reasonable to have a discussion with.
Yeah, I've said. I mean, you know, I think some of the more heated environments that we've been in, it hasn't been quite cohesive. You know, we all get a bit emotional about shit, but I think, you know, ever since I've seen you on here, you've always approached things in a good way, and I respect that.
All right, I appreciate your interaction as well.
Hit us, bro.
Okay, so if anybody else wants to pick up from this, but I'll change the scenarios since Druss put particular markers on it. So if I'm on the shoreline and there is a ship on the horizon, but I can't see farther than that, and there's another ship beyond it, so then I raise my elevation, and now I see a second ship farther away. But what I can't see is a third ship farther away from that. So then I raise my elevation, and then I can now see that ship. In every single scenario, I will say that the reason why I couldn't see farther was the condition of the medium. So my position on the shoreline creates the apparent position of the horizon through the medium. So that when I go up higher, my position there now creates a new horizon as well as a new obstruction due to the conditions of the medium. So that if I raise my elevation again, I can now see another horizon with another ship on it. And the only reason why I'm able to see it is because I've changed my elevation. But in each instance, my elevation and the conditions of the medium together are the reason why I have limited visibility at those different elevations. That's about as clear as I can make it. And with no one to oppose me, I win.
Did you see how he said he's okay with level, but he didn't want to. He didn't want to accept flat. You notice that?
Yeah, why don't you flesh that out? Like, what does that mean for you?
Well, it's confusion because he's saying, "Oh, Earth is level," because that's the globe argument that it's level like a ruler on a circular ball is level. That way it can be not flat. So he confused that. He
Right.
wanted to say
Yeah.
level, and he didn't want to accept flat, and it was just confusion. It's just word games.
Right. So I think my way of saying this is pretty genius. That is, when the last scientist died, science stopped proving things. So at some point, level took on a completely different meaning. So I'll say it this way. When the last scientist died, level changed its orientation. Because level up to that point was always in reference to simply the surface of the earth with regard to water. So if I have a pond, it is contained within an area of land, and that water fills that area. That water, in relationship to the surface, is level. But as you pointed out, in the globe model, level isn't oriented toward the surface, it's now oriented to the center. So when the last scientist died, level became oriented to the terms. They've redefined terms. Does that make sense?
Yes, and it's not only that the science has changed; it's that this control of information on the internet, and the internet has somehow become the authority. Like Google has somehow become the authority of everything, and they're changing the definitions before us, and they're not telling us they changed it. I know that some of it is must be in response to the flat Earth. So they're changing Wiki and they're changing Google, and they're not telling us when they change it. For example, space is no longer a vacuum, right? And now, recently, the atmosphere goes all the way to the moon. So they're I believe they're creating these nonsense changes only to cut to like the flat Earth, and they don't tell us when they change it; they just put it in there. So yeah, there aren't many more scientists doing this stuff. It's really Google and Wiki and these other websites that we're all going to, and they're making new citations. But who can question them? That's what I think. Who can challenge them? How do we challenge them? How do we challenge them?
Yeah, I don't know if you can hear me.
Yeah, go ahead. Was that roboting? I can hear you.
For me, I think my it's really bad. I think my
Was that coming through?
connection's bad.
Yeah, you were fine, Godric. Travis is having some issues.
Oh, okay. Good discussion. I like how it was civil. I think he was being. I think he was avoiding questions. Yeah, I think it was a good discussion. I think he's avoiding. I think he's dodging some important points, so he doesn't have to prove a globe. Like I noticed how he actually proved it flat. That was interesting. He's the one with the globe claim. He wants us to prove it flat, and then he goes, "The distance to New York isn't exact." Like that's completely, that's not even in the ballpark. Distance to New York, really? You can tell the difference between flat and curved within a few miles, so we don't have to go to New York. Geometry states if be a ball, there would be this curvature. If it's missing, they have to explain that. Am I right?
Yeah.
And he goes, well, ruler's not exact, 170, 170.3, it's not exact. He's obfuscating.
Do I have a connection now? Check, check, check.
Yes.
Yeah, I apologize, but I'm sure everybody else appreciated what you had to say, but I couldn't hear anything.
Okay, no worries. I think it's on. Is it being recorded?
I certainly hope so. It's been a great discussion.
Yeah, you're still recording, right? So there you go. You can review.
Yeah, I'll have to check it. Yep. Yeah, you'll have to check back too. Earlier, like around 5 o'clock, 6 o'clock, there was an absolute fantastic discussion with Laurie.
Was that with you and him?
Yes. Yeah.
Okay, I'll check it out.
Yeah, it was a blast.
Question on about geometry. If we're confirming that it should be 8 inches per mile squared, is that 8 inches per mile? Is that dip? Is that hidden curvature? 8 inches, 32 inches, 672 inches on the third mile. Is that hidden objects, or is that another measurement?
What?
The supposed curvature, 8 inches per mile square, is that the same as hidden objects of that height, or occlusion from A to B, or is it something else?
I mean, it's supposed to be hiding objects, with that. I mean, because what's happening is it's the Earth would be curving, and at some point, the objects are the objects are pretty much hiding at that rate, I imagine.
Yes, so if you drew a straight line from A to B, and then put a globe ball in there, there should be 8 inches, 32 inches, 64 inches, etc., 66 feet at 10 miles. Physical occlusion of these objects.
Yeah, I guess so. Yeah.
Would it matter if the object was on the horizon, or if it was on the other side of the horizon?
Well, that's such a finely nuanced question, because there's so many dependent variables. So the horizon would be, what's your elevation? Are you on the shoreline? Roughly, because leave 3 miles away. So the horizon wouldn't be 10 miles away, right?
At 10 miles, right, that would be 66 feet of physical curvature from the surface. Not observed, but from the surface.
Right. Okay. So on my channel, I have video footage of the Anacapa Arch, which is in Google 50 feet high. It is 19 miles away, and I have a direct line of sight to the entire arch.
Where is your channel so I can see this?
If you give me a second, I'll post it.
Okay,
but give me a few minutes.
That you've done, or did you borrow it?
No, these are all my observations. I have
Nice.
observations made of gold. The only problem is I wouldn't be able to tell you which video has that footage.
Are you gonna put your YouTube in here?
Yeah.
No worries, I'll check it out. I'll look through your stuff. I'll find it. What's the name of the arch called? I think he's roboting right now, right?
Yep.
check. Mic check.
Yeah.
You're okay. A little bit choppy, but okay.
Yeah, you guys are roboting for me. Am I roboting?
You're clear right now.
Okay, so I just put the link in the chat then. Did you see it?
Yeah, I subscribed. Thank you. I'll check it out.
Make a little simpler. So I'm not hearing anything. Is anyone talking?
Nope.
We can hear you. It's gone quiet for a while, but we can hear you fine.
Okay.
Yeah.
Yeah. So
You're the one on the discussion?
say again. I'm what?
You're the one on the debate?
You mean the one that was happening before?
Yeah,
Yeah. My name's Travis, by the way.
Travis. Yeah, you did good. That was a good job.
Oh, thanks. But yeah, if you look at the playlists, that'll give you some different categories. I have tutorial playlists. I think if you look up Anacapa, that will possibly have a more accessible video that will show you the island with the lighthouse and the Anacapa Arch.
Hey guys, so what percent of people do you think are basically losing their job over this nonsense? Like 1/10? Like what's the percentage you think? Let's say across America. Anybody have an idea? Because I wonder if that's going to impact all these companies with less workforce. Or do you think they'll just replace the jobs right away, or just make it tougher on the people that are there and have to do more work?
Yeah, I don't know. That's an interesting question. You know, whether or not the powers that be are creating this conflict to make the way for more automation. I don't know. You know, that very well could be what it is, that they're trying to eliminate the human element so that they can then, you know, have, I'm sure what they've got this warehouse full of all of these automated AIs just waiting to be implemented. Then they had to clear out because people weren't going to be, you know, relinquishing their jobs voluntarily. But I mean, to give you a number, I'm not that guy. Who knows?
Well, if you want to keep hold of some hope, like I try to do, you just hope that maybe you get a bit of retaliation from the corporations because they're getting shot in the foot by this. You know, they're losing customers in a sense. So who knows? Maybe there might be a bit of pushback.
Well, right. I mean, that is an interesting element of hope. You know, I think, though, my point still remains, though, that the corporations might not necessarily see the long game, per se, and see that they're in a situation where, like, oh, we're losing our workforce. But then government's going to come in and say, look, we've got the solution. We've got these automated options here. If you want to bring these in, you know, just buy these automations. You won't have to worry about your depletion of human resources now. Because I don't think that they did this without understanding the recourse. Of course, they understood that certain businesses, like even the smaller corporations, you know, let alone the mom and pop that's not a corporation, it's just a single business that had to shut down. Like there was a pizza restaurant where I live that was a good restaurant, and it's gone now. And the only reason why it was gone was because of the event. Yep. So, you know, but if you have a smaller business that has, you know, a few locations, but they're not, you know, necessarily a corporation per se, but they have taken a hit and they had to shut down maybe a couple of their locations, but they still can maintain, you know, their supply and demand on you know, whatever. All I'm saying is that I think once you get to the bigger corporations like Walmart and Amazon and everything like that, those guys are in on the event. You know, not the people that you're checking out with.
Yeah.
But
the people are benefiting. I know what you're saying.
Yeah.
But my theory on it was that not the huge businesses, but businesses nonetheless, big businesses still, like they're losing customers by trying to impose things on them, and then they're going to lose staff,
right,
by trying to impose things. Maybe some of them are a bit, like you say, quite a lot of them are just sort of.
So here's the problem. Here's the problem with that. Okay, so the problem with businesses is they all run in tandem, right? So if everybody's down 10%, nobody's down. You understand? Because they all compete with each other, right?
Oh yeah, I get you. Right.
It's all connected. Yeah.
So in its essence, they'll probably survive even if they were down 10%. You know.
Right. Yeah.
No, but just in a business sense of to get one over on your, you know, your rivals that are trying to enforce. But the rivals are doing the same. If you don't enforce it, maybe you steal some of their custom. You know, I don't know. It might just be another business way of getting more custom.
But here's the thing, though. But okay, so the
sorry, just to give an example, here in England, you've got Sainsbury's that have said It might be a bit different over here in England because they've not tried to make it a law to wear a mask or anything like that. So Sainsbury's is one of the only supermarkets here that have actually said it's your choice. You know, wear it or don't wear it. It's up to you. But I think in that sense they might have just kind of lifted themselves up in the, you know, the preferred shopping centre for quite a lot of people to go to because of that.
That's
So I
good.
think
I noticed Florida, Texas, and Arizona have a lot of pushback against that. Those are conservative states, though most other states are basically falling in line.
I think one of the things that is interesting to me is that this event, even when it shuts down small businesses, the federal government loses out because now they have no taxation from those businesses, right? So they are shooting themselves in the foot, so to speak, right? So if you have a revenue that comes in on a yearly basis because this business pays its tax, and now because of this event, you've created a scenario where that business has to shut down, you've got no revenue.
but they're not relying on that revenue. They're relying on weakening you by taking some of yours. It's not they need that bit of cash off you. It's only to weaken you, right?
Yeah. I guess part of my point was to go into the automation. Like, say, sometimes people will ask me, am I worried about losing my job as a trucker because of automation? Or, what do you think about automation when cars become fully automated? To me, that seems counterproductive to the state, because if you've got an automated car that is going to obey all of the traffic laws, all of your revenue to the state based on tickets and citations, they're gone. You're never going to have to worry about speeding or illegal lane changes or whatever, right? Like, so to me, they're never going to automate the automobile industry ever, unless doing that somehow brings them more revenue. That makes sense?
Definitely.
I think it's already happening. Taxis are already gone, and then you have these self-driving cars, so I think it's already a done deal, just a matter of time. A robot driver won't get drunk, they won't do road rage, probably drive slower, right? I think truckers are saying they won't get their jobs taken, but I think they will. That's the next thing. Their taxes are all gone, basically. Because of Uber and Lyft, but then these Uber and Lyft cars are going automated, so there you go. Just a matter of time before they get a robot trucker. A robot employee, won't sue. They won't they won't get sick and take sick leave. They won't need medical benefits. Come on, dude. It's dollars and cents. Once they get the price down to where everyone can afford it, the whole employee industry is going to get replaced by robots. So there's no way around it.
Well, I think that's part of my point, is that if that's the case, then the money that they are going to make from automation is going to be greater than the revenue that they would be making from road rage or sick days or paid leave, all that kind of stuff. So,
But what's more important, money or control, right? They can
No,
put
I
all the people.
understand. Yeah,
If they
I
can
get
put all
you.
the people out of a job, then they have more control.
Yeah, I get you. I think
That's
that's
Well,
a
a
in a weird
universal.
sense, though, that could be a double-edged sword because if you take someone's job away, what else do they have apart from all the time in the world to direct their anger at whoever took their job away?
If they're too angry, you don't get universal paycheck. If you behave, you get universal paycheck. There you go, control.
Yeah, because I was going to go back to my point again, which is they probably don't need that money. They can make money whenever they want.
That's right. They don't really right. The corporations can make money off the government, which they are doing anyways. For a while, government handouts, government contracts.
Well, it's interesting to me. I think about this every once in a while. I think, okay, I'm already using digital currency because all I have is a digital representation for my manual labor in the bank, right? But it's just ones and zeros. So when I go to the store and I use Apple Pay, that's just a digital transaction. So I'm already using digital currency. So you could very well hack into my account and put in 10 million digital currency. It has no value. You could give me 10 billion. You know what I mean? Like I could walk in and schmooze the bank teller and fall in love with her and have her fall in love with me and say, hey, why don't you just jump into my account and add a few zeros, baby? She could actually do that, right? No problem, because it's all not real anyway, and it wouldn't deplete the economy at all. It would have no effect on the economy whatsoever. So if I go in to buy a car and the transaction is digital, there's no money being exchanged. There's no loss. There's no debt. It doesn't even exist. It's just an exchange of ones and zeros.
You have a good point with the banks because when the banks make a correction, they just type a number. Like if they take off a fee from your account, they just type a number. They basically create money by typing a number.
Yeah, well, I lost my wallet and someone went and spent money at Taco Bell and Domino's, like $200. So I filed a complaint, and yeah, like you said, they're just going to tippity tap, and there it is. Boop. It's all back.
Then on a large scale, the Fed Reserve prints more money, loans it to the bank at interest. The bank loans it to us at interest. So you got this like debt system, and it's not real. It's not based on anything. It's just based on what the market will tolerate.
Going back to your original question, though, what would you say would be the effects? Say, like you say, if it was 10% of the
Well,
workforce.
I do the stock market, right? So they're just talking about how Goldman Sachs and JP Morgan they're losing employees because they're not they're not all coming back. Some aren't getting the jab. but they're kind of like at the same time they're kind of threatening them, like we don't need you, whatever. So it's like they're pretty much falling in line. All the major corporations are pretty much falling in line with basically firing you if you don't take the vaccine.
Right.
So if that's the case, they're all on the same page, most of them. So they're all going to be out 10%. Let's just say 10% of their workforce. I don't know how much it's going to be. Maybe 5%. It doesn't matter what percent. It's going to be a percent, right? So it's more percent different business groups.
Occupation.
But yeah, they're going to lose productivity. In a sense, they're going to gain on the payroll. So I just think it's a balancing act. They can hire more people, but then they won't have the skilled workers. They have to train them. So I think all the corporations are going to take a hit in productivity. Probably they'll have less production, right? Kind of like how those containers are stuck in the docks, right? So less production. But if everybody's doing it, if it's happening to everybody, then it's kind of like it's all balanced,
Yeah, it does seem to be like a wave of flexibility that's washed over the country, because here it seems to be a lot of people are working from home now, where they'd normally be going into an office. So maybe these businesses are actually making a lot more money, like cutting some of their staff for one, and then cutting
yeah.
the,
It's
in the
like one
office.
thing. Okay, so the thing about businesses, like they can cut their staff anyways, because when they cut their staff, they cut the payroll, they tighten their belt, right? Like if there's like the recession, the corporations anyways, they just fire, lay off, furlough. They tighten their belt, they can survive a recession, right? They just cut back, right? But they know how to do it, so they survive financially. So something like this is almost like kind of like a recession in the sense that they're going to be tightening their belt, lowering payroll, and then productivity will suffer, of course. It's kind of like a balancing act, So more people will be home, and then these people are going to be working from home. So there'll be industries that favor working from home. Those are going to go up, Those are going to need more. Those are going to probably be more competitive, So it is changing. I just don't know. I don't know the effects of it, and I think, unfortunately, I think it's almost like you can't tell. Like hundreds of thousands of people are home, not going back, and it's almost like you can't tell.
So wouldn't the stock market be an easy transition into full automation?
Yes, because the problem with the stock market is these corporations are basically they're all about the dollar. They're not ethical. They're not like there are a few exceptions, but mostly the exceptions are all about the dollar. So if they can get it to where robots are cheaper than humans, 100%, they're going to jump on that shit faster than white on rice. It's just a matter of time.
Right. Well, what I was thinking was just simply setting up an algorithm to buy and sell. Right. As soon as it gets down this low or whatever, you just automate.
Oh, you mean trader? You mean like traders?
Right. Right. Yeah.
Well, they already have that to a degree. They have buying and selling, like trading. But the thing about that is, it's just the robot's only as good as the person who made the program, right? The only advantage is that the robots can trade when you're out playing golf, where you're not watching, so they're faster and they're efficient. But I don't think, as a trader myself, I don't think any algorithm will be successful more than let's say the experts that made the programs that told them what to do. But in a sense though, like the job as a trader, a lot of them use programs anyways. A lot of them use bots and stuff. So it's just I mean, in theory, a computer can outdo a human in theory, So like playing chess, right? So that's the thing, and then if that's the case, it just comes down to who owns the machines, right?
Well, there you go. I was just about to say.
Like your employees.
Then a human can also always hack the machine.
Yeah, so machines have problems, right? They can hack, they can get hacked, they can break down,
Infiltrated.
Yeah, there's a movie, I forget, it was a show where it was in the future, and a car was going down. There was a car going down the bridge, and then it just went off the bridge and it killed the person inside. The whole thing was that it was like a setup, like you couldn't get out of the car because it was designed to keep you safe. So you can't get out of the car, and it just drowned the person because it was hacked. So that's what we're looking forward to. Someone doesn't like you. So yeah.
I'm sorry, Dave. I can't do that.
Exactly. Let me out. I'm sorry. I can't let you out. You need to be safe.
Hey,
manual control. Manual control.
Yeah. Hey, speaking of which, guys, listen. You guys need to watch this movie. It's called The Infinity Chamber. And if you have Prime Video or YouTube, it's on both of those options. But I've watched this movie like 12 times in this past year. It's just I love it. It's an absolute amazing science fiction movie. Amazing.
Is it like a 2-hour movie? Is it like a sci-fi?
Yeah, it's like I don't know. I mean, it's not. I don't think it is 2 hours, but it's a good length.
Is it
where
free?
can I watch the movie?
YouTube or Prime Video.
Is it free on YouTube?
Okay.
Yeah, it is free on YouTube. Yes.
Excellent. Have you guys seen that film Tenet?
Yeah.
No.
That's a bit of a weird one, isn't it?
Yeah, it is. I saw it in the theater. I mean, I really like Christopher Nolan. This one, for me, was a little bit of a stretch. Like, it was really...
A bit forced.
Huh?
A bit forced, wouldn't you say?
I think so, yeah.
It came across that way.
Yeah. Yeah, it was a concept he wanted to communicate, and to me, it didn't work as well. So if that's what you mean by forced, yeah, I think that.
Yeah. Some cool concepts in there, though.
I heard Kazakhstan overthrew its government because they were requiring the jab to access your bank account, and I guess they all rioted in one weekend. I don't know if you got that story.
Well, I heard loads got killed. Loads of protesters got killed.
Did they overthrow the government or no? Did the government take back control?
I'm not sure. That was actually on the main news as well.
So here's the thing: like, who do you get to kill your own people? With guns. You know what I mean?
Your own army.
Like, what kind of person is that? Is that like
a dictator that doesn't want to lose his power?
Yeah, but the people that are shooting the guns at people.
Yeah, but listen.
I see. Yeah, just pawns doing what they're told.
Right. Well, yeah, but if you think about all of the Karens that are out there that are flipping out over you not wearing your mask because, like, my uncle is not a Karen, but he's a full-blown stab advocate, right? Like, so my grandmother just died 2 weeks ago, and he would not come see her because she was not jabbed. So now she died, and he hadn't seen her in over a year plus because of his conviction. But my point is that you've got people that are so crazy about this situation that they believe that your death is justified. Like, you should not be alive.
So they have no shortage of people that are going to basically hire them to shoot you. They have no shortage of those people.
I think it's just the whole problem of the media, isn't it? Like, if the message weren't there, then who would be scared about all this bullshit? You know, the fact that it's there and it has
Yeah, I think it's fear. Like, is it fear or is it like some other psychosis that make people act this way?
yeah, I kind of approach it with like just disassociation. You know, I feel like I'm not in the system. I'm just spectating people stuck in it.
Yeah, me too.
You guys watch Squid Game?
Yeah.
I've not seen one of them. This is what I mean. I'm not. I don't know what's going on the TV, but I like it like that. Everyone's like, "Oh yeah, this new program." What? Not on my radar. But I've obviously heard of it because of other things that I watch. Other people talking about it.
Squid Games is a good example how human life has become worthless. It's become devalued to the point where your life is no more important than a dog or an animal. And it's definitely not more important than money. Money is more important than life, you know?
Just a side note, I did put the link for Infinity Chamber on YouTube, so it is still free.
Excellent. I'm gonna just
Okay, thank you. I'll click it.
Yeah,
I'm gonna add it to one of my playlists now.
I'm probably going to watch it tonight.
Okay, I gotta go, guys. God bless. Talk later.
All right, take care, man.
Peace, dude.
Come on, Funk. Come on, Bacon. Go, Larry.
Hey, what's up? Oh, what did you ask?
I said, come on in.
Oh, I'm here.
Oh, I know you're here.
So I'm not getting it.
I'm just asking you to jump in and start a discussion.
I don't usually start discussions. Just I prefer to go to the flow, and if there's something I think I can share,
You haven't got any riddles for us today, no?
well, if you want to.
I still didn't find out the answer to that because that was ages ago.
The chessboard? I can
Yeah,
explain
yeah.
it now if you want to.
Why not?
Alright. It's gonna take a while. I mean, if you don't have... Do you have any background in computer science?
No, I remember Kosho saying it was about binary, though, in the answer.
Yeah. It's more than that. Like, the only binary is just... Actually, you don't even need to understand binary. You just have to... I mean, for people from the computer science context, it's more natural to think of zeros and ones than to think of heads and tails. But actually, both work the same. If you replace ones with tails and heads with zeros, it doesn't make any difference. What really helps is that there's an algorithm for error correction used in computer science called the Hamming code or the Hamming algorithm. And this can be used to solve the problem. So if you know this algorithm, if you have a background in computer science, then it's much easier to explain the answer. But if you don't, then I just have to explain you the algorithm, which isn't that hard. I mean, I explained to people who don't know computer science before, so I might do it again if you want to.
It's up to you, man. I'm
All
not
right.
trying to put you on the spot.
Do you?
What
I
is-
think Arma was also interested. Are you here, Arma?
Yeah, I'm here. What are we talking about?
You're talking about the chess puzzle.
Oh, the chess puzzle. I mean, yeah, I guess if you want to explain, yeah, I'll listen in.
I'll have to draw a little bit because it's a bit complicated just to. I'm just speaking how the solution works. But the basic idea is this.
Hey, hold on, just real quick. So, is it a spoken riddle?
Oh, you're not aware of the riddle? I can explain it again if you want to.
Yeah, recite it.
Yeah. Go ahead and do that.
All right. The challenge goes like this: you're in a prisoner. I mean, you are a prisoner, and you and your friend. So you are two prisoners actually. And there is a challenge that if you can beat the challenge, you are free to go. And the challenge is something like this: the guards are going to show one of you a chessboard, and this is not a regular chessboard. Chessboard that can, every square of the chessboard can be used to hide a key, which is the key of your cell. So they're going to hide the key that opens your cell in one of those 64 squares on the chessboard. And they're going to show to one of you guys, let's say they show you where the key is. And after they do it, they're going to cover all of those squares of the chessboard with coins. And so every single square is going to have a coin above it that can be facing head or it can be facing tail. And this is unique. This is different for every coin. So every coin can be either head or tail, regardless of the other ones. So they can distribute any configuration of heads and tails above that chessboard. And one of those squares has the key below it, and you are the one who know where the key is. But you can't tell your friend. Your friend is going to have to guess where the key is. And you only have one chance. So he has to know exactly where the key is. Can't miss it. And the only way you can try to help him find out where the key is to choose one of the 64 coins and ask the guards to flip it. So if you choose a coin that is facing tails, they're going to flip it, and then it would be facing a head, and vice versa. You can't touch the chessboard. You can communicate anything to your friend. You can only choose one of the coins, and the guards are going to flip that coin. And then you're going to leave the room, and your friend is going to join the room, and he has to guess where the key is. The challenge is to find a strategy between you and your friend. So you and your friend had to come up with a strategy in which your friend can guess correctly where the key is every single time. And the only thing you can do is flip a coin. That's the challenge. Did you get? Do you understand it?
Yeah. Okay.
So it was argued that this is unsolvable. Yeah.
It's
At first,
I was gonna say it's definitely solvable, but like I think from like as a human, who doesn't know about like computer stuff and all that, or just doesn't know about like algorithms and all that. Yeah, it's gonna seem nearly impossible, but it's definitely possible though. I mean, from what I can understand, it really just comes down to like understanding like sort of like language written in the in the coins and whatnot. Like when I think about it, if you're always flipping one coin, right, to pretty much what's the word, to communicate that the key is under another square, right? Then with that being said, I'm thinking about this, right? Um, so okay, so let's imagine real fast. I'm not trying to get off whatever track, but imagine the key is in one spot, right? And it's always in that one spot. And let's say no, not always in one spot. Let's say it's in one spot, right? And then you have, let's say, one configuration of the coins laid out, right? It's just that one, right? And then obviously you have to choose a square or a coin to flip to say, hey, the key's hidden in this spot, right? So if I'm moving the key around, but that configuration stays the same, right, with the coins, all fucked, all like randomized, right? Then technically, I'm thinking about this. Technically, there's always a square in that configuration that technically lines up. Well, that doesn't line up, but that always. Okay, I can't explain. The point is, yeah, there's a language. I want to explain it better, but I can't really explain it. I'm bad with words.
Can I give a general explanation, and then you can say if that's what you're picturing?
Okay.
So the whole idea is to use a logic, like a certain way to read the board that points to one of the squares. So you're going to read like you're going to read the board, and the reading of the board is going to point to one of those squares. And probably, most likely, the square that this random configuration is pointing to isn't where the key is. And
yes, for me, it's a bit confusing. It's like, so the two prisoners obviously have a set code, yeah, that they know that they're going to use when whoever flips the coin, depending on the pattern, of the tails and heads or whatever. But what gets me is that the pattern of the coins could be random all the time from the start. So it has to be possible that whatever this pattern is to work out has to be possible every time with the so if you had a whole board full of tails, this method still has to be possible. If you had a whole board full of tails, it would still have to be. If you had a whole board, half a board of tails, half a board of heads, this method still has to be possible.
Yeah, the method.
I know. So it's like I'm just trying to narrow it down in that sense. Like,
yeah,
that's
the
what
method.
I was trying to explain, but I wasn't really good at explaining. I'm gonna probably get a visual real fast to explain what I think is kind of going on, or or whatever. But yeah, go on.
Yeah, basically it. It's just kind of narrowing it down, thinking of, if it, what pattern works every single time, what code works every single time.
Yeah, there are a couple of codes that can work every time. What you have to do is you have to come up with a reading that splits all possible configuration into 64 groups. Let's so you make a reading, you know what group that reading results, and at each one of those 64 groups actually means a square where the key is, and you have to split all the possible configurations in 64 groups in such a way you can always move from one group to any other group using a single coin flip. That's how you solve it. Of course, the hard part is to create a way to split all possible configurations into 64 groups that allow you to change from one group to any other group with a single coin flip. But that's the general idea of how it works. So you make the reading, this is group 3. So it points to the third square, let's say. But the key is on the 6th cell. So I have to flip a coin in such a way that the reading now is going to be of group 6, not group 3. And then when my partner reads it, he's going to know that it's on the 6th square. But of course, there will be millions of configurations that points to that same square. But you have to be able to get to one of them with a single coin flip every single time.
So you have to have that unique code.
Exactly. And one way to do it is to memorize the 64 groups in every possible configuration of each one of them, which is impossible for the human brain to do it. Yeah. But it is possible if you're using, for example, 4 square. You have a very small chessboard, only 4 square. That's much more doable. You can memorize like groups that point to first, groups that point to second, third, and fourth, and you can spread the configurations in such a way that every coin flip can either keep you in the same group in case of the key is already where the board is pointing to, or it moves you to another group, any other group. So that's a way that it's practical for a small board, but it doesn't scale very well. As you increase chess squares, it becomes impossible, humanly impossible. That's why you have to come up with a code, and that's why computer science becomes very handy, because there's something called error correction codes, which are basically, when you're transmitting information like in a wire, you're just oscillating the tension of the wire, and the other end is reading that tension as like high tension is 0 and low tension is 1, or vice versa. So you're sending a stream of bits or a stream of heads and tails, and sometimes there's some oscillation in the network. So your wire might have interference with something, and that might flip a bit. So you might be sending a 0 and it gets read as 1, and vice versa. And we don't want that happening, so we have to be able to correct for bits that were flipped. So what those algorithms do, that if you flip one bit, it becomes immediately evident that that bit is flipped. So it's an algorithm that points to a position that was flipped, and that's very helpful. But that's not exactly what's going on with the chessboard, because with the chessboard you
false flips.
Sorry?
So it doesn't highlight false flips, but it just determines when a definite flip.
Well, for example, you have 8 bits of information, and you want to send that. If I'm not mistaken, you have to add extra 4 bits to be able to use this code. So you're going to send like extra 4 bits, and when you read all of the 12 bits, if one of them is flipped, you can detect this. You can know exactly what bit was flipped.
Right, yeah.
And so what this algorithm gives you is a code that when you read that stream of bits, it points to where the error is. Which is not the same as we are doing the chessboard, because the guards are not going to use this code. They're just going to distribute randomly. But it's enough to use this algorithm, because whatever is that configuration, if you assume that that's a code being transmitted, you're going to find an error somewhere, and that's where the code is pointing to, which is not going to be where the key is. But now you can just flip a coin and change the error to be somewhere else where the key is.
I see.
If you want to see how the code, I can explain the code now. Let me share my screen.
Unless Copernicus is still trying to work it out.
Gee, thanks a lot.
Are you?
I mean, you.
Yeah, I'm following. I'm following the explanation. Go ahead.
All right. Let me get another mouse because I don't have the middle button on this one. 1 sec.
I mean, I'd imagine like for someone to come up on it on their own, it would be kind of tough. I mean, like because I feel like you kind of need to know that theory already, like in order for you to really kind of work with it. Otherwise, you would have to be like like a what's the word I'm looking for? It's not a
Yeah, you'd have
savant.
to teach your friend first, wouldn't you?
I mean, if you
Well,
don't, let me see.
when
But
I
see,
saw
that's the
this,
whole thing, right? That's the whole thing is that if you're if only one of you understands code, which one do you want flipping the, or which one do you want
no,
flipping the coin? Which one do you want?
you both have to know it because the solution for the challenge is the strategy between you both. So if just one of you know it, you have to explain to the other one.
Right. So okay. So here's my question that I had early on was, if you don't have the ability to communicate to your cellmate, that is, you can't tell him which one it's under. You're telling me that you both are given the information as to how the riddle works, and you do, and you both have to, or let's see, you're both given the freedom to discuss code
Exactly.
before the game is played.
Exactly. Yeah.
Yeah.
You
Okay,
have to
go ahead.
find.
Yeah, it's just your strategy.
Exactly. So let me share my drawing. Okay, so let me. Where do I start?
64 squares.
Well, that's gonna take a while. I mean, we can do a smaller chessboard. We can do a 2x4 chessboard. Let's use. Okay, I think it's best just to explain the error correction algorithm first. So let's just pick a random set of bits of. Yeah, let's use heads and tails. Okay, I have heads, tails, and head. This mouse is and tails. So I have this set of information, right? And I want to encode it in a way that if I flip a coin, I can know that the coin was flipped. So I have to add some extra stuff here. I can't just send this and expect the person to know where the coin is flipped. I have to send some redundancy. So what I'm going to do is I'm going to give a number to every position. So this is going to be position 1, position 2, position 3, and position 4. But because I'm going to need more information, I might have to be able to displace these coins to insert like some extra information in between. And actually, I'm going to need 3 extra coins to do it. So what I'm going to do is I'm going to add more 3 numbers there. Which is 6, 7, and 8. To add more 3 coins. So these 3 coins are going to be used as a control to ensure that this is correct. This is not flipped. So if I flip like one of the coins, when I read this extra 3, I will know that this coin is actually flipped. So one way to do it is
Wait, real fast. You're just teaching us the theory. You're not actually like this wouldn't actually. Never mind. Okay, it's just the theory behind it. Okay.
Well, this is the algorithm.
This is the strategy, yeah.
Yeah, it's the beginning of the algorithm. After you understand this algorithm, I can tell you how to apply that to the challenge. Because one thing is to understand the code, the other thing is how to apply that code to the challenge. Like, how do you combine 2 coin flips?
How do you apply the code to the chessboard?
Exactly. So I'll get there. Okay, So one thing is that these 3 extra coins have to be very sensible to any change in one of those coins. So what I'm going to do is I'm going to set the values of those 3 based on this configuration here. And each of those extra coins is going to be, let's say, responsible to store information about a different set of those original coins. So let me just pick a different color here, create groups. So let's say the first coin, which is this one, going to be responsible to store information about squares 1, 3, and 5. Okay, and then I'm going to use the coin number 7 to store some information about the squares 2 and 3. And I'm going to use the coin number 8 to store information about squares 4 and 5, right? Okay, so how can I store information about the coins using a coin? Oh, I can just count, for example, how many tails there are in the group, and if it's even, I put heads, and if it's odd, I put tails. So I can tell whether or not the amount of tails is even or odd, just looking by those coins. Are you guys following?
Yeah.
Right. So let's do this. Let's fill these coins with this extra information. So let's see the red group. So the red group has a single tail, which is an odd number. So I'm going to put a tail there, to point to an odd number. Group 7 has 1 T as well, 1 tail. So also going to put a T there. And number 8 also has 1 tail. So I'm also going to put a T there. So
Right.
there you have it.
Yeah, because it. Wait.
Exactly. What you can realize is that every coin is covered by the different set of these extra coins. So this coin here is only covered by this coin. This coin here is only covered by this coin. This one covered by those 2. So every single coin has a different set of extra coins that. Sorry?
They all have a unique identity.
Yeah, they have a unique group of extra coins taking care of their information. Okay, the way we now can detect if any of those coins get flipped, let's say the square number 4 got flipped. Or even better, I think number 3 would be a better example.
Yeah, let's just go with that and just kind of work through it and see.
I'm going to pick 3. So I'm going to replace his head by a tail. So let's suppose the information got flipped in the path.
2 tails would make an even number, which
Exactly.
having the T in 7 makes no sense because it's saying we have odd, but we really have even.
Exactly. So when you're looking to the red group, you see that the tail says odd number of tails, but actually there are 2 tails. So there's an even number, not an odd number. So you know this group was affected by the bit flip. So we can mark that there's something wrong with this group here. And let's look at 7. So it's a green group. There's also 2 tails, which means an even number. So it should be an H here, but there's a T. So 7 is also affected by this bit flip.
So blue is the only one that isn't affected. So
exactly, and blue is fine.
That's how you lock down which one it is, because both red and green were affected, and the only one that matches red and green is that T right there.
Exactly. Yeah. Exactly.
Yeah.
It's
like the thing the video I watched about the theory you talked about, the correction thing. It's just like that.
Mm-hmm.
Yeah.
Exactly.
It's ingenious,
so,
honestly.
Yeah. So what would happen if we add like a 0 coin here, coin number 0, that is, let's say, tails, but there is no group that takes into account this coin. then if I flip this coin, there's no way to know this coin was flipped because the information of this coin is not being stored anywhere.
Yeah.
So it's not going to affect those extra coins. Therefore, this would be a useless coin. The information of this coin is going to be completely unreliable. But all of those ones, I can trust them. Because if they got flipped, I'm going to instantly know which one was because the groups of that coin are not going to match the information that those coins are bringing.
Mm-hmm.
Right? So that's why in error correction code, we don't start with a 0. We start with a 1 because we use these values to figure out what groups they're part of. Okay, so, but now I'm using colors, right? That's not a very scalable way to do it. Otherwise I will have to memorize like where this group is in all the chessboard, where this group is on the chessboard.
Mm-hmm.
So in a chessboard, I would end up with, I think, 6 groups or five groups.
A sizable group for sure. Yeah.
Yeah, I would need 6 groups to solve the chessboard problem. And this will be very hard to memorize. So there's a more systematic way to distribute these groups. Which is, let's forget that they are in the end of the stream. Let's put them mixed in between the information here. So this is useless. And okay, so we have all these numbers, which are the number, like the identification of the square. And one thing that is unique about every single one of them is that every single one of them is a sum of different powers of 2. Yeah. So a power of 2 is like a number that you get just by doubling 1. So if you double 1, you get 2. If you double 2, you get 4. If you double that, you get 8. Double that, you get 16. Those are all powers of 2. And every single integer is a different sum of powers of 2. So 1 is just 1. This is a power of 2 itself. 2 is also a power of 2. But 3 is actually the sum of 2 and 1. So this is 2 plus 1. 4 is just a power of 2. 5 is 4 plus 1. So the same way before we had a different set of colors for every number, now we have a different set of powers of 2 for every number.
Oh,
right?
Okay. I like
So, yeah. So now we just have to use some coins to represent the powers of 2. And one way to do it is just to put the coins exactly where the power of 2 is. So 1 and 2 now are not going to store this information that we're sending. It's going to store that extra information that stores the parity of their own groups. So now I can't put the information there because they're going to be used to store the redundancy. So now I need some extra numbers here. For a while, it's 6 and 7.
And real fast, I mean, I'm sure this obviously covers it because I mean, it wouldn't be a solution if it didn't cover this. But I forgot how they accounted for a bit flip if the bit flip is the actual, the end. Like
right, yeah. That's a very good question. It still works. Let me show you why. Well, let's go before the bit flip.
Would it just be like kind of reverse where you look at the other bits and you realize that like none of them have any actual like errors I think I kind of see a solution to how to figure that out.
Yeah, well, actually, if you flip, for example, the bit number 7, you would think the error is here, right?
Yeah. But then I can check it against the others and be like, wait a minute, okay, so.
Trying
to see. So if you put it, let's see.
Yeah. No, it wouldn't work like this. That's why I'm going to change things a little bit.
Oh, okay.
So So it doesn't work to figure out an error here because we're just looking. I mean, we're seeing this as where the information is, and we are seeing this as something extra, right?
Yeah.
So we're not considering that this can be mistaken. So in order to consider possible mistake here, this should also be part of the information. And that's what we are going to do now. Because now I'm going to put these numbers in their own powers of 2 and consider that they're actually part of the information. So now even if they get mistaken, you can get the error pointing to themselves. So let me get there. Oh, I can't just redo because I changed things. Oh, no problem. Yeah. Oh, this be quite quick. Just this and this. Okay, so first thing I did was to shift this to this position. And because 1 and 2 are powers of 2, but 4 is also power of 2. So I have to leave this house free again.
Yeah, it was
Where?
1, 2, 2 plus 1, 4, 4 plus 1. I wonder how that's.
But the problem 8 is also a power of 2. So actually now I'm going to need 4.
Ooh. Hello? Did he crash? Oh, that's me. Never mind. Hello? Am I there? Can you guys hear me?
Yeah, I can hear you. Yeah.
Oh, so was it Bacon then that crashed? Or it lagged out? I'm assuming it's Bacon.
Yeah. Yeah, he's not here now.
Oh, jeez. What happened?
Can I?
Could be this. Oh, hello.
Sorry, my battery died. But I'm back now. Are you still seeing the live stream?
Yeah.
So what were you saying?
Oh, me? No, I was just kind of just wondering how it would scale up, like the whole, because you had it where it was like 1, 2, 2 plus 1, 4, 4 plus 1, and that was kind of a way to sort of, I think, differentiate them. I think, I don't know if that was kind of, like the groups or whatnot. But if that was the groups, though, I wonder how those groups would scale up. Like because
They scale up as much as you want. Every number is a unique set of powers of 2. And for example, before getting to the numbers that are sums of 8 plus something, you need to get to 8 first.
Yeah.
For example, 9 is 8 plus 1, but to get to 9, you have to have the 8 square here, taking care of that point.
But I guess what I meant was like scaling up the actual groups, like scaling, like having more groups is what I'm saying. Because if we're defining, I don't know how if I'm correct about this, but if we're defining the groups by between either powers of 2 or like like a 2, a power of 2 plus 1, then that would only be like 2 groups, because you only have the powers of 2s, and then you have the powers of 2s plus 1, like 9 or plus 2 or whatever. Well, then again, maybe the plus 2 would be its own little group thing.
The colors would be analogous to the powers of 2. For example, number 6 here is 2 plus 4. And if 2 is green and 4 is red, then 6 would be the only that is green and red only.
Okay.
Oh,
well, I mean, I guess I wanted to see, like, because right now with that example, that would be, I guess I'll just see it. I'll see it when you do it. Yeah, just I guess keep.
Yeah, I can use colors again to make it visual. So I'm going to pick 1, be my red group. So every number that has a 1 in their sum is going to be considered to be part of the red group. So 1 is one of them. 1 is a sum of 1, and that's it. 3 is plus 1. This is 4 plus 1. This is 1 plus 2 plus 4. And this is 8 plus 1.
Oh, okay. I think I'm starting to get it now. Okay.
Alright. So let's use green for 2. So 2 is just 2. This is a green part of green group. This is 2 plus 1. 4 and 5 don't have 2.
6.
But 6 and 7 do, because 6 is 4 plus 2 and 7 is. So it creates this pattern where first you have 2 coins, and then you don't have 2 coins. Then you have 2 coins again. You don't have 2 coins anymore. And the 4 group is going to have like 4 coins with this group, 4 coins without this group. 4 coins with this group, 4 coins with, and this goes on. Let me just connect, create this pattern. More nice.
Yeah. Yeah, okay, that's pretty cool.
And now there's group 4. We use blue. From 4 to 7, they are all 4. And that's, oh, and number 8. Number 8 now needs its own color. Don't peak this.
Oh, and that's why there's like 6, because it goes 1, 2, 4, 8, 16, 32. Yeah, there you go. Okay, that's why there's 6 groups, because you go up to 32, and I guess 32 is the last group, because 64 would start the new group, but because it stops at 64, I guess that would just be it. That would be the. Or,
no, I mean I'm going. Yeah, that's a good observation. Like, why doesn't it have a group for the 64? Well, but actually we don't get to. We start at 0. And why we start at 0? I'm going to get there.
Yeah.
We are going to need a useless coin for the chess puzzle. Okay, so let's do this way now. Okay, so let's check what's the parity of what if one needs to be heads and tails. Well, I don't have coin for 1 yet, so I'm going to look to the other one. How many tails do I have in the red group? I have 2. So let me put heads here. It's an even number. The green group, I have none, which is also even. 4 group has only 1 tail, so I'm going to put another tail here. And 8 group, which is the yellow, also have 1. So I'm going to put it.
So sorry to start this whole convo and then end up leaving, but I will be back. I'll be back soon.
All right. Well, this will be recorded. Right? Oh, we want live stream doesn't get recorded.
Yeah.
Well, I
can pull it back if I need. Yeah, I'll slip it back.
All right.
All right. Speak to you in a bit, guys.
All right.
Yeah. Alrighty.
Didn't. Now I fill the entire stream with the extra information. Now let's pick an error. Change number 5. See if it still works. It was tail. Now it's going to. So now when I'm doing the reading, I'm going to check 1 is okay. When I count an amount of tails in the 1 square, well, the way I can do it is just I don't look to 1, I look to the other one, and I see if it matches 1. Or I can count with 1, and it has to be head. I mean, it has to be the amount of tails must be even, because when it was an odd number of tails, if I add an extra t, it becomes even, right?
Oh wait, hold on. Okay. I don't know if anyone else, whatever, but I kind of not dozed off, but I had to do something real fast. Can you go back like 30 seconds maybe, or like
sure, no problem. Sure.
Yeah. Sorry.
So okay, so I flipped the bit number 5.
Okay.
So I had a tail there. Now I have a head. And when I was setting up number 1, what I did was I was looking at every other red square to see if there was an even number of tails or an odd number of tails.
Yeah.
And if there's an even number of tails, I put an H, which makes the red group still have an even number of tails. But if there is an odd number of, I have to put a T, which now makes the number of tails in the red group even again, because now there is an extra tail, saying that the rest of the group has an even number. Has an odd number.
Yeah.
So an odd number plus 1 becomes even, and an even number plus 0 still even. So all of the groups should be even after I do it, right? Because if it was odd, I would have to add the tail and it would become even again. So that's one way to know where the errors are. So I'm going to just count the amount of T's on the red group, and it must be even. So there's one T here, right? There's a single T in the whole red group, which is an odd number. There's something wrong with one. Detected an error in the red group, which we know is there because we flipped 5, right? Flipped 5, and that created a mismatch in the red group, because 5 is part of the red group.
Wait, so hold on. So pretty much now, because I think this is what you were saying before, where we're going to find the error number like within the thingy, right? So one would be the pretty much that one, that sort of the error thingy that kind of tells you what's wrong with it or whatever, or are we kind of like, or we're kind of like just trying to figure that out pretty much, where it's like, one is kind of always kind of like definitive, and so if something else is fucked up with the rest of it, then we know there's an error or some shit. Is that what it is? Maybe I'm understanding a little bit more.
Not sure. Well, these special squares here, I'm gonna call them the parity square. So the parity squares are starting the parity of the tails of their own group, right? So number 1, which represents the red group, have heads, there's an even number of tails, and a tail if there's an odd number of tails. And this forces the whole red group to become even, right? Is that clear?
Okay, I'm sorry. Say that again. Because my brother was kind of messaging me. I'm sorry. Okay.
All right.
Yeah. Okay. So let's go again. Sorry.
Okay. So number 1 has the parity, has a tail. Say that the rest of the group has an odd number of tails.
Yes.
And has a head if the rest of the group has an even number of tails. So this is going to force the whole group to always have an even number of tails.
Okay.
And this is the same for every group. So if I do the same for 2, then the green group also must have a even number of tails.
Right. Yeah.
So is the green and yellow group, right? But so if it isn't even, it means there was a bit flip in one of the red squares.
Yeah.
In the red group, which because we did on 5, and 5 is red group. But if we check 2 has no tail, so 2 is still even. So there was no flip in the green group, because if there was, it would become odd. So 2 is fine.
And then for 4, it says T, but T is the one that's causing it to be T. So T is right.
Exactly. So it's
okay. That's pretty interesting.
Yeah, exactly. So there's an error in 4. So something got wrong in the blue group, because if I flip any coin of the blue group, including 4, this would fix it. Which means that this is not the original configuration. One of those 4 has to be flipped. But because it also affected 1, also one of those red ones have to be flipped. But we know 2 is fine. So 2, the green group wasn't flipped. So the only square that this can happen is square number 5. Because it's the only one that would affect the blue, and the red group only. Because, it's
both of them have
blue and red.
All right.
And 8 is also.
Yeah. So I think we more or less we get like the theory behind it. And by the way, you're doing a really good job explaining it all. But with that being said, I do think though people are kind of just waiting for like the actual solution to be done with like 64 by 64. Have you done the 64 by 64 before? Or not 64, the 16, no, 8 by 8, 8 by 8, or the 64.
8 by 8.
Yeah, 8 by 8.
Yeah, well, I did 8 by 8, like using an algorithm, like I coded it to test like thousands of possibilities, see if the wall was going to work, and it always all of them worked. But like in person, using like actual coins, I did with 2 by 4, so I did with 8 squares.
Could
something close to.
So let's say in the problem, with the whole prisoner thing and shit, right? If someone wants to do this in person, how long would it take for them to actually go about doing it, or is it actually not that like long?
Yeah,
Like,
well, some minutes.
It take
like,
a while, though.
Yeah, some minutes. Yeah. Well, we have some minutes. So for example, you look to 1, then you count 1, ignore 1, count 1, ignore 1, and then you see if that matches. Now you you just use a finger on your hand to remember that 1 is matching or it isn't matching, for example.
Yeah.
And when you're done, you only need 6 fingers to do it. So when you're done, you know exactly where the error is. But of course, the error doesn't mean anything because the guards put the coins. So, so what? I found an error in this house, in this square, but I know the key isn't here, the key is there. But I have to communicate that to my partner. Yeah. So what can I do? So that's the solution. The solution is to what other coin that if I flip is going to change the value of the groups in such a way that now point to the key. So my partner is always going to have an easier job than me. So the first person has the hardest job because he not only have to read the board, but he now has to find combination between that reading and another coin that points to the key. The second person does have to read the board, and whatever the error appears to be, that's where the key is.
Yeah.
So how we communicate that to our partner. So let's say that's our board.
Uh-huh.
So yeah, I'm going to start.
Yeah, let's make this. Let's make this. Yeah, like the end all be all. Let's see how this works. Now I want to really see this in action. This will be interesting.
Hey, just real quick.
Mm.
I think this would have been an amazing scene in Squid Game.
Squid Game. I mean, I don't even know.
Everyone would die.
Everyone. I mean, like, yeah, this is kind of like no one's really figuring this out. I mean, I don't know.
Just real quick, I have a question. So the chessboard normally only has 2 colors. So because I'm not watching what you're doing, I'm only listening. How do you determine the colors that you're using, like red, green, purple, blue?
Yeah, the colors are going to be the sums of the powers of 2 of the square number. So if the first square is square number 1, the 10th square is square number 10, and 10 is a sum of 8 and 2, right? So there's the group number 2 and the group number 8. So instead of colors, we are using there's a color for 2 and there's a color for 8. You can choose whatever color you want. Yeah. But as long as 2 represents a single color and 8 represents another single color, that would work the same. But you don't have to think of colors. You can just use the number right away.
Yeah.
Are you all right?
You go.
Yeah. Or you don't even have to remember what number is in the beginning. You just have to find the powers of 2, and then you count that number of squares and jump that number of. Skip the number of. Count that number of squares. Skip the number of. You don't have to keep doing the sums of powers of 2 all the time. You just have to find where the powers of 2 are, which is quite easy, and then you just count like that. It's much easier than trying to decompose the number into powers of 2.
And the short of it is, if you really want to like break it down, just know in the chess example, there's 6 groups. The 6 groups um are going to be defined by 1, 2, 4, 8, 16, 32. So you have a number, let's say 33. That is 32 and 1. All right, so that goes in both the group 32 and the group 1. If you want to do it that, if you want to like really break it down and make it super simple, and you do that with all the numbers, like if they add up, if your group numbers add up to that number, then it's within those groups that it's made up of. All right, that's how you would organize it. I explained that really badly, but I mean, I think I got
I got it. But you don't have to. You never actually have to break down like number 47. What sum of powers of 2 is? Well, at least the second guy doesn't have to do it. You might have to do it. But you only have to do it after you finish the reading. You don't have to do that during the reading. The reading is just like, oh, okay, let's check power of 2. I'm going to count 2, ignore 2, count 2, ignore 2. Now let's do power of the group 4. Let me count 4, ignore 4, count 4, ignore 4. So you don't have to do this calculation of what are the powers of 2 of this square. You don't have to do that. You just count like this. After you're done, then you only have to do it a single time for the position, the keys, and for the position, the array.
I want to real fast. I want to real fast see this in action because you said before, like, what if the guards can kind of like mess around with the board, and they could in theory add a bunch of errors. You know what I'm saying? And so I want to see. I'm pretty sure that as you're looking through it, and as you go to solve it, it's more obvious.
But this algorithm only points to one error always. Let me show you what happens if you try to make 2-bit flips. So let me fix the stream again. So I'm going to flip 5.
Yeah, like give us just give us like an example. I want to see this in action because like usually
Sure.
it becomes evident when you actually go through it.
Yeah.
It's like that was obvious.
Yeah, but it's hard to show the action too soon. Otherwise, this might get very confusing. The best you have.
Well, I mean, like at this point, I think people are just kind of waiting for it to be over. I mean, I was invested. I liked it, but I mean, I'm pretty sure,
Well, but I tried to, for example, I think with Geo, when I was explaining to Geo, said like, well, just give me a summary of how the enter goes. And I tried to do it without explaining this algorithm, and I don't think I did a good job explaining it. So yeah, let's insert. Well, you want to see what happens? I mean, this is crucial. If you understand what happens when you have 2 errors, now you're going to understand how to combine errors. So yeah, we had an error on number 5. We can just leave that. Let me just put an H. This is much. So I have again an error number 5. So if I do all that again, I'm going to end up like, oh, there's something wrong with red group. There's something wrong with green group, blue group. So it's 5.
Mm-hmm.
Okay. Now what happens if I have problem? If I flip also number 3, what happens if I flip number?
All right, let's see. We got number 3.
Okay.
It says 2 is H, which is going to be even. But
hey, so I'm gonna have to bail out in a couple of minutes, but I have a real quick question. Megan, did you create this?
No, this is a known algorithm called the Hamming code.
No. I mean this riddle.
No.
Oh no.
Okay.
Oh, sorry. I'll have to be right back. I mean, I have to go for a while.
Kosho was pitching this. Kosho was going through this jail thing with the guards and shit a few months ago.
Yeah, just real quick. I'm curious. is there a video that does this, that walks you through this? And then secondly, does this exist like as an app? I think this would be absolutely fascinating, almost like the game Minefield or whatever that was. You know, where you try to determine where the mines are.
Yeah.
I would be completely, absolutely.
Well, I can create this app actually. I mean, I
That
can
would be
create a web
amazing.
page.
That would be
Yeah.
amazing.
All right. Yeah, I can do it. But I don't think there's an app. But there is a video that explains what I'm explaining here. It's a 3 blue 1 brown video. The problem is it doesn't present this as a challenge because the solution of the puzzle is right in the title. Like the title is like error correction, something like this, or Hamming code, and then he presents this riddle. So that's why when I saw it, it wasn't funny because solution was inside. I just had to come up with a way to use this algorithm to solve it, but I already knew the algorithm, and I already knew the algorithm was the solution. So I had 80% of the job done already. Anyway, I gotta go. I'll be right back. I'll go on from this point. Oh, or you can do it and tell me where it's pointing to. And if you want, try to figure out why it's pointing to that square instead of 5. I flip 5 and I flip 3, right?
Screen this.
What that results. Be right back.
Alright, I'm gonna try to figure this out. Alright, so let's see. If you guys want, you guys could talk about whatever. I'm just gonna real fast mute myself so I can try to figure this out. Whoop. All right, according to the algorithm, it should be under 6 if I'm correct. So I'm going to put a T under the 6. Let's see if it reads out correctly now. So red says even amount of T's, which we do. Green says there should be an even amount of T's. If I put the T under 6, then there is an even amount. All right. Under 4, it says there should be an odd amount of T's, which the 1 under 6 would be odd, and then 8 says there's an odd amount of T's, 9 being the 1. Yeah, all right. Yeah, the answer is 6, guys. Interesting. I'm going to try out mine now.
Hello.
Hello.
What are you? Yo. What's
I'm
up,
just
man?
trying to figure out this algorithm thing real fast to see how well it works with my current understanding of it. Which is kind of tricky. So I'm just trying to
What
figure that out.
algorithm thing?
It's the chessboard like thing where there's a key under one spot, and so you have to use like an algorithm to sort of figure out which square it's under, the key for your prison cell. I don't know if you heard of it, but it's an interesting little puzzle, and you need to know an algorithm for it, for you to solve it.
Alright.
Yeah. So that's what's going on right now. I'm just trying to figure out because it's not. I don't see it. It's not that I see a hole in it. Obviously, there isn't a hole. It's just me not understanding it. So I'm just trying to figure it out. I'm trying to
You might
understand
want to
it.
check with Kosho on this because he literally was doing this like a few months ago.
Yeah. Maybe I'll check up with him. But until then, though, I think I'm just gonna try to figure this out.
Check out with caution. Where are you solving this riddle? Where are you doing it?
Me right now? No, I'm just trying to. I'm throwing in random numbers right now just to test it. Just to put the algorithm to the test, and I'm trying to see it because like right now, like I'm flipping some of the error correction numbers because there's like in this algorithm there's like one number or one bit that pretty much tells you if something is right or wrong, right? But if that is flipped itself, then you don't know if it's right or wrong, and so I'm trying to figure out how that's corrected for. So I'm trying to figure that out. I'm trying to take this apart to see if it still holds up after fucking with the error corrected number or the error correction number. It's a slippery algorithm. It's pretty tricky.
Are you talking about like what is it? Coins on a chessboard?
Yeah, that whole
I don't know.
Yeah. That says odd. Okay. Green. Try to figure this out. Okay, I think I'm starting to get this now. Okay, I flipped one of the numbers, the ones that tells you if everything else is wrong, and pretty much what it comes down to is everything else is right, but that one. So you have to pretty much say to yourself, okay, never mind, the error correction, the number that usually error corrects, whatever, right? That one is the incorrect one here. So this is actually pretty interesting. This is a pretty neat algorithm. So I'm real fast trying to do this with two of them now. I'm trying to two error corrected numbers. All right, yeah, I got this. Whenever Bacon comes back, I'm gonna real fast give him a random set of bits, and then I'm gonna have him pretty much hide the key, and then I'm going to decode it, and then that'll show him that I understand it, and then bam, we're done with this topic. And in the meantime, though, does anyone have anything they want to talk about unrelated to this chessboard key thing? Nope. Let's see what you guys were talking about earlier. I mean, do you guys want to talk about let me see. I don't know. Horizon or some shit. I mean, that's what we usually talk about. The fucking shit looks flat, or I don't know. Man, you guys aren't making this easy.
Are you a flat earther?
No, I'm not.
Alright.
I'm the opposite of a flat earther.
That's just so.
Thick Earth. Earth is thick and round.
Earth, thick around, massive.
Yeah, it's a massive Earth.
Massive Earth.
Yep. Let me see. So you know what? I heard this one relatively recently, as in like literally today. Although they didn't really go into it. The whole 8 inches per mile square thing. I know DMOC likes to no, he doesn't like to, but he's argued this before where he's saying, well, it should curve at that rate, and that's that's correct, but he's thinking about it in a different way where pretty much things should angle at that rate, which first off, that there's what do I get for, like, how do I even quantify how much something should angle at that rate? That doesn't make any sense. With that being said, a lot of flat earthers believe that once something disappears behind the curve, that it should also be tilting away, which is fair. By how much, though, is what you guys don't really say. You guys just say it should be tilting away. And I have a lot of issue with that because you guys aren't quantifying anything with that. You're just saying it should tilt away. With that being said, I've said 1,000 times that it should tilt away based off of 69 miles a degree. Yeah. So after every 69 miles, it tilts 1 degree. All right. So you're not going to see any tilting. So if you see a boat go over the curve, it's not going to tilt anything. You're not going to see it with your bare eye. It's going to tilt. We're talking literally like 1 degree. Does anyone disagree with that? I know if DMOC was here, he would disagree with that. Like, no, you should see the boat tilt away from that's how he talks, right? But that's what he would say though. He would say that that the boat would tilt away. Does anyone agree with that? Anyone? No? Come on, you guys are flat earthers. I mean, some of you guys have to believe in this shit. Oh, never mind. I got Lisa's a globe earther, so never mind. Okay, Jeremy's a flat earther.
Yeah.
But that was my DMOC impression. I'm not the best at impressions, but I did my
Yeah,
best.
you sounded nothing like him. It's okay.
I mean, I was doing like the way emphasizing words. I feel like I want a cup of light. Give me a cup of light, or give me a cup of gravity. That's how he does it. Like he talks like that. Like, I don't want to hear your bullshit. All right, give me a cup of light. That's my impression. I'm not good. Anyway, I don't know. That is fucking bullshit. Cup of light, my ass. What is Jeremy doing? Jeremy? Wanna debate, man?
He'll probably playing video games or some shit.
Damn it! How about Copernicus?
Jeremy's retired.
Fusili. How do you pronounce your name?
Why are you looking for a debate though? I don't get it.
Because I mean, why else am I here? I mean, I'm here to debate. I'm here to.
But it's pointless to debate with you guys, though.
No,
You're
it's
intellectually dishonest.
Jeremy, you're breaking up. You're roboting.
Not me.
No, you are. You Globers are into. Yeah.
I'm not.
The Globers are intellectually dishonest.
Why am
I pointed it out to Nate. Nate's seen it.
I'm a Glober, but I'm not dishonest. I'm telling you, I'm
And I'm committing a stereotype fallacy, and I'm putting you all in this box of intellectually dishonest.
Oh, that was fucked up, man.
Sorry, bro. You ever heard guilty by association?
Jeremy, is it me or is Jeremy breaking up?
You ever heard that phrase?
Have you heard of a better Wi-Fi?
I'm breaking up. I'm driving and I'm in a bad spot. Obviously, this is not my house Wi-Fi connection.
Okay, fair.
So, have you ever heard the phrase "guilty by association"?
Yo, fix your data plan then assumption, bro. God damn.
I'm still lagging.
Yeah,
There's
dog.
nothing you could do. I got AT&T, bro. It's where I'm driving. I'll be back. I'll be back later.
Yeah. That was horrible. Yeah. So what are you into, man? Like, what do you do? What's your face? Arma.
Oh, what do I do? I'm an artist first. I mean, I do this just flat earth debate shit second, you know.
Yeah.
No, actually, maybe third. Actually, I'm an artist first. Then I'm like logic math guy second. All right, that includes like games, like game design and shit like that. And then I'm a debater third. There you go. So yeah, I don't know.
Okay.
That's mainly what I do.
Is my mic better?
Well,
A little bit. Keep talking.
Yeah, I still got one bar. I don't know what's going on. I'll be back.
Oh, it's doing better now. Okay.
Yeah, that was better. Yeah.
Okay, first of all, your boy's not an artist. He draws dick pics all day. So that doesn't. You ever see Superbad?
Jeremy,
you ever see the beginning of Superbad?
Yeah.
Where he had the dick drawing disease?
Yeah.
Oh, I'm breaking up again? You ever see the beginning of Superbad?
Oh, Jeremy's bad stuff.
Come on.
It's horrible stuff, bro. Just get home, focus on getting home.
Yeah. Anyway. Yeah. Yeah, I do art and all that. I do game design.
But I mean, do you really just draw dick pics though? Like,
no, I don't know what the fuck he's talking about.
We're not gonna act like Jeremy didn't say that.
Have you ever seen the beginning of Superbad?
Yeah.
The guy where the guy couldn't stop drawing penis.
Everybody here know you're gay, Arma.
I like how that's just.
Remember the kid.
Jeez Louise.
Remember the kid couldn't stop drawing pictures of penises?
Yeah.
Armbar got that.
It's in Superbad?
Yeah.
I knew a lot of kids that did that. I mean, like, they just do dicks everywhere, you know what I'm saying? Like, yeah, okay. I mean, it's a little funny, but, like, I never did that, you know what I'm saying? It just goes to show you, like, maybe everyone else is gay, you know what I'm saying?
Get out of your closet, Arma.
No, I'm not gay.
Stop being homophobic, Armbar.
It's nothing to be ashamed of.
Yeah,
nobody's judging you here except all the flat earthers.
We love you the way you are, bro.
Oh my goodness. Anyway, you guys are funny. You guys are pretty fucking hilarious. Anyway, yeah, I don't know. I've done a lot of a lot of coding stuff for the flat Earth debate shit. A lot of maths.
What do you mean?
You know, because flat earthers don't like the maths. You know.
Mm-hmm.
So I've done a lot of that. Like I did this one where, because you know how like I don't know if you heard this argument, but there's an argument where you have like 4 points, like on United States, like they're all
Hey,
like
can I make a
spread
point
out.
real quick? Can I make a point real quick?
Yeah, sure.
It's not that we don't like math. It's that we don't need math to prove our point, right?
You can also hate them as well.
So that's not a strict caricature.
Okay, fair enough.
But you guys really don't like math, though. Like,
You do really hate
it's
math.
so rare. It's so rare to see a flat Earth that will actually do some math with you.
Yeah, I don't know.
No, how many flat Earthers have you done math with, Arma?
You know, what you mean? Like they actually worked with me, or like I've just done.
Yeah. They said they sat down and worked with you to prove
Not
something.
a whole lot. No, I'm gonna be honest. There was like 1 or 2, I'm sure, but I mean that's it. You know, it's not usually. Like,
Well, maybe it's the same on the globe.
That's
Would you say you've had more? Yeah, actually, I would say it's both sides. I think both sides actually hate the math. You know, come to think of it, I've never sat down with the globe that's been going to actually do flat Earth math. They all just use calculators. You know, they don't actually do it themselves.
Fair. Yeah. I mean,
Yeah, but
I don't know though.
I mean, doing math isn't not using a calculator.
So Arma, have you
I
done?
know.
Arma, have you done any math in regards to refraction and mirage?
Oh no, I'm not gonna lie. I don't touch that shit because I'm not knowledgeable enough. I just do like some basic shit. I don't touch that. No.
All right, that's fair. I was just asking.
Guy named Fug, he made a simulator in Python using where you can plug in the indices, and it's based on not the Snell's law, but what Snell's law derived from, which is Euclidean equation.
Is it that one where it's like that 3D kind of like sphere that you can kind of like do things with the distances and shit, and it's like but it's like lines and it's like 3D.
It's a differential equation which you solve for or to simulate to solve it. Snell's law is only applicable for where you have like one layer and then another layer, and then you have meeting at the border. But if you have a continuous fluctuation, then you need another function.
Listen, are you talking about Howard or Walter Bislin?
No, another good guy.
So Walter Bislin actually says that Snell's law has fuck all to do with atmospheric refraction.
Yeah, you can't use that for atmospheric refraction because it's not the function for continuous changing indices. So you can use that. It's only for like having like air to water or like going through glass or something.
Right. So do you have a link for this other guy that you're talking about?
Yes, he has a YouTube channel which I can find for you where he sent this.
Put that in the chat, please.
Okay, I'll ask him if he wants to share it on the chat first.
They made up refraction based on the globe model. It's all ad hoc.
Oh yeah, the flat Earth is.
Oh, we know that we know that the globe's bending. We know that the globe's bending this much, so therefore we know that the light's bending this much through the atmosphere. It's all ad hoc.
Hey, Jeremy, lay off on the Latin, okay? We don't need that kind of hoity-toityness here, man.
Wait, Jeremy. So you think we just created refraction to go along with the curved surface?
This refraction that this guy's about to find, yes. The real refraction, no. This new refraction that's not Snell's law, that's some other shit, yes, made up.
So refraction only deals with Snell's law, nothing else.
No, I'm not saying the light's not bending through the air. It definitely is. At what rate, though, has been made up by reverse engineered to match the globe model.
Preach it, Jeremy. Preach it, man.
Well, what does Snell's law say about refraction that, you know, this
It doesn't
quote
matter.
unquote new type of refraction is violating?
It doesn't matter what
Snell's law is legit. Yeah, go ahead, Travis. Go ahead. I'm lagging.
Yeah, you lagging.
Yeah, so like Jeremy said, Snell's law is legit, but it has fuck all to do with the atmospheric refraction.
Why does it have fuck all?
Well, if you want to consult Walter Bislin, you can see that he will, he'll say.
But I'm asking you.
Listen very carefully, please. I'm going to paraphrase it. So if you want to check Walter Bislin, he'll give you a more specific answer. Snell's law requires a boundary. The atmosphere has no boundaries.
That's what I told you. That's why I told you use a different type of equation.
Hold on, Funk. I'm simply answering the question that was asked of me. That's all.
See.
Yeah, it's called the Euconial equation, which you can use.
Yeah, I'd be interested to see if Andrew Thomas Young uses that phrase at all in his papers.
I don't know. Like, I think you can simulate it many ways. Euconial equation is one way to simulate. It's a way to simulate wave propagation, but to have the actual way that it propagates, you need to have the data from tests, which you get a type of indices from. So you can, for example, have functions for how pressure, or a function for pressure over height, and then use that in your equation, and temperature as well. And then if you have like a model for the different indices, then you can propagate that using Euconial equation.
Will you type out the name in the chat, please?
For the
for the term, for the equation or the term that you're talking about.
How do you pronounce that? Econol. All right, don't help me out here.
I think that you use it in many things. They use it for like, yeah, you can use it for all waves. It says here, application is like radio wave attenuation in the atmosphere, geometric optics, continuous shortest path problems. I guess that's like more related to geometry stuff. Yeah, some other shit.
Do you see these applications being made in large distances or just in short laboratory, classroom, clinical examples?
This simulation, if you simulate, you can simulate as far as you want to.
I'm not interested in simulations. I'm interested in making observations in refraction and having data to establish any information.
Oh, you mean how much data they have gathered on the indices? Then you need to. That's separate from this equation. So
Travis,
how
the
you?
problem is you're never going to get anywhere with just observations. You know, you can look at something and now it's moving here, it's moving there. What does that tell you, though?
Well,
about the actual.
That's what I'm saying. Like if they're doing these measurements in a classroom where they're creating a model of something, right? But they don't have any field data where they're doing something like you're talking about. Okay, I'm going to go out and shoot this mountain range across the Bonneville Salt Flats and take measurements. Right, you're right. Observations only get you so far. But if they don't have any data on this out in the field regarding long distance observations with refraction, then it's useless.
Yeah, of course you need the data. As I said earlier, you need the. This is only a mathematical tool. Then you also need to know how the light actually behaves in the atmosphere. But you can't use Snell's law, calculate like continuous wave propagation is problems with Snell's law.
Yeah,
this is like built for more simple things, like going through like glass or something.
Yeah, I mean, I think you can describe what you think light will behave like based on a clinical classroom setting, but I don't think you can then take the numbers that you get in the classroom and then apply it out into the real world where those conditions don't exist.
Of course, if you're going to test it, you've got to test it against real world problems.
How would you test it? How do you actually know? Question.
Huh?
Know which way the light's bending in the atmosphere over long distances.
You make a prediction.
If you know it's
that doesn't tell you where. Just making a prediction doesn't tell you how the light's bending.
No, you make a prediction
or
and
where
then
the actual position of the actual position of the object is.
Yeah, obviously you got to make a prediction, and then using your experiment to figure out if you're right or wrong as to where the light. It's all about how you set up your experiment.
I'm asking, how do you figure out if you're right or wrong? Okay, I predict the light's bending in such and such a manner. Now, how do we check to make sure that is actually so?
you need to know where the thing is in the first place, and you got that. You can, of course, not use this prediction to determine where the thing is, because that would be circular. So you need to have a different method to know where whatever you're looking at. If you look at the mountain in the distance, then you need to know where the mountain is first.
Yeah, what
in
the
a
weather
separate
conditions
method.
are like. Yeah, you're gonna need some information to make your prediction. But if given that info, you could do it.
I don't think so.
Why not? I mean, we do it all the time.
That's how you do experiments.
Okay, I'm an observer at a beach. I'm looking at an oil rig. Oil rig, I can't see it. The next day, I can see it. How do we know where its actual position is?
What?
I think you could do measurement under other conditions. Verify it, probably.
Like, you're going to measure temperature, pressure, and humidity and shit, and then what? How's that tell you where the actual position is?
where its
Because
position is on the surface of the Earth?
yeah,
Like there's an oil rig in the distance, and I gotta like give you its GPS coordinates type of thing.
No, dude. I'm looking at an oil rig.
Uh-huh.
How do I know where the actual, according to me, according to the observer, how does the observer know where the actual position should be of the oil rig?
I think you can determine that if you're going to use you could use several measurements and then see if because
several measurements of what?
Of the oil rigs during under different conditions. For example, that's one way to do it.
Wait, say that again. Wait, that wasn't clear. Can you say that one more time? Several what?
Measurements of the oil rig which you were looking at.
Yeah, listen again. The question is several measurements of what?
When I say measurement, I mean take a. In this case, measurement is taking a picture of it.
What the fuck, dude? Listen to me. There's an oil rig. You're an observer on the beach. You see an oil rig. It's moving up and down. Sometimes you can see it. Sometimes you can't. Sometimes it's higher. Sometimes it's lower. Do you know what the actual position of the oil rig is, according to the observer?
I don't know. I would use light. You know, I would use some method where
the light's bending, right? So we can't use light. Light's out.
Why not? Just because light's bending doesn't mean it's not.
You can if you know how it's bending.
Yeah, I mean you can always.
How do we know how it's bending?
How
do we know how the light's bending? How do we know how the light's bending?
You can look at shorter distances.
Did you hear my question?
Yes. You can look at shorter distances and where you have known positions. And you also, we know that light will also, I've seen measurements where they
make too many points. Let me address your first point. So we're going to use a shorter distance. Now I'm going to go half the distance to the oil rig, and now it's still moving, and now the oil rig's still moving, and now the oil rig's still moving. I'm almost done.
I would just use like a laser.
Hold on,
at the thing.
The distance to the oil rig now. We use a shorter distance. The oil rig's still moving up and down. Sometimes we can see it, sometimes we can't. Now what do we do? Shorter distance theory debunked.
No, I think you can use a shorter. If you use a shorter distance, so you are sure about how it's where the position where that the thing is actually straight, and you can also. I know that you can use methods where you send
actually straight. Hold on. How do you know it's actually straight?
You can use incremental measurements of the thing.
I told you we went at half the distance to the oil rig. It's still up and down. It's still moving all over the place.
Yeah, but you're looking. I'm not talking about doing measurements of how air moves in a place where you can't control all the variables.
I mean, Jeremy, do you want us to figure out how far away it is, or because you keep saying it's moving up and down? Is it moving up and down on the same spot? It's just like bobbing on the same spot, right?
Right, yeah, it's just moving up and down.
So on the same spot. So all I got to do is figure out how far away it is. That's
no, we already know how far. The distance doesn't. Distance.
So what am I trying to figure out then? If it's not the distance to it.
We're trying to figure out. You're an observer at the beach looking at an oil rig. You're trying to find out now. It's moving up and down, so you don't know where the actual position is. What you need to do, what we need to do, is find out.
That's why I asked. When you say position, do you want GPS coordinates, or do you mean how far away it is from? What do you mean by position?
Observers looking at an oil rig, right? This day to day, this will have different positions according to the. It obviously doesn't actually move. It has different positions according to the observer basis, right? You with me so far?
Different positions, as in, what does different positions mean? It's bobbing up and down on the same spot.
Observer can see it, and one day he can't. So its position is changing. Apparent position.
Okay, it's changing the parent position. Okay.
Yeah, what we need to do is find out where the actual position is, because that would tell us a lot. This whole problem would be over if we knew the actual position. Globe Earth wouldn't even be a debate anymore.
Yeah, then the only thing you could use is light, Jeremy. You would need light, and you need to know what the conditions are like out there.
The light's
Here is a method. I found a method how they do it. So what they
light
do
bending
is,
helps you figure out how far away the thing is.
yeah, there is a way they calculate this, and that's through they compare it to something else. So they look at here is one example where they compare it with ethanol. I'll post it to calculate the air refractiveness. Oh shit! How do I copy this link? Copy link. There.
I mean, you could just figure out what the weather conditions are like. That way, you know how.
Yeah, but you need to know. But you need to know separately how do you get the refractive indices in the first place? That's what his
if
question.
you know how if you know how far away the thing is from you.
No, yes, but then
I could just make up my own refraction numbers and say that light's bending to make it look like it's a flat Earth. You guys can just say, "Oh, the refraction's making the light bend so that it looks like a globe Earth."
That would require
But how would you do that, Jeremy? If we both have the same weather conditions, how would you just make up your own numbers?
They made up different refractive indices to make the Earth look flatter or whatever it is. That's what they could do.
Let me just jump in just real quick. I just posted a video of my footage of one of the oil platforms off of the coast of California, and if you watch it, if you take the time to watch it, it's 20 minutes long. You will see it change position. It'll drop from horizontal at a slight right to left drop, but it's very significant. I think you'll find it very interesting.
Well, the thing is to have a flat surface looking curved with refraction, you need a specific gradient in which the refractive index is lower at when you get closer to the surface and bigger as you get away from it. Which can't happen if for example the temperature of the ground is cooler than the air. You're gonna get the opposite. So if you still have things being blocked by the horizon, even with the gradient going from higher index to lower index as you go bottom up, that can't be refraction doing it. Because refraction is doing up. Yes, that's what Snell's law gives you.
How do we show that this? That's your claim. How do we show that this is true?
I told you. You have
just look up how refraction is.
The link I posted.
No, Bacon. Hold on,
in reality.
Hold on, real quick, Jeremy. Okay, Bacon. Listen, I've been doing this for 4 years. All I have ever seen is the rhetoric of what you just said. I have
this is
hold on, Bacon,
Snell's
hold
law.
on. Okay, Snell's law has fuck all to do with atmospheric refraction. You need to keep up.
Why?
It's a derivative from the.
Okay, listen, just real quick. Let me make my point. I have never, in 4 years of my research, and I've been looking, I have never found any document. Hold on. I have never found any documentation where they have shown any field measurements to prove anything about surface temperature, air indices, blah, blah, blah. It doesn't exist. And if you can find it, let's talk.
They did have
Travis, please. I sent you. Remember, we had this talk a few months back, and you said you have never seen this, and I sent this to you. How can you say you have never seen this now in 4 years? You just forget about what just.
Yeah, what you sent me was not sufficient. Okay, so there you go.
It sounds like you're just moving the goalpost. To be honest, that was data of actual measurements of air refraction indices in the air.
They were not. They were not verifiable. They were not valid measurements. No.
Can you tell me exactly what was not valid and how it? Show me what.
Listen very carefully. What you showed me was a paper that had numbers and dashes and symbols and all this kind of shit.
You want a YouTube video?
Okay. If you would stop talking, this wouldn't take so long. Okay. You showed me a paper that had equations with numbers and parentheses and all these kinds of symbols.
The documentation.
How you're gonna get the data using numbers? You're not gonna get. What, you want the drawing?
Listen very carefully. Let me finish what I'm saying.
Okay.
They did not show the field data or experiment where they derived those equations. They just put fucking equations out there. That's not evidence.
I remember yesterday.
I posted several links. One link was how they try to tweak the current equations which they used for, and then I also linked the data which you used.
Took some pressure, temperature, and humidity readings, right? Is that what your paper did?
And how what's their index of pressure?
Yeah, sure. So they got that. They got some temperature, pressure, and humidity readings, right? Did they do anything else?
I don't remember. I have to look it up again.
Yeah. Well, the overarching point is, even if they did have that,
DMs and posts, reposts.
Of course, that wouldn't make sense.
Even if they did do this and take corridor measurements of the temperature, pressure, and humidity, that doesn't show where the object actually is. All that does is show the temperature, pressure, and humidity through the optical corridor. It doesn't that. It doesn't give us the actual position. All it does is give you the supposed position based on your, based on your reinventing of refraction and your globe model.
Yeah, but I posted you a method where you can do this in the lab, Jeremy.
It's not outside.
What's the difference with the air in the lab and air outside?
It's a different universe.
The air in the lab, I can tell you what the difference is if they'll let me. The air in the lab, you have a container of air. That's not the atmosphere, right?
It's meant to control for all the variables.
Container of air, the atmosphere?
Experiment.
The same.
Container of air in the lab, is that the atmosphere?
Yes, if you have air in the lab, that's the same type of air that you have in the atmosphere.
Check with Rumpus. If you have a jar of air, that's not the atmosphere. Okay, you might want to check with Rumpus on this one.
Yeah, but that's part of the atmosphere.
It's the same substance, same stuff in both. What's special? Can you breathe that air which you have in that glass? Yes, you can.
You're saying this jar of air is the atmosphere. You're saying the jar of air is
the same material. He's saying no. That's
material.
All right. Hang on. Jeremy.
Argumentative now. You understand what I'm saying?
That's just wordplay.
So stupid.
Yeah. If you feel the air in the jaws,
this is what Rumpus brought down upon you guys. Okay,
you clearly just made a stupid.
He's been arguing for years that the air is not that.
Well,
if you have a jar of air, it's not the atmosphere.
Think for yourself,
we're trying to check what happens.
Jeremy,
we're trying to check what happens in the atmosphere, right?
That's That's a stupid word game saying that the jar of air isn't.
That air in the jar is not the same thing as the air that.
Yes, it is. Isn't the same air? It's not different.
It's
containing CO2, oxygen, nitrogen. Both of them. What's the difference?
Jar of air. I have a jar of. Telling me if I have a jar of air, jar of atmosphere in there.
That's not the atmosphere, but they're the same thing.
Check out what happens with light in the atmosphere.
Yes, which is
behaves the same
nitrogen.
So if your jar isn't the atmosphere. Our air isn't the atmosphere, and we're trying to figure out what happens with light in the atmosphere.
We are trying to. Yeah, we were trying to figure out. Okay, we're trying to figure out what happens to light in the atmosphere, and then we see, well, what's the atmosphere made of? It's made of nitrogen, oxygen, carbon dioxide in a certain proportion. So now we're trying to figure out what happens to light in that in that gas mixture, and by figuring out what happens to light in that gas mixture. Is the same as figuring out what happens in the atmosphere, because that's what is in the atmosphere. If you know what happens with light,
the argument is this jar of air is the atmosphere.
No, no. The argument is what happens in the mixture, in this mix of gases. So if we can know what happens with light in these mixtures of gases, doesn't matter how you label it, if it's the atmosphere, it's a jar of gas, those are also the same mixture of gas, and we are testing what happens in that specific mixture of gas. So they are the same mixture of gas. They just don't have the same label, because one is in the entire Earth, the other is in the jar of gas. But they're
run
both...
through this quick. I'm gonna try to run through this quick because I can't stand all your goofy fucking accents and the way you talk. So, are we trying to figure out what happens with light bending in the atmosphere? Yes or no?
Wow.
Yes.
Okay. And
You're
is the
trying to
jar
figure out
is the
what's
jar of air that?
happening
No,
with-
stop.
Oh
I'm
my
done with
fucking
you
hell! You're gonna
goofy
quote
fucks.
mine me. You're fucking.
I just want a yes or no answer so I can continue my line of questioning. You guys can't play along, so you can go fuck
I
yourself.
can't give you one yes/no answer to this. I'm gonna explicitly explain what I mean so that you don't misunderstand me. Because you misunderstood everybody.
No, you
now.
can't give a yes
what
or
you
no
say?
answer.
He
Intellectual
doesn't
dishonesty.
misunderstood.
Intellectual
He's being
dishonesty.
dishonest.
I know because no, you're being intellectually dishonest because you can't
We-
give a yes
we
or
are
no
being
answer
dishonest?
I
to a
won't
yes or no.
elaborate what
This
I'm
is
saying.
not
To a
what-
yes or no. It's a
What's
yes
the
or
problem
no
with that?
question.
That's not what intellectual
Question.
honesty
Shut
means.
the fuck up, dude. I'm done with you guys. I can't get loud. My wife's sleeping. Go. You guys with all your goofy accents, go fuck yourselves.
Wow, that's a very, very mature way to end the discussion. Let me appeal for accent, right? I mean, we can debate in the language that
Because you're
isn't...
being intellectually dishonest. You won't.
We
You
can
keep talking
debate-
over each other and me like you're doing
Of
right
course.
now. You won't answer a yes or no question. Of course, you're talking over me. I know because you're intellectually dishonest. Go
No,
fuck
that's not
yourselves.
what intellectual honesty means. It doesn't mean not
Let me get
interrupting.
my words out. You won't let me get my words out like an intellectual, honest
Can I-
person would.
Yeah, because
Can
you're...
I please
I know.
fucking
I know
explain
you
this
still
one
can't
time?
do it.
Can I please
Do it.
fucking
I know.
explain this one time?
No, guys.
So
Go fuck yourselves.
It does,
okay, fuck
you
off.
can't
So,
explain
Bacon,
it because
please.
he's not interested in
Bacon.
understanding it.
Okay.
Go on.
So what I'm saying is the air inside the glass, the components in that air inside the glass is the same as the air which is in the atmosphere. So that means if you test on that air in the glass, that will behave the same on the air outside.
Yeah, because
What's so
we're not-
hard about that? Like,
we're not testing specifically for gases in jars. We're testing specifically
Yeah.
for this gas composition. So
It's
if
like-
that gas
it's like-
composition...
it's like testing medicine on you, Bacon. And I tested medicine on you, Bacon, and some other people. That means I can only use the medicine on you people because I only tested it on you. Of course, it applies to
You're
everybody.
trying to check what happens with medicine on humans, so you check it on some humans.
Yeah.
You don't check it on some non-humans.
Exactly. You can
check it on
rephrase
humans.
the way you just
The
did.
Yeah,
or you
atmosphere
human,
is
and-
atmosphere. Can you guys not talk over me every time?
Okay, finish.
Really, every time, man. It's mad annoying with you guys. I don't like it's not
You
fun
have
engaging with you.
horrible analogies, Jeremy.
Yeah, but that's because we
Analogy is
got your
horrible, and I'm
point.
about to
And
explain
you're
why.
still
If you
going
let me,
on
I
with
know
that
you won't let me because you're
analogy.
intellectually dishonest. I know.
That's not... It has nothing to
Hold
do
on.
with intellectual
I wanna hear-
honesty.
I want to hear his analogy, and then can I real fast also? jump
I
in with my
understand what
own-
his analogy was.
demolish his
immediately opened his
analogy.
mouth.
Yeah,
going to
but yo,
demolish
guys,
his
listen.
analogy. They won't
You
let me.
two aren't the only people. Just let him finish, man. Like we're all trying to listen to this conversation. We're not just trying to listen to you two talk. You know. Go ahead, Jim.
To check medicine on humans. They check medicine on humans. It works. We're trying to check what happens with light in the atmosphere. They're checking it on something that's not the atmosphere, and I don't know why that's their analogy demolished just now.
It is
because in
it
their
is-
medicine,
Let me explain.
in their medicine
It is-
human
no,
analogy,
Bacon, please.
they tested the medicine on the things they were trying to see what happens with the humans. And my analogy, and what we're trying to do here is we're trying to see what happens with light in the atmosphere, and they're testing it on not humans, not atmosphere, something else.
They
Well,
are
if-
testing it on the atmosphere. They're just testing on a part of it. They're not testing it on the whole atmosphere. Even if you were to test it on a specific place, don't you assume that that test is always going to behave the same on a different part of Earth? I mean, you don't test it for all. Like, this is like an error in inference. Like, you're of course you can assume that when you do a test on something and then you have a substance which is exactly the same as people, if you have a person and he is the same as a different person, that the medicine is going to work the same on him. That's how fucking people think. Like,
But the reason why the analogy fails is that there's two ways to phrase what we're testing and what we are concluding. we can say that we are testing how light works on a jar of gas and concluding how it works in an atmosphere. But we can also phrase it like we are testing how light bends in this mixture of gas, and we are concluding how it bends on the same mixture of gas. Because in both cases, in the atmosphere and the jar, you have the same mixture of gas. So the second way I'm phrasing it does make sense. The first way I'm phrasing it seems like I'm committing a non sequitur. And what Jeremy did when he was making the medicine analogy, he just phrased in the other way. Although he was testing in Alice, Bob, and John, and then concluding that this should also work for, for bacon, he just phrased that, well, I'm testing in humans to say that if I can use in human. Well, I can just do the same rephrasing, and instead of using the atmosphere in the jar of gas, I make the general phrasing, which is this mixture of gas. So it's the same thing, you're just phrasing differently.
Your jar of air is not the atmosphere.
Yeah, and bacon is bacon is an Alice, right?
When you had the medicine, you were checking it on humans. We're
exactly.
trying to check
but those humans have names.
With the light.
But those humans have names.
I can't.
If I rephrase what you just said, if I rephrase what you said, but replacing humans by the names of every human it was tested for, I could just make the same point you were making.
The difference is Bob is a human.
Yeah, and the jar of gas
air is not. Dude, shut up.
And the jar of gas has has nitrogen, oxygen, and carbon dioxide, which is what we're testing for.
Yeah.
Yeah, your analogy would work.
You can't let me talk because I'm going to demolish your whole analogy.
You don't.
We just demolished yours. We explain why yours doesn't work. I just wanted to finish the point.
Yeah.
Well, I still have like 13 minutes, so I might finish the explanation of the algorithm. If ARM is still up.
Well, I mean, how about we put it to the test? We see if I can actually complete it, and if I can complete it, then I understood it. If everyone else can't complete it, whatever, we don't give a shit, right? Let's just do me, all right? Let's see if I can complete it. Someone give us a random sequence of T's and H's, okay? Heads and tails.
Well, first of all, is anyone else interested in this happening? I'm not.
Fair enough.
Not. I haven't followed that, so.
All right. Well, then.
We can.
Someone in the chat.
If you want. All right. Well, if you wanted to move to Livestream too, you can finish it there.
I think maybe it's better to divide it because I don't know about the others, but for me at least.
All right. Well, okay. It'll probably just be me and Bacon then real fast in Livestream too. Then, but I mean, well, you know what? Actually, no. Just do. We could just do it in text. We could just do it in text if you want, because I don't think anyone else is. Yeah. Anyway, yeah, you guys can go back.
Okay, so we have some medicine. We're trying to see how it works on humans.
Hold on, Jeremy. I'm sorry. Hold on. Okay, so Funk,
yes.
I would like you to retract that I'm lying in the text. Okay, I'm not lying. So the problem with the paper that you sent me is that yes, they had equations that represented values. That is true. Absolutely. I would like the field experiment data that they're basing the equations upon. Do you understand?
I think I sent several papers. Also, that was part of their citations. They cited the data.
No, they did not. Okay, look. Because if you would like to go back to one of those papers and highlight for me, just take a screenshot and circle. So for instance, if they have an equation and then they have a footnote by that equation, and that footnote takes you to another article, if I can't access that article, it does fuck all for me. So the shit that you sent me had data, but I'm looking for the actual experiments that they ran to get the equations. This is not difficult. It's not hard.
Yeah.
And I'm not dishonest or lying. So I looked at the papers you sent me, and in my opinion, they are all still insufficient. So I again would like So
Was it behind a paywall?
So again, yeah, paywalls, yes. So again,
Okay, so paywall is your limitation. Okay.
Okay, whatever. Again, my point is I would like you to retract your accusation that I am lying.
Well, why didn't you mention this? That I presented it to you, but it was behind a paywall.
Okay, because in our conversation, it didn't get to the point that it's at right now. Because a few minutes ago, I explained that the papers that you sent me did have equations in them. Now, after I saw that you accused me of lying, I said something more, and you gave me more information as well. So that's all I'm saying. Okay?
But you can't say that you have never. But if your limitations is paywall, then
Did you look
you
up
haven't really looked really hard.
Did you look up those citations behind the paywall?
I didn't pay for that. No. I
Okay,
sent it
great.
to you.
Okay, great. So let me ask you a question. Do you have any evidence that those papers are actually going to have the field data that I'm looking for?
Yes, because the title says so.
So you know that a paper has the data I'm looking for, but you've never seen the paper. That's really interesting.
No,
Why
I
is
have
it
seen
so
the
hard-
paper. I just haven't read all the content.
Sorry.
I wouldn't even read all the content.
Wait. I just asked you if you paid for the access to the citation, and you said no.
No, you asked me if you think that I have a paper which has this data, and I have. You just have to pay for it.
Okay, guys, you guys are listening to this, right? I clearly asked.
Dude, it's intellectual dishonesty at its highest
Oh,
point.
you can't
peak.
say.
This is the
You can't
peak
say
of
that it
intellectual
doesn't exist
dishonesty
when
with these
I have
people.
it, and
I've
you
never
have to
seen anything like it
pay
ever.
like $10 for it. I'm gonna fucking pay for it if you're gonna be this smug about it.
I'm not okay, dude. I'm not being smug. You're accusing me of lying, and I'm telling you what I've done in terms of the information that you gave me.
If you base your whole worldview on this, like, it's not my contention. It's you who don't believe it. So I'm not gonna pay for you to believe something.
Okay, wait. Wait. Did I say I don't believe something?
Yes, you say you don't believe that there exists paper that has these numbers.
No, I did not say I don't believe. Those words did not come out of my mouth.
You said you don't have seen them, and I have shown you that, but you won't pay for it.
Okay, great. That's what I said. Did the words "I don't believe" come out of my fucking mouth? No.
You believe that the Earth is flat because you don't have this data.
Fuck off, dude. Fuck off.
Okay. The fuck.
The professional Glovers are pretty intellectually dishonest.
Stupid.
Well, I sent him the fucking data. Like, what the fuck?
No, you didn't send him the data. It's behind a paywall. You can't get to the data.
Yeah, it cost $5 or something. Like, I'm
so
not.
Go ahead, man. Like I said, my
it's
argument
not
is
my proof. It's not. I don't have to prove it for myself.
Is it
If
an
is
anarch?
honest, and
Does it have a DOI link?
Yes.
Oh,
It had a
so
DOI link.
maybe it's on. Yeah, so we can
checked,
get it
I
on.
checked on Sci-Hub. I didn't find it on Sci-Hub.
Oh.
Otherwise, I would send him that.
Oh, share with Sci-Hub if you pay for it.
Yeah, maybe I'll do it. I can do that.
Hey, you guys think anything we can push down? You're trying to push this refraction thing into a small scale thing in a fish tank, right?
Mm-hmm.
Yeah.
I think that's a better way to test, because then you got more control of the variables than to test in a large complex system. You have much more variables which you can't control, and therefore you'll be
variables that could be affecting the way light's bending. I know.
It will give you a less precise reading of the index.
Yeah, you get
ridiculous.
You get a much less precise indices.
You
don't know what you're checking for.
But you didn't even have to
wow.
be so
that's all I gotta
precise.
say is wow.
You don't have to get so precise, because, for example, if the gradient goes from bigger index to lower index, light can only bend downward. If it goes from the opposite, it can only bend upward.
That's not even true, man. There's
Yeah,
there's no data to back that up.
Yeah, simple Snell's law bakes.
Okay, I'm going to say this one more time for the cheap fucking seats. Snell's law, according to Walter Bislin, according to Walter Bislin, your guy on the fucking model of the bendy light fucking bendy earth shit, says, and I knew this before I read it, you cannot apply Snell's law to atmospheric refraction. So stop using it.
But what it would, if you have two
Can I
indices,
see the whole
it tells
paragraph where it says
it doesn't. What it does explain is if you have two indices, whichever model you use, if you use Snell's law, if you use the Arconial equation or whatever you want to use, that one will tell you the direction it will bend. You won't be able to model it. It's not going to bend the opposite way with a different equation.
Yeah, if you want to claim that light bends down or bends up through the atmosphere, you can make that claim all you want.
So
you can't.
all of
Alright,
this.
thank you.
You can't prove it. You can make the claim, but there's no proof.
Yeah, I don't think we can prove anything to you guys.
Yeah,
I think there's enough evidence for that.
That's because you're a fucking pseudoscientist.
No,
Science,
there's enough evidence
science,
for that.
No, science proves shit, dude.
Yeah, I agree. No, I mean not with 100%. That depends on what you mean by proof. Of course, that means. Of course, that depends on what you mean by proof, right? Can science prove we don't live in a simulation? No, it can't. So if we do, everything about we know might be wrong. So we can't. Nothing you can know for sure, right? Science can't prove anything about the real world with 100% certainty. Because you can't even prove the real world itself.
Yeah, whatever, dude.
I mean, that's just the philosophical problem of solipsism, which is unsolvable. That's what I meant when I said it doesn't prove things
I'm not
with
a
100% certainty.
I'm not a philosopher, bro. I'm a scientist, okay? Thank you.
Oh, yes. Oh, what scientist are you?
Empirical.
No, what are you graduating in?
I don't need. What do I need a degree for? I'm self-taught.
Oh, right. Self-taught
right.
scientist, right. Interesting.
Yeah. Do you have a science degree?
I do, actually.
What field?
Computer science.
Awesome. So stop fucking talking about atmospheric refraction if that's not your field.
Why?
Because you don't have a degree in atmospheric refraction.
And so what?
Yeah,
You can
so
refer to people who.
Did I say you should stop talking about it?
Well, what was your point about ad homing me for not having a degree?
I wasn't ad homing you. I never ad homed you. I just asked what's your major in because you said you were a scientist. So I got curious.
Yeah. Why do I need a degree to be a scientist, bro?
I never said that. I just got curious.
Okay, it's implicit, dude. Stop fucking around. It's implicit in your question.
That's what I mean. This isn't even.
You're trying to discredit me because I don't have a.
No, I didn't try to discredit you.
Whatever.
These guys are legit
people
just playing
most
games. Like
people,
it's obvious. It's obvious they're just playing games. They're here to get us upset and agitated. They're not being
there wasn't an assumption. There was an expectation because every people I know that calls themselves scientists, they say that because they majored in science of something. So I expected that would be the case for you. Not that I'm assuming that's the case, but because that's like the vast majority. Exactly. So there's I'm not discrediting you.
Pretty reasonable.
Listen very carefully. When I make claims, I try to be as specific as possible. So when I talk about the Bible, I will tell you I have a degree in the Bible. Okay. So if I don't claim to have a degree in science, there's no fucking reason to ask me if my degree is in science. So science is simply the observation of the natural world. My 5-year-old could be a scientist, making discoveries for themselves about the nature of reality. That stove is fucking hot. That's science. It's not complicated. It doesn't need to be represented with maths and equations. It's very simple, gentlemen.
Yeah, well, I understand that. I'm not denying that. I just didn't do the attack you think I did. Just had an obvious expectation that wasn't met. That's all.
Listen, don't blame me for the atmosphere. Your fish tank being a not the atmosphere, because Rumpus has been arguing for years now.
But no one's saying that.
That a jar of air. Relax, bro. Relax. I don't know. Are you on a time budget here? Or do you have only a certain amount of time to talk?
Wait, what?
No, you're just taking forever to talk.
Yeah, I mean,
What do you mean,
forever
dude?
to
I was
talk
once-
things
that was-
you already claimed before, and we already give you the response. Like no one's claiming that.
Jeremy, let me give you a shout out, man. I was just thinking this like 5 minutes ago. I was like, man, I wish I could keep my shit together the way Jeremy does, dude. You are so calm, cool, and collected, bro. Just props to you, man.
Well, I lost it a minute ago because these guys are. I feel like they're intentionally doing this, like with the over talking, and they're like tag teaming and shit. He almost did it just now. Relax.
Yeah.
Bro. You want to say something? Go
You're
ahead.
very,
lag, Jeremy, for crying
you're
out
very-
loud. It's not like he's trying to overtalk you. Jeez.
You're very calmly strawmanning us. Right, fine. You're doing it very calmly. Congratulations. It's still a strawman.
Kimo is an expert in that. He's just politely disrespecting you all day long.
Listen, I'm not strawmanning you. You guys are claiming that the light's bending a certain way in the atmosphere. You want to check it in this little tiny fish tank, okay? How about I measure? What? Yes, that's what you do. You test it in this little tiny fish tank, not in the atmosphere, right?
Yeah, because we're testing for this mixture of gases.
Yes. Okay. Yes. So.
Which is the same as the atmosphere.
If I were. No, it's not. You said it yourself. There's other variables. Variables you can't control that.
No, I said it's the same mixture of gases of the atmosphere.
I mean, it's not going to help to find the indices if you test in a place where you have no control of the variable. Like if you're going to test medicine on a person, you want to know his weight, his gender, his height, see like fat and BMI and all that shit.
Okay, is there
you're not going to just blindly give it to him, right? So it's better to take individual people than to just throw medicine on the ground and say, whoever takes it, somebody just take it. I don't give a shit. It's different.
Okay, is there the same amount of magnetic field in your length of fish tank than there is over the length of, I don't know, a mile or 3 miles that we're making these observations in the atmosphere? Yeah.
You could test with the magnetic field in the tank as well. If you think
they already know magnetic fields. Yeah, they already know magnetic fields can cause light to bend.
I don't think it bends a lot. I don't think it bends.
It doesn't need to bend a lot. All it needs to do is bend a little bit.
How much is a little bit? How much is a little bit?
A little bit, 8 inches per mile squared.
Yeah, does it do that? Show me evidence of that.
You haven't shown. I can show you evidence that a magnetic field will make light bend in your
8 inches per mile squared.
No, I don't know that's the math I'm making up. Like you guys make up your math of how the light's bending now. I can just make shit up. You guys don't have any proof of what you're saying. I can equally do the same.
That stuff. I cite sources who do actually use real numbers.
Okay, where do they get their real numbers from?
They cite their sources.
How do they check to see that that's the way light was bending in the atmosphere?
They don't need to check it. Somebody else checked it for them.
Okay, how? How did they do it?
Look at their sources.
So you don't know?
No, I don't know who the. Okay. I don't know what sources you don't. You're not saying.
I'm not asking you who the sources is, not who. How.
Yeah, then how can I know how the fuck they check it if you don't know what you are talking about?
Hey, Funk, just
the people you're talking about, not me. You're saying the people check.
I'm not talking about.
I don't care who.
I don't talk about specific people now.
Okay, just for clarification, Funk, if I went to a paywall and all I had to do was pay $5 for the article, I sure as fuck would have paid $5. Okay, so it's not just $5, bro.
Check what it cost them. I remember it wasn't that expensive.
Okay. When I'm going to just say this, when the handful of times I have followed links to go to a paper that's behind a paywall, I have to pay for the membership, which is $300, and then I have to pay for the article, which is $35.
Was it the case for this one?
If I did the research the way I normally do, and I see a citation that I follow, I will check it. And I've never bought an article behind a paywall, so they are not just $5 wherever the fuck you're getting that number from.
Just have to look it up again, I guess. I sent it not to you directly, so it lost. I can ask somebody else who know this, have more control of these sources. I think MacToon has, like he do this shit every day. It seems like so. If you want to know, like I gave you one link though, but
Are you done? That was a long pause. My bad. Go ahead.
Yeah, I was
Talk
just
about
saying.
I take a long time to
gave you
say
one.
shit. I know.
I'm just saying. I gave you one link.
Like I thought you were done, or you paused, or you lagged out, or something, bro. You guys just take forever. It's like you guys think it's the more you talk and the more you over talk, it's just gonna make you like win or something. That's not how it works, bro.
No, I gave you a link, and you think, what if I give you another link which also does things in a lab? You're just gonna reject everything that's done in a lab now because it's not done in real life. So
well, okay, let me ask you this. If I were to check how much the water was bending, how long is this fish tank in the lab?
It's let's take a 2-meter fish tank, then you can find out how much refraction happens in the fish tank.
How long is the fish tank? What's the distance of the fish tank? The length of it that they're using in this experiment?
I just made up example, but let's say it's 2 meter.
So you have no idea. You don't even know what you're in here talking about.
No, what?
You don't know what you're talking about. You don't know anything about this.
It's a trivial example. Like, of course, you can measure refraction in a fish tank. What's the problem with that?
I don't know. I'm asking you how they did it in your experiments that you supposedly gave.
They didn't do it in a fish tank. They did it using air and ethanol, and then they compare the two substances and see how they interfere with each other, or how their interference pattern are. I don't understand it. Yeah, I don't think.
I know it's clear. You've made it clear you don't understand it. Keep talking more.
Well, nobody will understand it. But why do you distrust it? Tell me why you would distrust it. Like,
I don't
if you're
understand it because he just explained it like a mumbling idiot. That's why I don't understand it. They used air and ethanol to see how the light was bending. That's what I got from what he just said.
They also have a picture of how their setup is, although I have no idea how they derived the refraction number from that.
Yeah, was it daylight or was it a laser?
They use a laser.
Yeah, that it doesn't count. Lasers are not daylight. Thank you.
There's so many things that's wrong with this fucked up experiment already. I know this is a dumb experiment you guys use. You didn't even use the same type of light.
What's the difference between laser light? What's the difference between light coming from a laser and light coming from outside?
The fact you're asking that shows us you have no idea what you're talking. You should not even be in. I know he tried to overtalk me so people didn't hear. The fact that you're even asking that tells everyone that you have no idea what you're talking about. You shouldn't be arguing anything.
Tell me what the difference is then. Tell me what the difference is then. I want to literally know.
Stop now. You should stop now, bro.
Why? What's the difference? Both send photons. What's the difference? It's the only difference is one is controlled and the other one is you don't have control over.
Okay, what's the difference between the wavelengths and coherent light and incoherent light?
The wavelength? You didn't explain any wavelength. What wavelength do they have?
Okay, so here, how about this question? Is daylight coherent or incoherent?
Dude, he doesn't know. I told him to stop now.
What do you mean by coherent light? I don't know what you mean by coherent light.
Okay, so again, both Jeremy and I are trying to clue you in that if you don't know that there is a difference, I don't give a shit what it is. If you don't know there is a difference between a laser and daylight, you don't belong in this conversation.
But you're talking about light, which I just Google it. So coherent light is light that have the same frequency. You could just say that. So that's. I
So
mean,
what?
if you
Okay,
take
great.
individual parts of,
Okay.
if you take individual frequencies of and
Okay, how
measure
about
that
this?
in the air,
Yeah.
then
How about this, Punk?
what
How
is the
about this?
difference?
Okay, how about this? How about this? In your opinion,
Mm-hmm.
are you satisfied? Or let me say it this way: in your opinion, would you ask a scientist who's giving you a demonstration for how laser bends through sugar water to say to him, okay, that's great. That's an awesome demonstration. Can you do that with daylight, please?
If I wanted to demonstrate that light bends in sugar water.
No.
Sorry.
So so let's pretend that you don't know anything about light at all. And you go to a scientific demonstration and he shows you a laser beam in sugar water and he shows you how it bends and all this. And you're like, man, that's really interesting. You've got me really interested in the properties of light. Can you show me that with daylight, sir, please? Would you ever even think to ask him that question?
No, I would ask him how does it behave in the different electromagnetic spectrum, and then I could derive how it would behave in daylight from that.
How what behaves?
The light, if I know all the electromagnetic spectrum which the sun gives away, especially in the visible light, if you want to use that, then that would be sufficient.
So you think that you can simply correlate an incoherent light source to a coherent light source and put an equal sign between the two? You're okay with that?
It's called the fallacy of division. It's called the fallacy of division, what he's doing.
Fallacy of division? I mean, you mean like reducing down to individual bits and pieces for the experiment?
You're saying because this thing has one thing that's similar to the other thing, that they're all the same. They all do the same thing.
Well, don't they do that?
Can you prove it?
There's
you can
a
ask
school.
that question. You can ask that question all you want. You just said, "Don't they do that?" Okay, can you show me?
Yes, we can do experiments in.
Great. Show me daylight bending, please.
Daylight bending? It's not hard to infer that daylight will bend.
No. I don't want inferences, sir. I want science. Thank you.
Well, daylight bending is just like look at through a glass of water. That's daylight bending.
Yeah. I mean,
Okay.
you could just
great.
look
So when
over
I'm looking,
water
great.
and
Yeah, great.
sunny day.
Great. So when I'm looking 20 miles across the Channel Islands, am I looking through water, sir?
Oh, you ask it for water light bending. That's light bending.
No, I said daylight.
Yeah, daylight bending. That's daylight bending.
I mean,
look.
Okay.
When you look through a glass of water.
Picture.
Again. You guys are absolutely not. You don't belong in this conversation because again, I'm not looking through. When I look at the Channel Islands, I'm not looking through a beveled glass filled with water.
Yeah, but that's what's no one's saying. No one's saying that.
You just fucking did.
No, you asked it for an example of daylight bending. I can send daylight through a glass of water, can't I? That's gonna bend it.
Okay, great. When I'm having a discussion about atmospheric refraction and mirages, am I talking about daylight going through water and a beveled glass?
No, but that's what you asked it for.
No, but. Then shut the fuck up.
Well, then ask for light bending on the atmosphere if you want light bending on the atmosphere.
Okay, are you so obtuse that you don't understand what I'm asking for?
Well, I don't know what you use that for, so maybe that would be useful.
Okay, all you can show me, okay, again, listen very carefully. All you can show me with a glass of water is the effect at the end. Like if you could show me, like it's like a magnifying glass, like the light that hits the table through the glass, but you can't show me in the glass itself daylight bending. You can only show me the refraction effect outside of the glass.
What do you mean?
Would you like me to repeat what I just said? Because all I'm going to do
No,
is
if I said what do you mean, that means I don't get what you're saying. So if you just use the same words, I'm still not gonna get it.
Okay, pretend you have a glass in front of you.
Right?
Is there light in that glass?
There's light going through that glass.
Is there light in the glass?
I'm not sure what that would mean.
It's go light through the glass. It's light in the glass. Yes.
Yeah, I'm not sure if that would be considered yet.
He's asking if you put the light sensor in the
No,
glass,
no,
you will.
I
you
didn't
will
say
read.
light sensor. No. Okay, look, this is not.
You're
difficult.
asking if
I'm trying to
there's light
understand
in the
what you're.
glass.
Okay.
Bacon. He's asking if there's light in the glass. Yes, there is
Okay.
light in the glass.
Yes. Okay. Great. Show me that light bending, please. I want you to point out. I want you to point me to the light bending. Show me.
Well, of course
Well,
it has to
we
bend
can.
because you see the straw coming from different directions.
Okay. I didn't say anything about a straw, sir.
I posted an image.
Yeah,
maybe
but
you didn't see
but his answer is actually answering you because you're seeing the light
No.
straw with
No.
light. That's how we
No.
see things.
No.
we know
no.
how the straw is
Okay, look.
straight.
Okay. Look.
It's not bent. So
Okay. Okay.
if you
Great.
put it in the glass,
Great.
you know that
Okay.
it's bent.
Okay. Great. Great. I'd like you to show me not the straw displaced, apparently. I want you to show me the light bending.
That is the light.
That is
What
the
you
light
see,
bending.
yeah, I mean, you see light coming to you
What
at a
you-
certain direction. That's what seeing is.
I don't understand how more you want to see it, because you only when you say see it, that is literally light hitting your
No,
eyeballs.
I see the straw. No, I see the straw.
Let me
I
give-
don't see the light. No, I don't
Let
see
me
the
give
light.
let me give a.
Is using the straw. That is light. That is red light reaching your eyeballs.
Let's dissect this picture.
I mean,
so someone
you want to break down. He wants
Wait,
to
wait,
break
Frank.
down light into bit more.
No,
more bits
wait,
and
wait,
pieces.
wait.
Impossible.
We can do something more. We can be more
So
precise there.
One at a time,
So,
please, guys.
this-
You're talking over each other. I mean, you're on the same side.
Yeah. So we have a picture of that glass, right? That picture was taken from a camera, right? And the way a camera registers the picture is that it has a sensor inside of it with a grid of photoelectric sensors, right? So when a photon hits, it emits an electrical signal, and this gets read by the camera the microprocessor, and it encodes it into bits of information.
Great.
So that's
Can I-
how. So yeah, and each of those points on the grid becomes a pixel.
Great.
Right?
Okay, great. So you see that bit of light to the left of the straw?
Mm-hmm.
You see that bit of light to the left of the straw right there? That bit of light right there to the left of the straw? Can you show that to me, please?
Yeah, the color of the pixel is the light. That light, exactly.
When you say
That's what
see,
produces
that
the
is a clue
pixels.
that you already see it. If you say
yeah.
you see this, that is light. You can't say, do you see that light? And you say, I can see that I don't see it. That's like a nonsensical thing to say. Because if you see something, that is light.
Yeah,
No.
if you see red in the straw, that means there's a red light hitting the camera sensors. And
but-
if the red is coming, it's more to the right of the picture. That means the angle in which the light that was hitting the camera sensors is now coming from more to the right than it was before. So it's coming from a different direction. So it's bent because that's not the direction of the straw.
That's an assumption.
No, that's how cameras work.
Yeah, but you don't see the light doing that. You don't see the path of the light as it goes from the source to your eye. That's
No,
a
but
inference.
But that's how
yes,
images
what's the problem
form.
with inference? What's the problem with inference?
Because over long distances, like Travis is trying to illustrate, you can't be sure what the light is doing.
But the
Yes,
camera
we
is
can
right
do-
up.
we can test
We're all talking about this glass of water, and he's
Yeah.
making a point that we can't see if the light is being bent. Yes, we can because it's reaching the center from a different direction, and that's not the direction of the straw.
I mean,
No,
you know,
that's
think about
what
this.
over
Let me explain it this way. Let me explain it this way. You see you can, if you hold the straw in your hand, you can feel it, you can touch it. You know that the straw is straight. If you put it in the glass and you take it up again, the straw is still full. You can either do one of two things. You can either assume that the straw actually been cut in half by the water, or you can assume that the light bouncing off the straw is not going in a straight direction. What do you
Right.
want to do? Do you want to infer that the straw is cut in half? But when you put it in your hand again, it's full. It's whole again. It's like is it the water magical cutting the straw in half? I don't think so. Yes, you infer, but to infer something else is, in my opinion, just ridiculous.
Okay, so can you please show me anything in the atmosphere that is displaced the same way that straw is?
I think the Black Swan does it similarly. Does it really? Not the sharp lines though, because the sharp line is because of
So
the
the
water
answer is
with the air.
no. The answer is
No,
no.
the answer is yeah. We have plenty of examples of. I mean,
Great,
there's
show me
time
one.
lapse of.
Great,
Oh, there are multiple. I'm pretty sure you've
no.
seen them.
No, you're not going to. No. Listen, I'm going to say it very slowly now. Okay,
No, please don't
you
do
have
that.
a.
We heard you.
Okay, if you heard me, then why are you giving me an answer that's not related to my question?
Yeah.
You're asking for an example.
Bacon.
and-
He asked for a. He asked specifically. Do you see a type of refraction in atmosphere which is this sharp? He didn't precisely explain that, but that's what he means. And no, we don't see that because you don't have these sharp lines in the atmosphere.
No, I actually didn't use the word sharp, so no. Thank you, though.
Exactly,
Well,
that's what he said.
What wouldn't
He
that?
said you didn't use, but that's how he understood your question.
Yeah, I would understand it
okay,
like
well,
that.
then you're wrong. That's not what I meant.
All right.
What
so
did you mean?
What did you mean?
Yeah.
Okay, so we have an image in the chat of a glass of water with a straw that is apparently displaced, correct?
Mm-hmm.
Okay.
Yeah.
I'm simply asking you to show me anything, any image that is through the atmosphere where you have the target completely separated and displaced in the same way the straw is.
That's what I explained to you, actually, to be honest.
Wait. You said completely, right? Because in the example of the straw, half of it isn't going through the water. So it's displaced because we are comparing the outside, the straw outside of the water and the straw inside the water. So they are they're being refracted differently.
Okay, so you're saying that hold on.
Let me just finish. I didn't make the point yet. So if you ask it completely displaced, then it would be the whole straw, right? Not just a piece of it. Because if that's what you're asking, then the answer is yes.
Okay. Oh, the answer is yes?
Yeah, if it's completely displaced, then the answer is yes. If it's just half of it displaced, then I don't think so.
Okay, listen very carefully. I don't know why you're now talking about half and whole or whatever, okay?
Because that's what you asked.
Okay, it's very simple. The target is the straw, okay? The target. The target above is in a certain location. The target below is completely severed and displaced from the apparent position of the target. Are you with me so far?
Sorry, I don't think so.
Are you looking at the picture, or can you just see it in your mind?
What picture? Oh, right. So, right. Sorry. I wasn't following.
Okay.
Go on.
Okay, so we're talking about the glass of water, right? The glass has water. The glass has water in it. There is a straw in the glass of water. Okay, the top physical straw is in one position. The apparent displacement and separation of the straw in the water, right? You've got the right. It's completely separated and displaced. Would you agree? Okay.
Yeah.
I'm asking you to show me that in nature.
The two parts, one displaced and the other not displaced, or just the displaced part? Do you need both at the same time? Or if I show you the
let me try to be as kind as possible. Are both of them in the image that you are presenting to us to consider for refraction?
Yeah, exactly.
Okay, so yes, then I want both.
Right, because the first time you asked it, you said completely displaced. That's why I thought I wouldn't need like the half not displaced part. Because if that was the case, the answer would be yes. But if you want half displaced and half not displaced, then of course not. I don't have a secondary.
Okay, great. So what I hear you saying is this picture that you present to us to demonstrate light refraction cannot be demonstrated in nature. Is that what I hear you saying?
This specific picture won't happen like with the atmosphere, no.
Okay, so do I hear you saying that the image that you are having us consider has no correspondence to a natural phenomenon?
No, I didn't say it.
No.
Okay, great. Okay, great.
It's a very great leap.
Okay, great. So let me back it up then and repeat myself. Can you show me anything resembling the displacement of this straw from its physical target in nature?
Resembling, yeah. Actually, yes. There is, well, I'm pretty sure you've seen those GIFs of time lapse.
No, don't.
Let me finish. Let me finish.
Don't assume anything. Just present.
I'm not assuming anything.
You just said
I don't have.
assume. You just said I'm going to assume
Did
you
I?
saw this.
Oh, right.
Well,
Yeah.
what about the black swan?
Because I don't have the. Yeah, I don't. I mean, I'm not in my computer. Don't have the GIFs I have saved for this types of request. But this is a very frequent GIF on this servers. I mean, that's why I'm saying you probably seen it. Because if you didn't have to dig it up, but I'm pretty sure someone here have seen it. It's like a time lapse of like some houses and something like that. Let me finish.
Listen, your story doesn't matter if I can't see what you're talking about.
Right. So if I show you, you're accepted, right?
I will have to consider it. I will consider it.
So why can't you consider it before I give you the gift? Because this will take time.
I didn't ask you to explain something. I asked you if you could provide an example in nature that is.
This is in nature.
Okay, I wasn't finished. So are you okay if I finish what I'm saying?
Go on.
Again, I'm asking for an exact demonstration in nature of a target being 100% separated from its refracted image.
Actually, that's not what you have asked it before. When I was answering you,
that's not what
you. Okay, listen.
Let me answer. Let me answer.
You guys can't talk over each other, man.
Right. So let me answer. That wasn't your question. You said something that resembles this effect. No, it wasn't. I can go to the live stream and prove you it wasn't. You said something that resembles it, and I said, well, if it resembles it, then if you don't need the half thing, and
okay, great. Let me.
Then the answer would be yes. That's what I said.
Okay. Oh, hold on. So, is it your opinion that image of the glass of water with the straw and its refracted image? Is it your opinion that the straw and its refracted image are separated?
Visually, you mean? Yes.
Okay, great. I would like you to produce any semblance of a separation of a target and its reflected image.
All right, that would be very hard to do it, but I don't think that's relevant. If you allow me to explain why I don't think that's relevant. Let me explain. Let me explain why it isn't. Because you're not letting me to explain anything. You're just waiting for the short answer.
Okay, listen. Did I ask you to explain? No. Did I ask you?
You don't get to decide what I speak here.
Oh no.
You don't own the server.
No. Did
The
I
thing is-
ask you?
I don't want my words. I don't want my words to be misinterpreted. So
Okay.
if I'm answering you, you have to be allowed to go deeper than the short answer.
Hold on. Did I ask you for an explanation?
I don't care what you ask it for. I'm not here to
didn't
make you satisfied.
I didn't ask you for an explanation.
I don't care. I'm not here to satisfy you. I'm here to have
Then you
productive
can
discussions.
mute him and Bacon can explain himself. And for the rest of us, I want to know what your deeper explanation is, Bacon.
What am I trying to explain?
Well, I was trying to explain why I don't think this is relevant. Because a separation, in this case, is just a separation because you have the displaced and the not displaced. If the whole straw was inside the glass, you still have the exact same effect. You still have this exact same amount of refraction. You still have the exact same straw. Everything is the same. You just don't have an extra part not refracted. So the effect didn't disappear. It's completely there, but there is no separation anymore because the effect isn't separation. The effect is the displacement. So you're asking for a separation. If I would have to be able to look something through the atmosphere and through the vacuum to compare them, for example. If I'm only talking about the displacement.
Let me know when you're finished, man. What the fuck?
I will. If I'm only talking about the displacement, which is the effect that is going on the glass, that's what the water is doing. It's doing the displacement, not the separation. Then yes, I can give you multiple examples of things being displaced by the atmosphere. That's why I don't think the separation is the important part, but the displacement is.
Okay. Again, what I'm trying to establish that I think that you have established in your explanation is that image has fuck all to do with this discussion. It is irrelevant and inadmissible.
Why?
Because you can't reproduce this effect in nature.
What? If you have
What do you mean? Isn't that in nature?
If you have a stick in a river, is that nature, and would then that be acceptable?
Okay, great. I'm talking. Okay, listen. When I have this is okay.
Are you referring to air? Like in air? Just say it in air. Then.
That's correct. Because listen
Say
very
that,
carefully.
then. Holy
Hold on. That's what this entire discussion has been about: atmospheric refraction. And you guys fucking show. Hold on. You guys show us. Hold on. You guys show us glasses of water with bendy straws.
Because that's what we're asking for.
You ask for if light will bend, and we showed you that.
No.
Yeah, that's the easiest example of all.
Look,
without lasers.
No.
What was your question?
Okay, whatever.
This is pretty good evidence that light will bend without lasers.
Yeah, because it appeared to be the case. You were implying that only laser would bend, and then this picture of the glass proves this is not the case. It doesn't matter if it's laser or not. It bends in the same way, and that's what this is proving. This is not supposed to be analogous to what the atmosphere is doing.
Okay, except for the fact, and this is going to be hearsay for you, except for the fact that when I do have conversations about atmospheric refraction and I ask for demonstrations of light bending, they show me this fucking glass of water. But when okay, hold on. But when I am making observation, hold on. What the fuck's your problem?
Oh, you're talking about someone. We don't know who that is. I mean, just clarify who you're talking about.
I just said it's hearsay.
Who?
Hearsay.
Do you know what hearsay is?
No.
Okay, it's an anecdote, right? You weren't there. I was. You have to take my word for it. Okay?
Right. That sounds great for this discussion. Go on.
Whatever. So Arma, again, yeah, I've taken pictures like that, Arma. Okay, so stop showing us pictures of displaced and separated images in glasses of water, because that's not what we see when we're looking through the atmosphere.
Yeah, but the point of my image was to show, because I mean, like with the water, I mean, of course, I mean, you're going from air to water. That's a cutoff point. But I mean, air obviously is a little bit more gradient. So if if it was more of a cutoff, then yeah, the bendy crane wouldn't be so bendy. It'd probably be all fucked up. It'd probably be like bending one way, and then second later it's like shifted. But because there's a gradient, it's it's more bendy. But the bendy crane, it would be, I think, a good example of that. I mean, look at that. I mean, it's practically the pencil. It's just all connected still.
But
yeah, I'm look again. Listen very carefully. I'm not asking you to produce images of distorted and displaced targets. I'm asking you to show me light bending.
Well, that's the displacing. I mean, that's what the bending does. It displaces the point of light.
If light isn't bending in this image, then I don't know what the fuck it's doing. All right.
Okay, Arma. So if you look back up at the oil platform, right?
Uh-huh.
So if we look at the very left boom, right? The zigzag boom.
Okay.
Is the light bending up or down?
Wait, real fast. What's a boom?
The very
talking
left
about the flare boom, which is the thing sticking out to the left of it. Oh, that's
very
not the
left,
flare. That's the flare.
Okay, shush. The very left image that's bent the most.
You mean like the little the thing we like the crane?
The very left image, the very left part of the image.
The structure that like the bendy crane.
Okay, crane, if you want to call it a crane. Okay, the crane that has the backward S shape, right?
Yeah.
Okay, is that light bending up or down?
Bending, it's bending all like weirdly. I mean, it's doing like a weird thing. It's like I mean,
yeah,
some of it might be stretched a little bit.
Yeah, I agree.
So you agree that light bends? And what was the question? No, you wanted to have proof that light can bend.
Okay.
Up and down is different.
Okay, look. Okay, no.
Okay, it might be bending. Okay, so then it's probably
It's it has if it's turning a diagonal into a curve like that, then it's compressing more and more the lower you get. So I think that would be downward, right? Otherwise, the curve would be in the other direction.
Okay, listen, that's great. You can imagine an explanation all you like. Is your imagination scientific evidence?
It's not an imagination. He's basing it on the real shape of the oil rig. He knows the shape of the oil rig. He knows that this boom is straight. If you see it compressed, how must the light bend to create this effect? It's not imagination.
It's not just compressed, because if you compress a diagonal evenly, right, it's still a line, but you have to compress it in different rates to get it to become a curve. And the bottom part in that case needs to be more compressed than the upper part to make it a curve. Otherwise, the curve would do the opposite. It would be like in the opposite direction. And
it might be
so yeah.
Okay, let me ask you. Okay, let me ask you this. Let me ask you this question again. Okay, let me ask Bacon Funk this question. Okay, that boom as one single unit, right? As one single unit, is the light across that unit all bending up, or all
it's bending
down?
in different? It doesn't all bend in one direction, apparently.
Yeah,
otherwise, you would see a uniform oil rig just higher or lower, but you don't see that. You see it squished.
Right. So which way is the light bending for the squished?
Depending on the exact part, but if you took the tip of the boom, then that would look like it's bending. The part below her would look like it's bending a little bit upwards. Actually, I would guess.
Okay. So is your term look like? Is that a scientific evaluation?
It's what I can give you here by just looking at the screen for 2 seconds.
Yeah. I can describe stuff all I'd like. Is that scientific? Is that scientific data?
Yes, it is. It's a kind of modeling.
Okay, so how would you verify which way the light was bending?
You could do that by modeling based on our current knowledge of how light will behave in atmosphere.
Yeah, and match atmosphere. Actually, there are such models, and they make very good replications of the black swan.
Because we don't know the atmospheric conditions in this case. So in this case, you only know how it looked like, and if you know what it looks like, and you know the how light behaves in certain conditions, you can derive a certain model of how the atmosphere is.
Yeah, those are great claims. Absolutely great claims.
That's what you do with the. That's like what Walter Bisnon has done. They are great claims.
I was going to say something else, but I forgot. Oh, right. So yeah, I mean, I don't think any of the light is actually bending downwards. I think it's all bending up, but some is bending more up than others. You know, in certain spots, obviously, because if any of it was bending down, then technically, you know, we wouldn't be seeing
No,
it.
I mean, why would you think that? Because I think you might be confusing the picture being moved up with the lighting bending up, like.
Well, okay. So obviously, if we assume a ball Earth, right? I'm a baller, so it's not really assuming.
No, without assuming that, even without assuming that, right? Sorry, go on.
Okay, so okay, but okay, let me just give my example just to show you why I think this. All right, so on a ball, yeah, that oil rig would normally, you know, not really be in view, or maybe the top of it will be, but you know, a lot of it will be obstructed, right? The idea is though that, you know, it's going to be raised up, right? So we can see it, right? So if it's raised up, right, then all of it has to be raising up. Obviously, some parts are raised up more than others, and that's why you got that, you know, weird effect
Okay,
going
wait.
on.
Hold
But
on.
it'll all have to raise up, because if some of it's raising down, then some of it would be missing, you know.
Okay, hold on. Why are you
No,
saying?
it would just change the direction that you have to look to see it.
Hold on. Why are you using the term raising up?
I don't know. I'm not that knowledgeable on this topic. That's why.
if you visualize like a perspective, a path of light from the oil to you, and it's bending downwards, then of course the straight line between you and the platform, it would seem that the light from the platform would be missing. But actually, the light that is going from the platform up, because it reflects in all directions, can still reach you. Actually, now you have to look higher to see the platform. If light is bending downwards, it's going to loom the platform, because now you have to look to a higher direction.
Well, yeah, I mean, I was flipping it. I know technically light, you know, it bends down, and then we have to look up because it's. I get like the angle thing. I get that. It's just I was just trying to, you know, use words that we can kind of just, you know, understand without going in too much into detail. I guess what I was trying to say is that, you know, the image is raising up, but obviously other parts of the image is raising even more so, is what I'm trying to say. But, you know, without, you know, talking about light, you know, the angle that it's bending and whatnot. So I don't know.
Yeah, and because of that curve, you can see that the lower you get, the more is being raised.
Wait,
otherwise,
because of the curve of what?
The curve of the part on the left. The way that curve is, it means the lower you get, the more it's being lifted up.
Yeah.
Because if you start with a straight line, to curve the line like that, you have to move up faster the bottom part than the upper part. If you move everything up equally, you're still gonna get half a line. So for you to get that curve, the lower part has to be moved up in a bigger rate as the upper parts of the line to make it that curve. So the lower you get, the more bending, the more loomed it is.
Okay, I'm just for clarification, you're describing what's happening to the boom as looming?
Yeah. The boom? What's a boom? Boom is that part?
Oh my god,
Yeah.
crane.
The crane.
It's a flare boom.
I didn't know about that, but I mean now I know.
Right. Well, I'm referring to the curved part. The curved part, it's looming.
Okay, can you
the,
okay, hold on. I'm not trying to be a dick. Can you find any documentation that would describe an observation like that as looming, please?
I'm not sure. I'm just giving you the obvious conclusion.
It's not obvious to me. I would never describe that as looming.
What do you
Well,
describe
the whole
it as then?
thing. No, of course, it isn't looming in the general sense of looming. What I mean is the closer you get to the bottom, the more it's displaced up. That's the only way you can get that curve. And in displacing up by refraction, usually is what we refer as looming, right? So in that context, that would be looming, but it's different from something just displaced up.
Yeah, you're saying that part of the oil rig is loomed, not the whole oil rig.
Yeah, and and it's getting more and more loomed as you get more and more close to the bottom. Otherwise, you would get the curve would start bottom up, going up and then curving to the left instead of going left and curving up.
See.
Oh, anyway, I gotta go back to work. So.
All right, later, Bacon.
See ya, guys.
Bye.
But yeah, bendy crane, guys.
It's not a crane, it's a boom. It's a
Oh yeah,
flare
bendy
boom.
boom, guys. Bendy boom.
It's two different things. The other one is to expel gas, and the other one is the crane is to lift things.
Okay. Fair enough. Well, yeah.
Hey guys, I'm gonna post an image that I took. I'm just curious how you would interpret what the light is doing.
Dun dun dun. Yeah. Over here with that little island in the background. That's whatever you want to call it. That's a little mirroring at the bottom. That's why it's kind of reversing back on itself. It's mirroring. Wouldn't that be that one refraction, reverse refraction?
Is what happens if you put your camera pretty low to the asphalt and you see the asphalt almost disappear.
Okay,
but
listen,
it's a
guys. Why
reflection from
is
the
it okay?
atmosphere.
I asked you to describe what you think the light is doing.
Yeah, I said.
Yeah,
mirroring.
it's coming from. It's actually you're seeing a reflection, not a reflection, but the air in the sky is refracting off the water.
Okay, do you not know what that phenomenon is called?
Isn't that like reverse?
I don't remember, but I've seen it a lot when I drive.
It's an inferior mirage.
There you go. I had a feeling it was called that, but yeah,
What?
I think it's called that.
Yeah, it's called an inferior mirror.
Yeah, that's true. That's what the name is. Okay, I didn't know what the name was.
Okay, so you see that little bit of pink between the boat and the island?
Yep.
Yeah.
Okay, so the light, or I'm sorry, the pink part, the sky that's right above the water.
Mm-hmm.
You see what I'm talking about? That part right above the water between the boat and the island visually?
Mm-hmm.
That is not the sky. That is a mirage of the sky.
Yeah, I said so.
Okay.
That's what I meant.
Okay, so if that boat weren't there and all you had was the sky to the left, and you didn't know there was an inferior mirage out there, you would think you were seeing the actual horizon at that position. But you wouldn't know that right above the water there at that degree of angle, that it was an inferior mirage, and that is not where the sky actually is.
Well, if I were to actually use this for like a measurement or something, I would never take a measurement from that acute of an angle.
I didn't ask you to do that.
No, but like if okay.
Okay, so just you need to let the impact and the import of what I'm pointing out to you. Okay, so let's remove.
Let what?
Hold on. Let's remove the island and remove the boat, so that all you have is the water and the sky.
Mm-hmm.
Uh-huh.
If you simply looked out to the water and the sky on this day, you wouldn't know that there was an inferior mirage above the surface of the water.
No, you would have to have some object there. It's true.
So guess what that means? That's not where the water actually ends, and that's not where the sky actually begins. So you don't even have an actual horizon there that you could take a measurement for your radius of your Earth.
So refraction, I've consistently heard in here that refraction can't move the horizon, only objects. But now you're telling me it can actually move the horizon.
I've never heard anybody say that, but that means
I've heard it many times. It's like
Okay,
used
well,
as an argument for the Black Swan.
Okay, well, I've never heard anybody say that, but obviously you haven't paid attention to or even watched my content, because I've made the exact opposite claim.
Yeah. I'm not saying that you said that. I'm just saying that I've heard. It's literally the first time I've heard the opposite from a flat earther. But that's great. I mean, so Travis, what I am saying to flat earth is that refraction doesn't discriminate whether it reflects from water or from air or from an island or from a boat, whatever it is, everything can refract. It's not a rule that tells you, well, if it's reflecting of water, then it can't refract. So of course, everything can be lifted or sunk down. Like in this case, you can disrupt the line of horizon, like where it is. So yeah.
So, okay, again though, the inferior mirage is creating the horizon. The inferior mirage, where if you look from the bottom of the photograph, you see water. If you go all the way up to where the water ends, the water is not ending because of Earth curve, gentlemen. It's ending because refraction. Every single time.
It doesn't remove that possibility still.
Yes, it does. Absolutely, it does.
Hold on.
No. This is just proving that inferior mirages exist to prove that there is
No, it does
Earth.
not. No,
Well,
it
hold
does
on.
not.
Hold on. Well, let me real fast debunk, your whole thing here. All right, with this image anyway, specifically, right? With this image, yeah, there's a mirroring going on, right? So with that being said, there's nothing's actually sinking in this image, right below the horizon. You're simply just getting the sky mirroring onto the horizon. So with this image, specifically, you can't make that argument that that's where the horizon ends, and that's why we see what we see, because we have sometimes mountains just below the horizon or whatever, and
wait,
that
you
wouldn't
have what?
work
You
with
have
that
what
logic that
below
you're
the?
using.
Wait, what? You have what below the horizon?
You have like mountains hiding behind the horizon, but if you're using the logic in this image, that wouldn't work, because this only mirrors what's above the
Okay.
horizon.
Okay, listen very carefully. When we're talking about the horizon is always, every and only created by refraction, either with or without mirage. I'll be right back.
I kind of get your argument, but at the same time, it's like, like this image alone doesn't really.
I mean, if you show an image without inferior mirage, does that prove globe Earth? No, it doesn't. You still need to know why the horizon is where it is. And if you have, in my opinion, if you have any horizon which is moving due to your height, that is evidence of globe anyway. And I know that he's not. I don't know if you listen now, so I don't want to backtalk him specifically, but I consistently hear from flat earthers demanding numbers and specific measurements with actual numbers and models. But consistently, what we get back is inferior mirage exists. Therefore, you can't have globe Earth. I don't see that connection at all. Like, you need to have a model at the very minimum. Like, where do you expect that horizon to be? You can't just say, well, there is inferior mirage, or therefore, yeah.
Yeah, you seem to think that falsification requires replacement. I don't have to replace a model simply because I've falsified that the apparent horizon isn't a result of the curvature of the Earth.
In this case, it is. Yeah, you gave one specific example. It's not this always. Inferior mirage doesn't always exist.
Yes, it is.
No, it doesn't. You see it some days you don't.
Okay, I apologize. Yes, you're correct. But listen again to what I said. I was very specific. With or without mirage, the horizon is created by refraction.
Not if you don't have inferior mirage, because it's a specific, more extreme refraction.
Incorrect. That is incorrect.
Refraction doesn't behave like statically. It's not like this or that. It's like gradually.
Did I say that? Did I say that?
No. So if you know how much refraction there is, you know where the horizon is.
Great, awesome. So let's you and I team up, okay? The next time I'm in California, I would like you to let me know all of the data that you would need to predict for me where the horizon's going to be.
Just so we're clear,
what
his
data
prediction,
you need?
Go ahead, Jeremy.
That prediction doesn't mean that that's actually where it is. You know, that's just how we can predict it on the globe model. They're reverse engineering it off the globe. It's ad hoc.
No, it's not reversed of globe model. I gave you example, but where you don't use the atmosphere itself, but then you reject it because it's not in the atmosphere.
Because your fish tank, your little fish tank, there's more variables in the atmosphere going on over a larger distance than what's happening in your fish tank.
Mm-hmm. That's a positive in my opinion. Then you can reduce and see what each individual variable affects the indices. Like change your humidity, increase the pressure, decrease the pressure, increase CO2, decrease CO2, add a little bit more nitrogen, these things. Isn't that kind of better than to have no control over them at all?
There's other factors you're not controlling at all. Well, I don't know, because someone explained the experiment very poorly, but are you controlling the amount of magnetic field that's happening?
You can do that as well.
Is that what you can, but is that what they do?
I don't know if they've done. I believe that nobody believes that except you or some other flat earthers.
Well, a magnetic field can cause light to bend. Or maybe it's an electro. There's a magnetic field that can cause light to bend. That's not me. That comes from the mainstream. That's mainstream science, bud. You didn't know the difference between coherent and incoherent light 10 minutes ago, so I don't know what your basis for knowing this is.
I haven't heard about the term, but
You didn't hear about coherent and incoherent light either. I know. You don't even know what you're talking about here. We know.
Okay, so just real quick, guys, I
don't see how that's relevant. If you can just explain it.
All right, so let's go to this next image. Take a couple seconds and look at it.
That's the mirroring effect, yeah.
Okay, so this again is my own photograph taken of the Channel Islands, and we got a ship out there in the distance. Okay.
Mm-hmm.
So, what's your interpretation? How would you describe this to somebody? Like, if you wanted to use this image or try to explain this image to somebody, what would you say?
Like a reflection.
It's a type of inferior mirage effect going on.
Okay.
Looks
and what about the boat? Where's the position of the boat?
It's in the middle of the image.
Wait,
Okay,
wait,
so
it's a boat?
a
I
ship.
can't tell you the distance or whatever if you want to know
I'm
that.
not. I didn't ask you for the distance. Yeah.
Okay, it's in the middle of the image.
Okay, so when you see, okay, so to the left of the boat, there's no boat, just sky and then the water. Correct?
Mm-hmm. Mm-hmm.
Okay, would you call that the horizon?
If I would call that horizon, yes, I would call that horizon.
Okay, great. What's creating the limit to the water?
The mirroring effect, like that.
Yeah.
You got pretty much.
Very, very good. That's very interesting. So let's take the boat out of the picture. What's
You mean the
creating
top of the boat that's hiding behind the horizon? Okay, go on.
No. Oh, I'm sorry. What did you just say?
Is that the top of the boat that we're looking at? I don't.
You yes, you do see the top of the boat.
Yeah, the rest of it's hiding behind the horizon.
Okay.
It's really
Hold
hard
on
to...
now. Wait. Hold on now. So, is this Arma that just said that?
Yeah.
Okay, Arma. So, what's creating the limit to the water below the boat?
It's not the but okay. Even if you take that limit out, though, there's still a lot of boat would be missing. That's my point.
Okay, great. So now what we have to understand is that when you have a mirage like this, the entire physical image is directly in front of you, behind the mirage. Okay, so the top of the boat is there, and the hull is also right there in front of you. The hull is behind, like I think it was Funk or whoever else said, that the bottom of the boat is behind the mirage. It's right there directly in front of you.
So it would be lying on top of the water then that we see. Like it would be lying because I mean like I need to draw this out.
But he uses you uses example where you have inferior mirage.
Yeah,
you can't
okay,
use
listen,
that
hold on.
as,
Wait,
as
stop,
evidence
stop.
for
Okay, stop.
pictures where you don't have inferior mirage.
Okay, listen. I don't know why okay, hold on. I don't know why you're bringing up another category that I'm not addressing. I'm addressing this photograph right here. If you would like to bring something else up after we finish this discussion, by all means do. But the fact that you're bringing up a red herring right now
It's
is
not
a fallacy.
fucking red herring. It's
It
both
is.
our pictures in both our light effects in the atmosphere, and you picking pictures of a specific.
Okay, listen.
I'm not gonna listen for you forever now.
Let's
You're just telling
talk about.
you have interrupted me every time I've spoken now.
Let's just talk about this image and the reality of what the inferior mirage indicates to our understanding. Okay, so hold on.
No, stop it now. It's enough of this stuff. You said you used this previous example, which also is the inferior mirage, and you inferred from that to all observations that we can say from this that the horizon isn't the real horizon. Therefore, you don't see curvature. You're just seeing an inferior mirage.
Okay, hold on very carefully.
In an inferior mirage, but you're just picking the images which has inferior mirages in them.
Okay, listen very carefully.
There are
because
pictures which don't have them.
You are misrepresenting me.
That's what you said, and that's what the same thing you will do on this image, because it's the same type of image.
Okay, listen very carefully. I'll pay you $100 if you could find that quote from my mouth. You're not going to be able to. Do you know why? Because that's not what I said.
You said that on the last picture.
Okay,
You're just going to conclude with the same thing now as well.
Okay, please listen. This is not difficult, gentlemen. This should not be a difficult conversation.
You want to ask
have.
the same question over and over again, and you want us to give you the answer you want to. We're never going to give you that. So it's no point in trying to say, listen, listen.
Okay,
We're going to give you the same reasoning again back.
You okay? So far, you haven't given me any reasoning. We're talking about.
I gave you one. Did you just ignore it?
Okay. I'll give you the benefit of the doubt. What was your reasoning? I'm sorry.
It was that you are picking images which have strong refraction. You can pick other angles and other limits, and you can argue that's the real horizon within very precise, very small margins.
Okay, great.
You can't just say, "Well, there is."
Let me know when you're going to be finished talking.
Please.
Let me know when you're going to be finished talking because you seem to have.
I don't need you. I don't need to give you any permission for me to talk.
Yeah, you had a pause, and so
yes, I didn't finish. So stop talking. So in that example, you can't just say that it's inferior mirages, and therefore you have the horizon could be wherever you want. Like, assume that we can't trust where the horizon is. Yes, we can. You just pick the pictures where we don't have inferior mirages. You don't choose the horrible anomalies for this to conclude with.
Are you finished?
Yes, I'm finished.
Okay, great. Like I said before, after this discussion of inferior mirages, if you would like to bring up other instances to consider, you're free to do so. So the reason why my conversation is the way it is right now is because I'm demonstrating to you my understanding of what the reality of observations where there is an inferior mirage. So I'm not going to bring up other instances where there isn't an inferior mirage because I would like to present you with a consideration for understanding what happens when there is an inferior mirage. Does that make sense?
Go on.
Does that make sense?
Sorry, I didn't listen to you right now. I was actually reading and typing something.
Okay, well, you can go fuck yourself, man.
Cheers.
Cheers. Yeah, I don't see how it's gonna help presenting another image with.
Is there anyone else here who would like to continue this conversation at all? Arma, are you?
But
Arma, are you interested?
I am a little busy too, though.
Okay, because this is technical, gentlemen. Okay, so if you're not able to give me your attention, because this is technical, you actually have to consider the evidence and the claim. I'm not trying to be.
Well,
I'm not trying.
What was your claim, actually?
Can
What's your claim?
Can I finish my sentence, please?
Yeah.
I'm not trying to be condescending at all. I'm trying to tell you that this is a mind bender. Okay, you have to think about this.
It's a light bender. So can you give us the claim? Because you gave one earlier, but I want to see what the claim is again.
The claim is that a mirage at any distance will require the same reality of physics for atmospheric refraction. So, if you have an inferior mirage at 1 mile, and you can demonstrate that the mirage is obstructing the surface of the ground, but the ground is still there, extending into the distance, but you can't see it because the mirage is there. Why can you not see the rest of the road in the distance? It's not because there's earth curve, because when there's no mirage, you can actually see the rest of the road go into the distance. But today, there is an inferior mirage, and you have a limited view of the road. Therefore, the road is still physically there. It's just obstructed by the mirage.
All right.
But that was only during the. That was exactly what I told you that your claim was on the previous picture. So you just repeated the same explanation just with a new picture and came to the same claim. That's why I think it was kind of pointless to say that again. But I'm going to come with the same... I'm not finished. So I'm going to come with the same rebuttal again, which is you can pick these days where you have mirages. That's one thing. The second problem... The second problem is...
wasting our time. You're fucking wasting our time right now.
The second
You are
second
wasting
problem...
time right now.
The second... I'm just going to talk over you. So the second problem is that I don't see how this is... What is your hypothesis for determining that you don't see Earth curvature? How do you see the difference when you see the horizon? How do you determine that it's Earth curve or that it's not Earth curve? Mirage or no mirage?
Okay, my hypothesis has nothing to do with Earth curve. It has to do with refraction and how it affects the observation in the distance. Okay. Now, that is not to say that I don't think it has an impact on the reality of the land upon which we stand. But my hypothesis primarily is exclusively with the physics of refraction with or without mirage. Now, your interruption to my explanation tells me that you don't
interrupt you.
You just did.
I did now to say that I didn't interrupt you.
Okay, earlier I was explaining my interpretation, and you interrupted me to say that I'm just saying the same thing over again. So yes, you did.
And you did. And you did, so I was right. I
Okay,
could spare us
so
like 10 minutes of your babbling.
So let's just be clear. You did interrupt me.
The last time I did, earlier, yeah. But not when I explained after that.
Okay. All right. Again, it's obvious to me that you are not interested in understanding my hypothesis because
you didn't explain it fully, because you concluded with the Earth that the Earth that you're not seeing Earth curvature, but you're not explaining how you determine that.
Okay.
And earlier you said that it didn't even was part of your hypothesis, even though you concluded with that. So I don't understand how your brain works, to be honest.
Listen very carefully, please. I'm trying to take you from one instance of mirage so that you can understand that part, so that when I go to the next part that's a little bit more developed, you can understand the correlation between the two. So that's why I'm starting off with giving you a demonstration of a road in the distance. One day you're on that road and you can see far, far into the distance. Another day on that road, you can't see as far into the distance. In fact, it looks like the road just stops. Okay? That is the result of an inferior mirage. The inferior mirage is creating the apparent limit to the visible road. What that implies is that behind the mirage, the road continues to extend into the distance like it normally does. Does that make sense?
Yes.
Okay.
It goes into the distance, yeah.
Okay. And does it make sense that the reason why you can't see the road farther into the distance is because the refraction is creating an obstruction?
The inferior mirage in that example, yes. But the day you didn't have refraction, No, you're not going to cherry pick my fucking explanation now. You're not going to quote mine me.
Carefully. Stop, man. Stop.
No.
If you want to bring up other instances after this
You're
discussion,
so fucking dishonest, man.
If you want to bring up other instances to discuss, I am more than happy to listen to you. Right now, we are talking exclusively about inferior mirage. If you have a problem with that, then put yourself on mute and I can have a conversation with someone who is. If there is no one here, that's fine.
You can quote mine somebody else, I guess.
Quote mine? What are you fucking talking about?
You just want half my explanation. You don't want the other half where I elaborate on my explanation.
There's no need for a qualification, dude. We're talking about an inferior mirage.
I think it's necessary because your conclusion doesn't follow.
What's my conclusion?
That it doesn't show Earth curvature.
Okay, go back in the last 5 minutes when I repeated my explanation. Did I mention Earth curve? No,
Yes, you did.
I did not. No,
yes,
I did not.
Yes, you did. On the first one, you said it does not show Earth curvature.
God. Oh my God. Listen to the words that I just said right now. If you go back 5 minutes to the explanation
so
that
you change your conclusion on the first and the second inferior mirage image. I mean, it's really difficult to follow you when you change your explanation almost every time.
It's actually not difficult. Okay.
Yes, it is when you change your explanation. If you can't follow, if you can't hold on to your explanation earlier and be consistent, then it's really hard. Because every time I say something, you can just deny what you said 10 minutes earlier.
You said. There's no need for you to keep talking. Okay, I understand.
It's necessary for me to talk because then you're not talking.
Okay.
I think it is necessary.
Okay, great. If it makes you happy.
It doesn't make me happy. It's just
I wasn't finished talking, so how can you know what I was going to say? Okay. In order to
Did I say that I know what you're going to say?
In order to remain consistent, I will say this. When you look out on a long stretch of road in front of you, and you can see the entire stretch of road into the distance, and the other day, and another day, you have a limited view where you cannot see the road stretching into the distance, but you know it goes like another 20 miles ahead, you know. So when you see that apparent limit to the road, in that instance, it cannot be due to Earth curvature, because the other day you saw the entire road in front of you. And now there's a mirage. The mirage is the reason you have a limited view of the road. It's not due to Earth curve. Okay?
So that's your conclusion, Earth curvature. That you're concluding that this is evidence that you don't have Earth curvature.
In this instance, the limit to the road cannot be created by physical Earth curve in this instance.
Let me ask you a question then. If you don't have a superior mirage and you still see a horizon,
I'm not talking about
superior
due to
mirage. Earth curvature?
I'm not talking about superior mirages. I'm talking about inferior mirages.
Oh, sorry, inferior mirage. If you don't have an inferior mirage and you see the horizon, could that be the Earth curvature causing that horizon?
If you would like to present an observation for us to discuss, by all means, let's discuss it.
You have horizon without inferior mirages? Yes, you have plenty of them. I can show you an image where you have a boat behind the horizon.
Okay, so can we first finish the discussion of inferior mirages before we get to your no inferior mirage observation?
No, you're comparing it with you are comparing it without the inferior mirage. So no,
I'm not. Not.
Yes, that's how you concluded that it was fucking not Earth curvature, because you're saying you have inferior mirage one day and you don't see the horizon at the same place that you do when you remove it.
No. When I was just describing the road, I didn't use the word horizon at all. I was just describing the road.
Yes, but you see the horizon is lower, as we explain it to be the horizon.
Okay.
So that's where it
hold on.
to...
Again, listen very carefully.
Oh my fucking God. You are annoying, man.
I'm the annoying one, right?
Yes, you are.
Let's take a poll. Anybody?
I would actually love to clarify this. So, in the case, the first case where you're on the road, there is no horizon there then that day. You cannot see the horizon. Just doesn't exist.
Do you have an observation you would like us to consider?
I was talking about the case you were talking about. Isn't that something that you would be willing to consider?
So the example that I was describing was my own personal experience in the state of Utah, where in the distance there were mountains. So I did have a horizon. Okay. I did have a horizon in the distance because there were mountains. But I'm describing the road itself. Okay. Are we good?
We could, yep.
I thought he was gonna follow up with something. I guess we're not.
Good afternoon, guys.
Good afternoon.
Afternoon, SE.
Wasn't is Don talking? It's just green.
Oh, I don't know. Oh, there he is.
Bollocks, I thought that was happening.
Oh, I was.
Damn it. Well, the main last thing I said was I'd like to balance all of Travis's and Funk's information with this information. Earth to globe, light bends a bit, and we see stuff. And it's
You're crazy, man.
It's very healthy not to worry yourself too much about how a horizon looks. Just, just chill out. Because it's only a horizon, and we learnt about it when we were little. Don't obsess too hard on horizons, guys.
You guys mind if I bring up a topic, or you guys are in the middle of something?
Will it be semantical?
No, I'd like a change. That's up to you.
Go ahead.
Well, I'm sort of like doing a project. I'm sort of like I'm asking what is proof to you, like proof project, shall we say. So I'd like to ask anyone who cares to answer, like, what is proof to you?
I do have an answer because I've thought about it recently.
I mean, like, I don't know, if there was like an image of, I don't know, like something really far away, and we could like still see it, and assuming not even refraction could get it that high, then maybe that would be. I would really have to look into that. Like there was an image a while ago of, I don't know if the numbers are true, but it claimed that the mountain was like 800 miles away or some shit, and you could still see it. I wanted to look into that, but no one ever really gave me anything, so chances are it was fucking bullshit. But yeah, if you can find Like,
so your example is sometimes a good image can be a proof. Your proof.
well, I wouldn't say it's a proof, but I would have to really like go into and be like, okay, why are we able to see this or whatever? Assuming like it would really have to like defy a lot of things. You know what I'm saying?
Is it the image or is it you being convinced by the image and you thinking?
Come on, Don. Listen, have a normal conversation with somebody, man.
I will admit, yeah,
I'm about
you
to
ask like
answer
a lot
what
of
proof
questions.
is.
Tom.
I see.
Let him answer. Let him
your
answer his
atmosphere's
way,
done with,
guys.
sir. Sorry.
Arma, in your own words, proof. To you, proof, is it a picture, solely a picture? Yes or no?
I guess not. Then I guess it's not just a picture. No.
So maybe you want to think about it a bit more. Let somebody else, like Chad. I mean, Don, sorry.
I'll try and... my idea of proof is it's the point after you've got evidence, which is a reason to believe something, and then you decide, now I've thought about it enough, and I've seen this evidence, I've chosen what I think is evidence, I've thought about it enough, now I decide it's true. That's when it becomes a belief to proved.
I'm glad you said that, Don, because I heard that before. Now, the obvious question would be, right, what is evidence?
I think it's anything that supports your belief in something, or your idea about something, or your explanation for something. Supporting thing, anything.
Yeah, I would agree with that. Yeah.
So I could say that boat there in that meme behind the water is evidence for why I think it's a globe.
So visual
anything,
evidence in the form of a picture.
Anything. That's just one example for me. Happens to
Okay,
be
fair enough. Because some would say evidence like that. Some would say, I don't know how to put this. Maybe some would not think that's enough for evidence. See what I'm saying? Like a picture. We're back to a picture now.
By itself, but it is a piece of evidence, however small or big you think it is. It's one piece. If you decide it, it is.
All right, fair enough. Anybody else want to take a crack at what proof is to them?
Is this an attack? It's just you talking about what evidence.
I mean, I would say things that can be proven empirically. I don't think there is like any. I think it's no defined line, but there are some things that we are really certain that they are not considered evidence, I would say. For example, but it's very difficult to make a general rule that will fit all future evidence. I think it's need to be determined on a case by case basis.
Can you be a little bit more specific? Because it's
okay. I can give you some example of what is evidence and what I don't consider evidence, and maybe one evidence is perhaps that you could say, if you say that you do a test where you check whether water causes people to be murderers, and then you check, then you do a test to see did the people who murder people drink water, and you'll see, oh shit, all of them drank water. Can you say that's evidence that water is causing the murders to kill people? I would say no, because even you have to determine that you have to look at its individual evidence to see if there is any perspective that we haven't looked at. Like, for example, in this case, do other people actually drink water? Yes, everybody actually drink water. So of course it's not a correlation there. But this is a simple example. But in real life, you sometimes it's very easy to go into this trap, and it's not That's why I'm saying it's not that easy to.
Oh my God! What are you even saying?
I gave you an example of what is not evidence, and to say that something is evidence, I would say the minimum would be that it's empirical, that it uses, that is quantifiable, that you can actually, that we can access the evidence in a physical way, and that it's also verifiable.
Now we're getting somewhere. So are you saying cause and effect here? Is that what I'm hearing? Or I don't
No.
want to put words in your mouth.
No, I don't know how that is useful in this context.
Invoke two big words, Funk. But you'll need to explain what they mean. It's empirical and verifiable.
Yeah, because when you say empirical, yeah.
Empirical, by that I mean like using something that is physical, and that is something that is like accessible by everybody, that we know is objective, so that you don't use. Yeah. So it's not like
no,
I feel this.
There's no
but
way everybody
it's only me
can-
who feel this. You know,
can access
it's
the same thing ever. So that's
I think you can. Like everybody can look at the same thing. Like everybody can look at the moon. It's not.
some people are blind.
Yeah, some people are blind, but the people who can see the moon. Everybody can see the moon.
So Funk, you're being a little wishy.
Sorry, a big amount of people makes it empirical. No, you can't mean everybody. Everyone can't see the same thing.
Yeah, and I also think that there needs to be some way to. Of course, the most important, I forgot that it's falsifiable. Of course, it should be some test that is a way to differ between two different options. If the test doesn't actually support the proof either way, then it's not evidence. That's part of the empirical part.
So you are saying cause and effect then?
No, not directly.
You invoked empirical, you invoked test.
Mm-hmm.
So what is it? You're being like, you're saying it, but not saying it.
I would say you can infer cause and effect relationship, but you can't prove it.
So
That's
now
why
you're
I'm a
saying
bit
it is
more
cause
careful.
and effect, but not provable.
No, yes, sorry, yes, I mean that. It's not, when you say it is cause and effect, that's what I'm saying. We don't know if it's the actual cause and effect, but we're trying our best to see if there is a relationship there.
So yeah, so now you're backtracking. So you're saying it does mean cause and effect. You do have to have a test, right? So now, I mean, I don't want to put words in your mouth.
It doesn't only have to be a test. It could be
Clarify,
observations.
Funk, clarify yourself, please.
It can be observations. It can be experiments. It can be analysis, existing data. It can be questionnaires to people, like social tests, if you want to call it that, social studies. It can be many things.
Okay, got it. Everything. To you, proof could be anything and everything.
No, I gave you a couple of examples where what's not proof.
Just say, Funk. Just say, if authority says so. That's what you really mean.
No, I just don't want to. Nobody limits themselves, and I would never limit myself to a set of rules where it's basically limiting our knowledge because we made a rule at some point which might be too strict.
If you trust it's been verified, and if you trust it's empirical, like meaning serious, physical, serious, then it's proof to you.
If it support the evidence and also the whole like part of like falsification and all that shit.
All right, can I ask a question real quick about this? So if I see the road one day and I don't see the road the next day because of an inferior mirage, can I say that the inferior mirage is the cause for why I cannot see the road?
Yes, I would say that's a thing you can say.
Is that a proof?
That's evidence.
I think
Or proof.
You decide if it's a proof, dude, and then I decide after when you present it to me. And I'm saying no, that's not proof of flat Earth. Sorry.
I didn't ask you if it was an example, if it was a proof of flat Earth. That's not what my question was.
If it's not proof of flat Earth, what else is it?
The reason
would you
why
consider?
Hold on. Let me try to answer.
Yep. Yeah. Go ahead.
Okay. My claim was the reason I can't see the road today is because the inferior mirage is obstructing my view.
Okay, yes, that's a proof. Inferior mirages can obstruct proper view. Yeah.
Okay. So then science can prove things. I just proved the reason why I can't see the road.
That's Dawn who said that.
To me, his proof is just me agreeing that you've done some good reasoning.
Yeah. Don't you say this is the reason why I avoided using the word proof? I said evidence because technically it doesn't prove it. It's just evidence for it, and you conclude from that.
Okay, Funk, we got what you're saying, and he's trying to veer us off path here. We got your idea of what proof is. There is no such thing as proof. We got it.
Yeah.
Okay, thank you. Maybe somebody else would like a crack? Somebody that hasn't spoken yet? How about JJ? Or Jerry? Or Dor Reckoner? Anybody? How about you, Lori?
I'm not sure if I can give a good answer because I was halfway thinking, should I give a trolley answer? But then I decided against it.
No, bro, give your honest answer. Like, how are we going to move forward if we troll? This is a project, an honest project. I'm asking everybody fairly, ballers, flat earthers, truthers, concave earthers, I don't care.
We can still move forward if we troll, but then it's going to be a trolley moving forward.
Yeah, you can troll another time. I mean, there's plenty of time.
That's sort of why I decided against it. Like, there are times to troll, and then there are times to gather up the trolling and put them in a basket.
What is
okay? So let's hear a non-troll from Lori. What is proof to Lori?
Well, firstly, there would need to be a distinguishing line between proof and evidence. I'm not sure if I can go there, but I can at least try to figure out what's evidence.
Well, the question's about proof. I don't know if SE wants to mean what means evidence as well.
Well, then I will say
you can talk about.
Then I will
both
say I
because
cannot
some
answer
say
the question, and you take a crack at it, Don.
Sorry, evidence is fine. He says.
That's fine with me. Thank you.
Oh, go on. I didn't mean to stop you. What is evidence to you?
No, if you want to be a troll, then I'm just taking a step back and giving you the floor, and that's it.
Come on, forget it, Lori. We were doing good. Let's not get off track.
Yeah,
I'm asking you. Forget about what Don said. Now I'm asking you, a non-troll, Lori. What is proof? Let's get back on track.
I would partly be willing to agree as well that proof is a sort of a vague concept that we cannot really have because we can't have 100% certainty.
So
and I think there are good reasons for saying that.
No proof.
So you're of the opinion that there can be no such thing as proof.
Yeah, I would say so. I think there's degrees of evidence. And yeah, technically speaking, in everyday speech, you could just call it proof. But if you want to be technical about it, I don't think 100% proof is something we can get at.
Okay, fair enough.
Yeah, that's fair enough.
Nothing is wrong or right. It's your opinion. Anybody else want to take a crack at it?
gonna have to hear yours, SE, before.
Sure, fair enough. For me, proof is something tangible, something that I can explain to somebody, give it to them, and they can repeat it. Something like that.
It can be handed to someone before they believe it, and they're holding it. They're holding the proof, like your explanation, your PDF.
Yeah. But it has to be repeatable. You understand what I'm saying? Tangible, repeatable.
What does tangible mean again?
Well, something, it can be a wishy-washy thing. You understand what I'm saying?
Real, not hypothetical.
Like I can't say something about the Big Bang, for example, and provide you proof of that. You understand? Reality. It has to be based in reality.
What about God? Could you prove God tangibly? Just as an example.
No, I can't.
But you could say to
But
someone,
that's just me. That's
feel
my
it in
personal.
your heart, bro. Like that would be tangible, maybe. To feel it in their heart. Wonder.
That's a different story. I mean, a feeling, or love. Can you explain that? I mean, you're going down a path.
You mean some
We're
type
talking
of
about
repeated
proof.
hard test?
Proof.
Right? Repeatable hard test.
Yeah. Repeatable, explainable, and you can pass it.
Convinced by it. If I just say, okay, I've done the hard test that you explained, I understand what you mean, but I still don't believe the result. Does that mean I've got proof, but I can't accept it? Or does that mean it's not proof to me?
Well, in that sense, proof is personal. Yeah. Like, I mean.
That's what I mean by, yeah. After the hard test that you've said is a good idea, it's then down to every individual to just decide if it's proven or not.
Yeah, I'm not about forcing stuff on people, I'm just on a project to, like, if we can come to an understanding of what proof is, then maybe we can move forward.
What I'm saying is, let's say you gave me a hard test to repeat for Flat Earth. I did it, and I said, I understand your reasoning. It's a good test, but it's not proof to me because it hasn't convinced me the Earth's flat. Is it then hanging in the air? It's proof for you and not proof for me? Or is it proof that I can't accept?
Well, first of all, I'm not talking about flat Earth. I'm talking about in general.
Well, that's just an example. If you were going to try and prove something to me.
Well, I guess that would be up to you. I guess that would be up to you if I gave you my proof, right? What I think is proof for me, and I presented it to you, and showed you how, and I explained it to you. Now it's up to you whether you accept it, but it's my proof ultimately.
It's your proof, but it's not mine until I accept it.
Yeah, that's basically how I think of it. Yeah, but that's just me. Anybody else want to take a crack at it?
I agree.
I actually want to say I kind of liked your definition. We might disagree on it, but possibly I could try to push you on it. But I liked how you were concise and how it was immediately graspable. Like I immediately got where you are coming from. So I kind of like your definition or your answer to it, Montreal.
Well, thank you, Laurie. Anybody else want to crack at it? I mean, you can't be wrong on this. It's just your opinion. There's no wrong, there's no right.
I would say that a proof is something that can be verified to be the cause of an effect. If you can demonstrate that something is the cause of an effect, then you have proven what the cause of the effect is.
Yeah, that's basically what I was saying before without saying that. Thank you, Travis. Yeah. Cause and effect. If you don't have cause and effect, you have nothing. That would be my first thing of proof, cause and effect. But that's just me. I don't know. Don't talk about me. How about JJ? Has JJ given his opinion?
He might type it out if he's listening. I can read it.
I might push a bit on what Travis just said there. Like, I don't have anything against cause and effect, but sometimes there are different kind of studies that you do in science, and one of the studies that you can do is basically look at a phenomenon and categorize what's there. So that's not looking at the cause and effect, but you can give good reasons as to why this thing is a real part of this phenomenon that I'm looking at. So you could say that it's proof and it's evidence, but it's not pointing to an effect or a cause.
I kind of lost you there. You're saying cause and effect, right? But then somehow not that's not the cause and effect?
Here's what I'm saying. Let's say science can be thought of sort of going into a conceptual space. So you're trying to map out reality. Sometimes what you do is you kind of categorize what is there. So for example, let's draw an analogy. You're moving to you're doing a voyage, and then you look at what's there, and then you say that there are these types of animals and these types of plants and those kind of things there, and then you make some sort of category, and then you can, for example, say there were these animals and they ate those other animals, and that would be evidence and proof for those animals being carnivores.
Yeah, you see them eating meat, right?
Yep.
Yeah, I could agree with that for sure.
Yeah, so
if that
so
ain't evidence and proof that they eat meat, I don't know what is, right? Perfect, Laurie. Yep. That's great. That's one of the best proofs I've heard.
I would say this, for listening to Laurie and thinking about it. We can prove things exist by defining them, and phenomena are happening by looking at them and saying, look. But we can't prove the cause and effect bit without doing some type of test, like SE was saying earlier.
Yeah, you'd have to do a test to prove the cause and effect, right? I mean, that's just logic, right?
I can prove a cause and effect to myself by believing someone else's tests, but a test needed to be done.
Yeah, okay. Yeah. And somehow you witnessed that test and you proved it to yourself to be accurate and acceptable.
Or I just trusted it was done and I understood what it meant.
But now when we go into the trust factor, that's a whole different, that's a belief. Now we move from proof
I
to
still
belief.
call that proving myself. If I don't have to measure Earth, I can believe someone has, and that's proven Earth's shape and size to me.
Sure, I'll grant you that, but you have to, well, you don't have to. I'm asking you if you would admit now we're moving from the proof to the belief department, like we're in a different part of the university.
Well, no, I still use the word proof. That's my point. Proof is when I decide the evidence is good and the test is good and I've trusted and believed it. That's proof. So I've proved Earth is a globe to myself by thinking about it and watching stuff. Yeah. And looking. And then I thought about it, and then that's me proving it to myself by thinking.
You'll have no disagreement with me there as long as you say you proved it to yourself. I'm fine with that.
Yeah. Then I would extend it, and I could prove it to someone else by helping them think about it without doing any science.
There we might have a beef on.
They would have, if they believed me and trusted me and understood it, and then decided to themselves, yep, that's such a good explanation, and I believe it all. They've then proven to themselves Earth's a globe with no science at all, just with me talking.
Yeah, but now we're in the belief department. Come on, you must admit we're in the belief department.
No, it's proven because it's all come from a test that I explained to them. So it's word of mouth, but it's from a real test.
Which they did not verify themselves, so they chose to believe you, which believed somebody else who done the test.
Yeah.
Correct?
My argument is that's still called proof.
All right, if that's what you believe, just don't try to convince me of that and we'll be fine.
But you already said it is a personal thing.
Yeah, personal thing
So
for you, right?
whether you believe it or decide.
Yeah, I'll accept that that's what you believe without any
You
argument.
agreed. You said that. You said proof is a personal thing in the end after the test.
Yes, and I'll agree with that and I'll stand by that, yeah.
It's a little bit contradictory.
As long as you don't try to convince me of what you believe is proof, which I don't believe is proof, because now we stepped into the belief department.
I'll only
Understand what I'm
convince
saying,
you
Don?
if you want to be helped. I don't.
Excuse me?
I don't want to waste my time trying to convince you if you don't want to be helped. You'll have to say, Dawn, can you explain and prove Earth's a globe to me? And I'll say, yeah, of course.
No, I don't want you to explain Earth
Exactly,
is a
that's what I'm
globe to
saying.
me.
So I want.
Yeah, because this is not about the globe. This is about me asking different people's opinion on what proof is. That's all.
I'm just saying I could prove something to you if you allowed me and wanted me to.
But that's not what I want. That's not what I'm asking here. No disrespect. We can have this conversation at another time, Don, but I'm just asking for what different people's opinion of what proof is. So no disrespect to you.
No, it's fine. It's just no one else was talking. That's why I'm rambling.
It's an interesting topic. That's why I'm asking people, because I don't think I've had the same answer from two people, exactly the same.
Yeah, a scientific version of proof that can't happen. So why do you use that as a scientific term if it's impossible? That's the question. Why don't you just drop proof to a colloquial term like, oh,
Well, I'm trying to move forward, and your opinion is valuable, right? But
that's my question to them, Essie, to Funk and Laurie. If it's
okay.
impossible to prove something scientifically, why are you trying to use the word prove in a scientific way and explaining it as if that's what it means?
That's a good question, actually.
I'm not sure that's a word that I use myself. Like, I think there's a semantic difference between the word prove and then the noun prove. Those are, I think the semantic space is actually quite different.
That's interesting. Maybe I haven't looked at it. Just try and assume it's the same.
Yeah, one would assume that they are the same because they are very close, but sometimes it's not. Language just doesn't work that way. Sometimes it's not so systematic because it's man-made. Like no one makes up the rules. Language just happens, and sometimes it's messy like that. Sometimes it's not the one-to-one match, even though you would think that it is.
You can say, as a nerd and a global scientist person, this is a scientific proof, but nothing can be scientifically proven. Right?
I know a bit about the language that scientific papers actually use. So normally you don't actually see strong language like this proves that. Instead, you would see that this seems to indicate. So that's called hedging, where you say, I'm not claiming this is 100% exact, because I might have made a mistake. There might be something wrong with my methodology. My sources might be incorrect, but it seems to be the case that. That's actually the kind of language that science actually does use
Yeah, I do believe
most
it.
often.
I'm thinking after they do their paper and they're really happy with it and they think it's correct, they shout to themselves, "This has proved it," even though they've written in the paper. This strongly suggests.
That's plausible. At least the way that it gets written about in the media, in newspapers, in textbooks, that language is way different, and I actually dislike that very much.
Yeah, they
So
say scientific proof.
yeah,
don't they?
yeah, the scientific paper says this seems to indicate that, and then someone writes in the newspaper, science has now proven.
Yeah, that's
And I
even
think
worse.
that's misleading.
I don't want to
Very
throw
well
away
said.
the word
That's
prove, so I use it colloquially. I've proven to myself this.
they use proof where there's no proof, and where there is proof, sometimes they say there is no proof. I find that kind of funny.
Can I ask a question besides the one I just asked?
Of course, bro.
Okay. Can we say that there is proof that refraction displaces an object?
Yeah, sure. Up to me, refraction moves stuff about in the field of view. Yeah.
All right. So, how would you incorporate the language of scientific proof in that discussion?
So you've already proved it. We can prove it by looking at the bendy straw that stuff refracts, and then you just have to take loads of images through atmospheres and look at them and think about it.
Okay. So, has science then proven that refraction causes the displacement of objects?
Yeah.
Okay. Anybody else?
What do
So
you mean by
science-
displacement, Travis?
Well, if we limit ourselves to the discussion of placing a straw in the water, we can see that the straw apparently enters the water at one point, but then refraction displaces the lower part, which is in the water, so that the physical straw and the image refracted aren't symmetrical. There's displacement of the image.
I don't think anybody will disagree with that, right? On either or whatever side.
Okay, so I would feel comfortable that that is a scientific proven phenomenon. So science does prove things.
Yeah, I think that you can make that argument.
Anybody else?
Well, what if somebody finds something out and you were wrong? Can you do you retract the proof then, or?
I suppose that you can create any what-if scenario you would like.
Mm-hmm. That's true. So that happens a lot. Like we think some things and then we are wrong, and then yeah.
I tend to think that the description of theories that stand as simple hypotheses, because there could be other later discoveries that replace the theory. I think that those instances only exist in metaphysics. That is, where you are presenting concepts and ideas for which you have no proof. So there could also, so if you have an idea about what causes the retrograde motion of Mars and you think that it could be this, right? That's a metaphysical explanation because it's not empirically, it's not a natural phenomenon that can be empirically tested, manipulated, and repeated. So if you have an explanation and then someone comes up with another explanation, that is simply concept. So when we get into the area, in my opinion, when we get into the area of natural physics, there is only cause and effect. And you can always have certainty that this cause and effect is a proof of the event.
I would say that even if you have what you can say is, if you word it carefully, you can say, when I move this happens. But I think it's should be very careful by saying that this definitely is or how you conclude with it. Like, for example, that this will directly change this.
So if you have a golf ball set up on a tee and you strike the golf ball with the golf ball club, are there any other causes?
Most likely, no.
Do you have what leads you to make the qualification most likely rather than just no?
To be scientifically precise.
You see, that's how they have your minds all jumbled up. Travis just gave you a simple example of a proof, right? Albeit crude and not scientific, right? And your brain just went, you went to what we call the cog this event horizon. You know that the answer is no, Travis, nothing else but the golf club hit that ball. But yet you went to that part of the brain where
I would conclude
you have to go to the model.
but I couldn't say 100%.
That's what he's describing. Right. There's no reason for you not to say 100%. Yes, the only cause.
The reason is because it's a very big if. But what if there was a gust of wind who knocked the ball right as you hit it?
Yeah, that's the cog this talking now. Yeah.
Right.
No, I'm just asking you, is that impossible?
Okay, great. Do you have an example of that happening? Because you're creating a what if scenario where I didn't give you those parameters. So here's my question.
That's the what if.
Hold on.
And that's true. And that's real.
Okay, here's my qualification. If there's a golf ball set on a tee and you swing the club and you drive the ball 363 yards, did a gust of wind do that?
Most likely no.
Why are you saying most likely no? The answer is
Because
no.
Could be.
The answer is no.
Not to be precise enough, I would say. I would never use that language. I would say it colloquially, yes, no problems. I would say colloquially 100% golf club hit the ball, and that was caused it to fly away. And that I would see there is no reason to consider anything else. But for the sake of language, you can't use the language which will say I would never explore any other reason. If some evidence come along in the future, however absurd it might be, if the evidence comes there, are you gonna say that, well, I'm not gonna consider it because we already concluded 100% that there cannot be anything else, so I would never consider anything else.
So again, in a hypothetical situation that isn't real yet, I don't have a problem saying if there is other evidence that comes up that demonstrates a cause and effect,
then but that's in the future, right? So what you're going to do if you already proved it and it's in the future, you get this evidence. That's the hypothetical. You don't know yet. That's the point of why I'm saying.
Yes, but in my opinion, your hypothetical scenario cannot apply to the event that I described with a golf club striking a golf ball. So I would say absolutely not. In this instance, there is never going to be any other evidence that comes up to demonstrate that the golf club was not the cause.
Can you know that for certain by seeing the
Yes.
future?
I can know the future based on the laws of nature. Yes.
You infer the future. You can't know the future. I think only God knows the future.
What evidence do you have that there's a God?
I think if there is a God, he would be the only one who knows the future.
Why would
See,
you
we're
think
going
God
out into the weeds now here.
Yeah, I know.
We
I'm
even
just
made
saying.
a thing about this, Travis. I even came up with a term for this. Is the COG-DIS event horizon. This is where people, they know the truth, they know what they have to say, right? But they just can't because the model comes into play. They know they can't say that.
I like
you can conclude with it, but in the end, for practical purpose, nobody will consider anything else than there's that the club hit the golf ball. Nobody would think about like, we need to take into account if there is something else like a unicorn kicking it instead of the golf club.
Right,
Nobody will consider that.
Because there's no evidence to consider other causes.
Currently, yes.
No, if you can demonstrate the cause, there's no. Okay, listen. If you don't know the cause of this event and you think I think this might be the cause, and someone else says I think this might be the cause, I would say, well, here's my evidence for why I think this is the cause. And I say, where's your evidence? And they say, oh, I don't have any. I just think that this could possibly be the reason.
That's not the example I gave. That's not the example I gave. I showed you I'm talking about actual evidence that could change your mind. And if you change your mind, then you didn't really
describe
the first.
Yeah, but you just described a generality with no specifics, right? So you said, what if? So I answered you no. When you said, would you consider that there is possibly in the future the discovery of another cause of why the golf ball flew 300 and some odd yards at the exact moment you happened to swing your club? What if someone else came up with other evidence in the future? I would say that's impossible because we know the cause. The club struck the ball, and there's nothing else right now. There was no one else around but me and the cameraman and my caddy. There was no gust of wind. There was no fox that ran across our tee. Nothing, right? There's no
But
other
that was
reason.
your evidence. That was the evidence you have, but you were presented evidence that you didn't have.
No, you said what if. You didn't
Yeah,
present
that's the
any
what
evidence.
if.
Okay, look.
In my example, no.
Okay.
No. In my example, I give you evidence, not the evidence you told me now, because all this evidence support your theory that the golf club was the cause. I'm talking about evidence that prove otherwise, not the evidence you have. Some
You don't
evidence
have any other
you don't
evidence,
know.
though. You don't
It's
have
a
any other evidence.
hypothetical. It's a hypothetical.
There's no need for a hypothetical when you know the cause. That's why I'm talking about
the
Hold on.
That's the fallacy
Hold
here.
on.
Like, you don't know the cause if you don't know. You can't know what you don't know. That's impossible.
Okay. Yeah, the the simplicity of natural science is cause and effect.
Yeah, but in the sake of language, you don't prove things.
Okay, you live in a world that has to qualify because you have a world in which you operate by ideas and concepts for which there are innumerable possible explanations.
Mm-hmm.
I don't live in that world.
That's the only honest way you can live if you
No,
if you
I disagree.
consider. You can consider them. They might be ridiculous, and you can say, "Well, fuck that. I am not going to think so much about that." Then fine. But then, what if that's correct? Then you fucked up. So yeah, you have limitations to like resources. You can't spend infinite time on every single absurd claim. So of course, you have to pick what's best. That doesn't mean that they are not true. It just means that you didn't bother checking it.
Travis is trying with you, bro, but you just seem to be going around in circles and circles. If you don't understand,
I understand what
example.
he's saying. I understand exactly what he's saying. I just disagree because I think he's saying he can see the future by using the word proof.
Okay, technically, you used the phrase "seeing the future." I said I know that tomorrow this event will happen because of cause and effect. I know. Go ahead. Go ahead. Whoever you are.
Okay, sure. May I jump in quickly? I wanted to clarify a term that you keep using. How would you define a concept? And there is no gotcha here. I'm just asking a question.
A concept is something that is immaterial and expressed by, I guess, let's see. The cause of a concept would be human thought. And then that human thought can be expressed in human speech. So a concept is immaterial and abstract.
Thank you. I don't have a line that I'm pushing. I was just asking a question because I'm thinking about things.
I'm sure everybody's thinking about this proof thing, huh? You must admit it is intriguing.
Yeah, you're a troublemaker, Essie.
Here's what I was thinking. Meanwhile,
Here's what. Oh my bad. Well, here's what you ask is like a litmus test. Do you think you could prove the existence of water 100%? What do you think?
There you go.
Could we
Jeremy's on the
100%
ball.
prove the existence of water?
Does water exist? Can we prove it 100%?
100%, yeah.
Well, to me, water would be a concept, but I'm not trying to deviate from the question.
Careful now, Laurie. You can't take back what you say.
No.
I'm being friendly today.
We never can.
Can you 100% prove the existence of water, Laurie?
Here's what I would say.
It's a yes or no
question.
question.
You guys have been presenting a good case. For example, I could take some peeks at, for example, some phrasing that Travis uses. But
he's dodging.
For example, this question. I'm trying to answer the question, Jeremy.
It's yes or no.
Yes, but I'm not going to answer with a yes or no because I'm trying to keep. I'm trying to give a deeper
So
point.
you're dodging the question, which is what he said.
Well, I'm trying to go on a tangent and give a deeper point. If you don't want a deeper point, then I can just go and have
Let him
dinner
say it,
because
guys. Let
people
him
are
say his
waiting.
piece. Let him speak his piece.
See, here's what I'm trying to say. You guys have a solid point. I might push you on some things, but for example, the question of can we really honestly say that we don't know that the golf ball was driven to the hole because the club hit it? Is there any reason why we would doubt that? Is there any reason why we would doubt the existence of water? I can't see a good reason to. However, here is why I am not ready to say that we can prove things 100%. There are deeper minds than mine and yours that have been discussing this topic. And I'm not yet up to par as to what their thinking on this is. So before I would give my answer, and I'm not trying to just get what some wise teacher says, but I would actually look into the deep mind, like what other people have said and why exactly do people say that science doesn't prove things. I would look at the philosophical thinkers. Why do they say that? And then I would give my answer. Well, here's what I think.
So to be fair now to Jeremy, your answer to his question, can we prove water definitively, is to defer to some other persons? Come on, Laurie.
Yeah, that's not what I said. And I think I was quite clear because I did include debunking that idea in my answer.
Yeah, but see, I didn't even understand your answer.
Yeah, so was it yes or no? We can prove it was either yes, no, or I don't know. Which one was it? You gave a very convoluted answer.
Well, then my answer is then my answer is I only have a convoluted answer at this point.
You're not doing very good on the litmus test, bro.
So he tried.
You're failing. You're failing the litmus test.
I think that this would be another example of cognitive dissonance, right?
Yeah, but at least he's admitting it and joking about it. Yeah.
I don't think you can call it cognitive dissonance when someone is kind of saying that I need to look into this. That's sort of the opposite of cognitive dissonance, because the cognitive dissonance would be, I know this is the case, I just, God damn it. And I didn't do that, did I? So you cannot call it cognitive dissonance.
To be fair to you, you said that somebody else looked into it and you want to look into that somebody else. So, okay, fair enough.
Yeah, saying that I want to look into it, I don't think that qualifies as cognitive dissonance.
So is there a difference between trying to hypothesize how many angels can dance on the head of a pin and what the cause and effect of a golf ball flying through the air is?
Even more than that, if I may, Travis, the fact that he thinks that somebody has the answer if we can prove if water exists or not. Laurie, I'm sorry, bro, but that has to be a little bit of cognitive there. Has to be a slight bit there.
Sorry, what were you saying?
What was the answer?
You're saying that you're not sure if water exists, but you said that some other smarter people might have an answer to that, and you defer to, you want to look into that. Now, just the fact that you can't answer that.
See, here's the thing. I didn't say that.
Yeah, I'm trying to figure out what you did say. Did you say yes, no, or I don't know about proving water exists 100%?
If you guys don't understand what I said, maybe you should stop trying to
clarify
reframe what I said in order to get a gotcha and get me to be cognitively dissonant. If you didn't understand my
tell us what you said, Laurie. Let's not
go. Did you say yes, no, or I don't know?
It's no use. I'm going to eat. I'm going to eat dinner. People are waiting for me. So instead of trying to get me to be in cognitive dissonance, just give it up.
Real quick, yes, no, or I don't know.
Yeah, he did this earlier to me.
Hold on, Travis. Yes, no, or I don't know. What was the answer? Just to clarify.
I'm going now. Bye.
Just you could have answered.
He can't answer that. He knows he can't answer it, bro.
You guys need to, whenever Geo publishes, however he divides today up. Earlier this morning, probably around 6 o'clock Eastern Standard Time, Laurie and I had a very, very long debate. And as soon as I did exactly what you, Jeremy, and SE did, and that is press him because of the words he used, he ran away.
See, that's the cognitive event horizon. That's where reality meets fantasy, La La Land. You know, that's where they go. That we were discussing this in on Next Level today, and this is exactly what just happened there.
This isn't an intellectually honest conversations we're having with these people.
Absolutely not, Jeremy.
You know, and what's tragic about this is that even though we have people that I think have the ability to have these conversations, like let's say Dr. Phil Bell, and I don't know, Mr. Sensible's not a doctor, but we can't even get honest conversations with people who actually have the mental acuity to have these kinds of conversations.
Bro, speaking of Dr. Phil Bell, I asked him, when does a straight line start to bend? After we agreed upon that, straight line. You know what he told me? Think of an ant on a basketball.
I see. You should have heard what I think it was Phil Bell. I was in Gems about 3-4 days ago. It was real early in the morning. I walk in and it's him and Concave Earther, and they're talking about space time. And Phil, I think it was Phil. I'm not sure, but he goes, "Well, space time is just a coordinate system." And now they're all backing him up. I mean, I'm like, well, humans invented coordinate systems, so space time didn't exist before humans. They weren't bending things, causing things to travel in geodesics, or space time wasn't bending to make objects drop on planets before humans. Like, it's just so disingenuous, dude. Even those people that are supposed to be smart, the professors and shit, they're just not honest with it.
No, they won't admit any faults. It's like to the T, whatever is written down. Space-time, fabric, yep, that's it. We're going with that.
The coordinate systems don't make things happen in reality. They just tell us where they are. It's a man-made concept, a coordinate system. There's no natural coordinate systems. So it's just so I freaked out on him. Jem was right for yelling at me because I was calling Phil all kinds of names over this. I was dude, because they've been telling us for years space-time bends, causing objects to fall on Earth. That's gravity, right? Einstein saw properties. He found properties of space-time. Like, that's not a fucking man-made coordinates. He didn't find properties of a man-made coordinate system, did he?
That's a good point. Yeah. Whenever you challenge their model, they go crazy. That's why we try not to talk about their model as much as possible. I know it's hard, but no. Try to keep it simple. Straight lines, level, water. Proof, logic, reality.
I will say this, based on what I said earlier just now about not having an honest, qualified specialist. I don't know if anybody saw the interview that I put up on my channel of the PhD in astrophysics who is in charge of the Georgia State University's hyperphysics website, where he presented the science of atmospheric refraction. I had an interview with him last year that went really well. And at no time, when I offered up my explanations for the Aether band, a term which he did not object to, he was very receptive to my explanations and simply said, "You bring up some very good and interesting points." I have a scheduled follow-up discussion with him for this Saturday. All things considered, it should happen. But my point is that, you know, in the past 4 years of my trying to have these conversations, I have this one guy who is open and willing to have this discussion. What's interesting too, though, everyone out there, is that I offered up a criticism of a couple of paragraphs on his website where he put up a diagram of an inferior mirage, and I explained why I thought that it was incorrect. He corrected it and gave me credit for it on the website. I thought that was pretty impressive in terms of his integrity.
Good. I wish you luck. Hey, you know what? I noticed Paid NASA is in the chat. I don't think we asked him of his opinion of what proof is. Hope I don't regret this.
You're gonna regret it.
I know.
Immediately, if not sooner.
I know, Jeremy.
Ask him about the water thing, because that's a really good that's a good litmus test that'll show you whether you know what they're saying is genuine or not.
Yeah, that's good. I really like that, Jeremy. Let's start off with the what proof is. Paid NASA shill. What is proof to you? Is he here? Is he gone?
He says he's not going to talk to you.
The does water exist thing? There's only 3 reasonable answers, right? Yes, no.
The one time when you want NASA to talk, he doesn't freaking talk. Oh, the irony. Have you got him muted or something, Jeremy? Travis?
I didn't hear you say that again.
Have you got Paid NASA muted for some reason?
Oh, yeah. He was muted the other day, but he left, and so I couldn't unmute him. So hold on.
I knew there had to be some reason why he's not talking.
All right, he's unmuted now.
Oh, he just said not going to engage. Wow. I think this is the first time ever Paid NASA shill was given an opportunity to talk and he didn't take it. Wow. Still not going to engage this topic, he typed. Why, man? It's just your opinion on what proof is. I'm not asking you what was your first date or who was your first date or something like that. But hey, I'll respect your opinion, whatever. Why would a question like that scare somebody?
It's a scary fucking question, bro. If you're not being you know, honest, you know, if you're not being intellectually honest about the conversation, it's a scary question.
I guess, yeah.
Yeah,
so you'd rather go to space. Sorry.
I was just going to mention NASA shill didn't want to engage with the subject, but now he's gone and looked up a Forbes article and engaged. So
Yeah, he wants to go to space. It's this particular topic that he won't engage in. If I ask him anything else, like watch this, NASA, what's a black hole?
Oh, he did engage. He's got out a link that says scientific proof doesn't exist. So I'm just laughing that he did engage after saying he didn't want it.
You know why they started saying that scientific proof doesn't exist, right? It used to be you could prove things, but everybody realized how they're doing pseudoscience, and their pseudoscience doesn't prove things, right? when you follow quote unquote QE's method of science, I don't know why these guys think he invented a method of science. Anyways, when you follow QE's method, it does prove things. You'd be doing actual science. When you stray from that and you don't have independent variables and no controls or anything, and you're just looking at stuff, yeah, just looking at stuff doesn't prove anything, of course.
And the idea that scientific proof is a myth, who made up the myth? That's my question to NASA Shill.
Wow, I think we broke paid NASA Shill.
Did Flat Earth make up?
First time.
Did silly, dumb people make up the myth that scientific proof exists? Or did scientists make it up? Who made it up?
Look, if you're not doing the scientific method to prove cause and effect, right? Why are you even doing science for? Why don't you just go play volleyball or something? Why are you engaging in a learning thing? I don't get it. If there's no proof, if there's no cause and effect, you have nothing.
If you can say that there is a relationship between them without you being 100% certain, you think it's useless information?
Nobody said that. We're talking about proof here. What is proof to you?
That is 100% certain. That's 100% certainty, which a lot of Glober here disagree with. And we're saying you can't prove it, but you can show evidence that they are most likely have a connection.
Okay, let me give you an example, right? I come up to you and I tell you, Funk, I saw your girlfriend kissing another man. What would you tell me?
I will look into it.
Wouldn't you ask me for proof?
Even if a flat earther said it.
Yeah, depends. I mean, it depends on how it was brought up. I mean, if you say it, then no, because you don't know who I am anyway. So.
And how about if I was to tell you every day on her lunch break at 12:35, she meets a guy on the 5th floor. They go out in the back and they hug, they smooch, and I can prove it to you.
Yeah, I would ask, show me the evidence.
So we come the next day, we go to her office, we see at lunchtime, and indeed she's there kissing another man. Did I prove that to you?
Colloquially, yes. Scientifically, no. It's separate. It's separate.
I've got an answer for you guys.
So which would you choose, the colloquial part or the scientific part?
Both things would conclude with the same thing.
Would you continue dating this woman?
No, as I said, both of them would conclude with the same thing. So it doesn't matter if I took the scientific or colloquially language explanation.
But why would you break up with your girlfriend if there's no such thing as proof?
Because it's very compelling and strong evidence that it happened. So that's sufficient for me.
Okay, fair enough. I think I've proved my point.
Well, okay.
Unless you can't prove anything, then did you really prove your point?
I got a question. What if she said, what if you seen her like SE said, and you confronted her, and she said, actually, I was just colloquially with them. Scientifically, it never happened. Would you be like, oh, that's
what I was asking him. Yeah. Good one, God.
That's okay, babe. I'll keep you.
Because it's different how you apply. For the most things, I don't apply scientific method to decide things. For the most part, I just rely on like experience from before. whether they are like anecdotal or not doesn't matter. If it works, it doesn't matter, right?
You're just making a joke out of science. That's all you're doing by saying this
No, you're
stupid
applying
shit.
like okay.
Scientifically,
I
she
am
didn't
being,
really kiss him.
I'm being
Scientifically, it didn't
precise in the language, and if you were to ask scientists, they would say the same thing as I do.
I highly doubt it.
They would. I can actually quote and post you the quote.
That scientifically, his girlfriend wasn't kissing another guy on the roof. Go ahead, post
No.
that quote. No, I'm
No.
curious. I'd like to see it.
Not that specific.
What are you going to quote then? What's the quote?
So there is a lot of noise here.
Yeah, what's the quote?
The quote is that science doesn't prove things. It shows evidence where you evaluate the evidence and then conclude from that.
The scientific method, though, does prove things. But anyhow, it's to sit here and say scientifically your girlfriend's not kissing that guy after SE took you to the roof and showed you is the most ridiculous
Why are you
statement.
saying that when I said both of them conclude with that? Scientifically, you conclude that that happened.
Yeah, but you said scientifically you couldn't be sure or whatever the heck it was you said about it.
Saying that you don't 100% prove it isn't the same thing as concluding that it happened.
Saying that you can't 100% prove it is the same thing as that it happened?
It's not this. Sorry. It's not the same thing as saying that it that you can conclude that it happened. Because if you're like, I have looked at all this evidence, there is only evidence showing that it happened, then you can say from that I'll conclude that it probably happened.
Probably, but she says it didn't really happen.
Well, I can show you all this evidence that show that it happened. So.
Yeah, but scientifically, it's not 100% that it happened. Can we get married?
That is for me. I don't need 100% certainty to conclude with that.
It's 100%.
I wouldn't get it anyway.
Why can't you just say it's 100% it happened? It's crazy. Like, this is foolishness.
It's not. It is to mix up like everyday decision and scientific method. They're two different things.
So then why would when SE brings this up to you, you're foolish enough to mix them then?
No, I don't mix them. I separate them in their explanation. But if you were talking to me just colloquially, man to man, not scientifically, then I would say, well, yeah, that is proof that she did it, and that would be reason enough for me.
But scientifically, it's not proof.
No, not science. If you're going to define it scientifically, no.
Is there any proof in science in your mind?
No, I have said that hundreds of times. No.
I never heard you say it. That's why I was asking.
Okay.
So according to you, there is no proof in science?
You can ask me again, and I will still say no.
I just want to make sure I heard your... No, I won't ask you, and you don't have to be sarcastic about it. I was just making sure I heard you, so I didn't misquote you on a different day.
It's fine.
That is what they believe, absolutely. Said it before. Science doesn't prove things.
Yeah, but remember 4 years ago when they used to tell us that science proved Earth was a globe?
They still do.
Yeah.
They forget. They still get caught in saying that.
They still do it. Yeah, remember? The whole body of science is behind us. Remember what they used to say? It's a globe. The whole body of science is behind us.
Although Jen was good at saying the preponderance of evidence. He's he's trained himself well.
That is more precise because you guys like to quote mine and misrepresent our statements all the time.
Who's you guys?
You guys just did it now.
Who said quote mine? Who?
You said Globers say that the Earth is proven all the time, using that as evidence that science proves things. When if you were to ask
they do
a guy,
say that though. They do say it, dude. Within this arena, they do say that all the time. That's not quote mining. That
I'll
just
say it
happens
now.
to
I
be
can
the way
say
it
it
is.
now.
Yeah, but saying that and inferring that it's our intention to say that science proves things from that.
Can I say it now?
When it's part of everyday language.
We
It's the
use-
only thing.
So it's not what they meant. It's just what they said.
Not
They didn't
scientifically,
really
no.
mean it.
Oh,
Not scientifically, no.
I tell you, we used science to prove Earth was a globe, but we didn't scientifically prove Earth was a globe. So I'd say it.
But that makes a whole bunch of sense too. Yeah, that sounds great.
So, what was the conclusion? Was I cognitively dissonant?
Well, did you look into what you said about the water?
Didn't have time yet.
So
Karl
I reserve
Popper
the
has.
right.
I think the books that Karl Popper has written are quite thick, and they take more than it takes to take dinner to read.
Yeah, no stress. I reserve the right to give you the opinion after you answer that question that Jeremy asked you.
Sure.
You think we can 100% prove water exists?
That's the one.
That's the one.
What's your answer?
He's still
My
doing
answer
research
is
on it.
that's the
You're
one.
looking into it? You're looking into it? No problem.
Yeah, in my opinion, in order to really make a statement about this, one has to look at what Karl Popper has said. This is not so that I can leech off someone else get answers, but it's like this. We're discussing which is the best strategy to win at boxing, and then there's a guy in the corner who has won all his boxing matches based on one strategy for the past 100 years. In order to actually say anything about the topic, one has at least to contend with what the guy has said and what his strategy was. And Karl Popper is one of those guys that really needs to be contended with here.
So still a convoluted answer, not a straight answer. Yeah, I know.
Well, I'm just talking.
Yeah, but so you're not going to
Actually,
answer the question.
You know what he's doing there? He's going to the man himself that came up with there's no such thing as scientific proof. So he wants to see if he can find something in there. Which, okay, we'll give him time to read some Karl Popper, the father of no scientific proof.
See, here's how I see it. You guys are saying to Karl Popper, you are wrong. There is such a thing as scientific proof. And now I want to go to Karl Popper and ask him, what do you think of it? What do you have to say about this?
Yeah, you
what
should
is
ask
your
Karl
argument
Popper.
for it?
You should ask Karl Popper what happens when
Yes,
we find a black.
That's exactly why I said that I.
Yeah.
Will
you should ask Karl
ask
Popper
him.
what happened.
Yes.
You should ask Karl Popper what.
That's what I said that I would do.
Okay, can I finish? You should ask Karl Popper what happens when we find a black swan.
Oh, sorry, I was interrupting you. I didn't realize.
No shit. You should ask Karl Popper what happens when we find a black swan. All right?
Sure, I'll ask him.
What did we do when we find that black swan?
Have you found the black swan?
Yeah, we found some at one point in time. People thought all swans were white. Then we found a black one. What did we do when we found the black one?
So what does one do?
What happened when we found a black one? What did we prove?
Yes, exactly. What did we prove?
You don't know?
I'm asking you.
No, I asked you. What did we prove?
No,
you
told me to go ask Karl Popper. You didn't ask me.
Yeah. Okay, I'm asking you. Do you know or do you not know what happened when we found the black swan?
isn't it a proof that not all swans are white?
So we did prove something. That's Karl Popper shit.
Sure.
Right? So according to Karl Popper, we can prove things.
Oh, that's falsification, though. That's saying, does this happen? But can't prove that you can't prove a positive claim.
Sorry, so did we prove something or not? With
You
Karl Popper?
Falsificate. In that example, it was falsification.
So we proved something.
No, because there could be infinitely other possibilities, positive claims that could also be true, which you have to individually falsify each of them. And even when you do that, you will never.
Is one of the possibilities all swans are white?
And even after looking at all the other possibilities, there could be other future ones which you haven't considered yet.
There's a possibility that all swans are white, right? Did we prove that that's not the case?
I think you in the Black Swan.
Holy shit, man!
You
dude. Whatever.
Let me ask him a quick question. Are you 100% sure you can 100% not prove anything with science?
Yes.
That's funny.
See? Fuck.
But when you say all swans are white, that's not like that's a different type of claim, I would say.
It's a positive claim. It's a positive claim. All swans are white.
You're
That's
saying
a positive claim.
You're saying, or you are saying, if one single black swan exists, that's enough for you to have evidence.
When you're saying all swans are white, that's a positive claim, right?
I would say I read a rephrasing of that, which is the more correct phrasing of it.
Don't answer my question again. I know I asked the tough questions. I know you can't answer them straightforward.
No, it's a good question.
Yes,
this is kind of like you could say it's a trick question, kind of. It's like asking, are you...
No trick. If I say all swans are white, that's a positive claim. It's not a trick question. I don't know what kind of bullshit word game salad you're trying to play with me, but it's not working, dude.
He actually answered the trick question. Fucking guy.
No, let me look up. I'm gonna look up the proper question.
So I've been wanting to have this conversation for a while on falsification.
Go ahead.
Hear me? Okay, hold on real quick. I gotta turn this off real quick. So I was finishing up where I was delivering, so I didn't hear everything. Does anyone want to clarify your position on falsification in terms of the scientific method, just real quick? I don't need a lecture on Karl Popper. I just want a general idea about like what falsification is and if it's a valid step.
Well, I mean, if you falsify a positive claim that all swans are white, what's your question?
Okay, so I'm sorry. If there is a baller who would like to summarize the idea of falsification and its place in the scientific method.
Okay. I just read on it a little bit. I just needed to gather my thoughts. So, like in this case, all swans are white is the positive claim. And all you need to disprove it is just one non-white swan.
And when you disprove it, you're therefore proving that not all. You're making the... Go ahead.
Yeah, but that's a negative claim. Not all swans are white.
It's not a claim anymore. It's a proof.
Hold on. This is so again, just a general snapshot of what the idea of falsification is. Like, what is falsification? And then does it have a legitimate place in the scientific method?
It's like the core thing of scientific method. It's
Okay,
like
because
literally.
that's interesting because Flat Earth Math Charles says he doesn't think falsification is actually essential to the scientific method. So that's interesting. So you said it's a core element to the scientific method.
Yeah.
That's great. Okay, so then what is falsification then? Just for clarity, just for the discussion.
It is what you call it. I don't remember the exact term. It's the modus tollens. It's basically that we can't prove that all swans are white because you don't know if you have seen all swans or not. There might be an extra swan that you haven't seen.
We can prove all swans aren't white.
You can. No, you can't prove that either, because
we can't prove that.
You can prove that. Oh, sorry. I misheard you. I thought you meant you want to prove that all swans are not white.
Yeah.
Yeah,
can
but
can we prove all swans aren't white? 100%.
Yeah, I would say that's falsifying the fact that all swans are white.
Okay, can we prove that swans come in more than one color? 100%.
Yes, but I wouldn't call that positive claim. So that's not like.
Here's my positive claim.
Different.
All swans. Here's my positive claim.
Swans are not
swans
blood.
come. Here's my positive claim. You ready to listen, or?
Yeah.
My positive claim is all swans are not the same color.
I just is that
Yeah.
colloquially, or did you say that colloquially or scientifically?
Can I pick back up where I wanted to go?
Travis.
Yeah, Jeremy hijacked me. Thanks a lot, buddy.
In my opinion, that's a
love
negative
you.
claim. But...
Love you, Jeremy. Nothing but love, brother. Okay, so falsification because I didn't feel like you defined it. You just gave an example of modus tollens, and that's fine. But so see if you agree with me on this. Falsification is an attempt to test your hypothesis by disproving it. So that when you do that, you safeguard yourself from prejudice or bias to force your hypothesis to be valid. Is that okay?
Mm.
So in other words, if I have an hypothesis about why something happens, the method, as far as I understand it, is to try and find other causes. Thereby, if I did find an other cause, I have falsified my hypothesis, therefore disproving it. Are we good with that?
No, I would disagree with that, because you're talking as if you have several premises, and many premises can lead to the same conclusion. But you only need to But you only need the one premise to be false. Why do you say no?
Listen, because I said hypothesis. I didn't give hypotheses. I said I have an hypothesis. One thing.
Yeah, and then you had another one which also proved the same thing. Didn't you say that?
Okay. I have an hypothesis. Doesn't matter what it is.
Mm-hmm.
I am now going to go about testing my hypothesis by looking for other possibilities for the cause. So if I think that X is the cause, in order to prevent me from simply confirming my bias, I am going to intentionally put my hypothesis to the test. I'm not going to try to prove it. I'm actually going to try to disprove my hypothesis.
Yeah, that's actually what you're doing.
Okay, good. Okay? So here's a question that I have had for a very, very long time. We have the story that Aristotle was one of the very first Greek philosophers to suggest that the earth was round based on an observation. His observation was ships going over the horizon. My question is, how did he falsify that? Or
he didn't falsify that. He tried to. You have a hypothesis, and then you create a test to falsify it. It doesn't mean that it was falsified, because then the Earth wouldn't be flat.
how did he attempt to falsify?
He did that by I think he did that by taking the stick, and if it didn't fit a certain angle, if the angle was straight up, then that would mean that the Earth wasn't curved.
Okay, are you making this up, or do you have a citation?
That would be a test that I would say. That's how you would observe
Let me
it.
start over again, and if anybody else wants to take over, please do, because this is not fruitful. How did Aristotle test his hypothesis?
He tested it by looking at the shadows on the stick. Oh, sorry. Am I missing?
Aristotle.
Sorry, I'm mixing it. Sorry.
Okay. Aristotle, we are told, by professional PhD astrophysicists, that Aristotle knew the Earth was a globe because he saw boats going over the curve. My simple question, scientific community, how did he test his hypothesis?
He tested if if you could see boats not go over down below a horizon, then the Earth wasn't curved.
Great. Did you just make that up, or do you have a citation?
I don't have a citation at hand, no.
So you
Isn't that
You're
kind of
you're breaking up. You're breaking up, Travis. Travis, you're breaking up.
Yeah, that's how you would test it, right?
You're breaking up, Travis. If you can hear, you're roboting bad. He's asking you a very specific question.
Yeah, and I gave him a specific answer.
No, but you're just making shit up. You're saying what you think.
how you would.
Oh, there, you're back now. You're just making shit up, dude. He's asking you a specific question. How did he do it? And you're like, well, I think he used stick. That's not really coming even near close to answering the question.
The scientific method as we talk about the scientific method as we know it didn't
He didn't ask you your opinion. He asked you how he did it. He didn't ask you how you think you would do it.
He himself just observed the horizon and concluded from the horizon that.
Right. So how did he falsify his conclusion? Because he just observed something and came up with any old conclusion.
Well,
he could have just as easily come up with.
The logical language to explain it in that way didn't exist then, so he wouldn't explain it that way. But if we were to divide his test into what he actually did, logically,
can we get anyone else?
See what happened.
Yeah, can we get this guy to go on mute? Is there anyone else here who has
falsification? The concept.
Because I gotta leave. Can I say something?
No, I'm gonna finish now.
Hold on, let him say it right quick.
Give me a minute.
The concept of falsification.
You've talked lots. Let SC say what he's got.
Oh my god, this is so bullshit, man.
Punk, just
you
give
guys
me
are
2
trolling.
seconds, bro. You've been blabbering for minutes. I just want to say something and leave gracefully. Is that okay with you?
Yeah, if I get the next word.
Yeah, you're next. Thank you. I just want to say thanks, guys, for having me. I'm taking off because it's Euclid night over at Try Thinking, Next Level Discord. So thank you for having me, and I'll catch you guys another time.
Bye, SE.
Later.
Yeah, so I'm really not interested in anything you have to say. Does anyone else have a shred of honesty in them to answer
Well,
this question?
is it true? When was the concept of falsification established? When did we start using those kind of like methods for science? I don't think it was at that time. It was later.
We've always used them. We've always used them, bro.
We've always?
That's always been the way it is. Oh yeah,
So,
sure.
I
did they
think he's
use
missing the
word?
point anyhow. It doesn't. Point is, it doesn't.
No, because you want him to.
Hold on.
You want him to cite.
Let me
that
finish
he's-
my fucking
okay.
sentence. The point is, regardless if falsification happened last week or the time before Aristotle, if his claim hasn't been falsified, then how can he make the claim according to your own scientific fucking methods?
That's the thing. You want me to cite him, but I can't cite him because he didn't write it in that way. He just wrote an observation. He didn't do his demonstration wouldn't fit like our way of explaining things today.
Well, as Travis pointed it out, there's professional scientists that are using that as an argument.
Huh? You're
Huh?
skipping out the Indian.
As Travis pointed out, there are professional scientists that are using that as an argument.
Yeah, and I
Okay.
think you can. But when you want to cite him back in the day, establishing, you're just using what information you have and the way they explain it back then, of course. But he concluded it. It might be sheer luck that he didn't know about refraction. He could be wrong. He presented his premises, but he didn't divided it into premise, conclusion, falsification, tests, hypothesis, all these kind of parts. He didn't divide it into that systematic way, but still, it's the general sense of observation, and then having a prediction for that observation he had, although however limiting explanation.
Wait. You're telling me that Aristotle made a prediction?
Yes.
Okay, citation, please.
Again, you're.
Have you not figured it out, Travis? He's gonna say.
If he
why do we let these trolls? Why do we let these trolls in this place? These guys are absolutely worthless.
I don't think he's a troll. I think he's honestly that.
If the ground is flat, then something can't go behind it. If the ground is curving,
No
then
one
something
says
can
it
go.
does. No one says. No one says
Yeah.
it does.
So okay, so that's fine. So then we agree on that. So then, if he sees,
No one even
boats
claimed the ground was
going-
flat.
So if he sees that the boats are going behind the water, he is
They're
concluding
not.
from that.
They're not. They don't
Well, it
go
looks
behind water.
It looks like that.
What if it's a big swell out there? Like,
Yeah,
you don't
well,
even know the
that's
conditions.
my whole.
What if it
that's
was?
my.
What if he was a complete idiot and it was foggy that day? And he's
That
like, "Oh,
could
look
be
at that!
as well.
It's disappearing."
That could also be. That's why I'm saying this wasn't a proper
But
scientific
you guys
test.
still use the argument.
Yes, because he was correct. So historically, it's need to present him because he
Okay,
did
you
so,
are-
but he didn't know
you are
all
aware.
the. Hmm?
Right? You are aware that there is a claim for falsification against Aristotle.
Claim? Who's claiming? Who's? But it sound like very law. Like did somebody have a claim on?
This is my I have a claim that falsifies the alleged observation that boats go over the curve.
Yeah. So you say.
Yeah, that's right.
That's fine, and I'm saying that's like the whole idea of I told you the premise he had, and he followed that premise from the conclusion, although he didn't say this is my premise, this is the conclusion. He didn't say it that way, but logically it's the same thing.
if it can be demonstrated that refraction causes the appearance of boats to disappear beyond the horizon, then it is not the result of the curvature of the Earth. If it can be demonstrated that refraction, with or without mirage, can cause the appearance of objects to disappear beyond the horizon, then it is not the result of Earth curvature.
Yeah. Let me. Can I try to rephrase how I would present that test? So in that specific observation, you cannot say from that specific observation that the Earth is curved. So in that case, if you want to use that as evidence, you would say it's inconclusive.
What are you talking about?
Because you can't, if your hypothesis is that the Earth is curved, and you're saying, well, I have this test and it failed the test.
That's not my hypothesis. That's not my hypothesis.
Oh my god, what's your hypothesis then? Please don't spend 5 minutes explaining it.
Okay, I'm good. I gave you an if-then, right? Do you not understand the if-then? So I have a statement. Here it is. There is an alternative explanation for the alleged observation that boats, lighthouses, islands, oil platforms disappear because of the curvature of the Earth. That alternative explanation is the medium through which the observation is being made. Which medium is understood scientifically as atmospheric refraction, either with or without mirage. That's my hypothesis.
Okay.
So there is an alternative explanation.
So you're saying that refraction is causing enough bending of light to appear as being curved, but it's really not.
No, not curvature. No, obstruction. Obstruction. It never.
Yeah,
presented...
but
no. Hold on. No.
But this the thing that is obstructing looks like the water is curving. That's like literally the only way that things can be behind other things. If you don't see a sharp edge on the water, but you still see things. Yeah, that's my.
There's never a sharp edge.
Yes, stop. Yes, I agree. Fuck's sake! Oh my god. So you never see a sharp edge, but you still see an object behind the water, and it's on like literally the surface. It's not floating.
Apparently, it's apparently behind the water.
So why isn't that concluding that the water is curving?
Because it can be demonstrated to be the result of refraction.
I'm not saying take your experiment out of this. I'm just telling that's if let's say refraction didn't exist, but you still saw this.
Whatever, dude. Whatever.
Then how other shape can it be than curving if you don't see any sharp edge?
If pink unicorns existed, why can't I have?
Oh my fucking god, you're stupid.
Oh, you're fucking god, right? Yeah. Okay, listen. We live in a world with refraction. There's no reason to talk about. There's no reason to talk about what if there was no refraction.
Do you have like any like way of thinking about objects, like conceptually in your head, without having to exist in reality?
Absolutely.
Okay, so picture a world where instead of light bending, light actually goes straight. Can you do that?
I'm sorry, you broke up. Honestly, you broke up. Can you say it again?
Can you picture a world where light don't bend; it just goes straight.
Nope.
So
nope.
So you can't think conceptually.
It doesn't exist, dude. We don't live in a world that
that is
no.
what a concept means. It's abstract. You don't. It doesn't have to exist. You're imagining it, how it will appear in your head.
No, I am.
So you can't
I'm
think
not going to concede.
conceptually. It's not about conceding. It's about having a brain and thinking.
No, sorry. Yeah, I don't.
My fucking.
You're fucking God.
Have you ever like have a thought about some? Have you had a dream about something that wasn't real once?
Dude, whatever, man.
Well,
Is
have
there
you?
Anybody else? Is there anybody else here?
No, Travis. No. Have you ever had a dream about something that wasn't real once?
Let's talk about reality, bro. We are wasting so much time.
Yes, but you can conceptually picture a dragon in your head.
Right? I don't want to talk about dragons.
Okay, but can you conceptually picture them in your head?
Oh my God.
Well, can you? Yes or no?
Now that you put it in, yeah, I mean, I might as well be in the movie Ghostbusters and have the Stay Puft Marshmallow Man come after me.
Can you picture a dragon in your head, how it will look like, and then draw it on a piece of paper?
Listen,
don't cross the stream.
Just say whatever you want, dude. I don't give a shit.
Yeah, I understood that you gave up now, because this is the thing. It's just like trivial for like pretty much everybody else that you can picture lights going straight and not bending. It's actually, for me, I would say it's easier to conceptually picture it in my head. Straight lines are much more simpler than having curves and all that kind of shit. And if you can think about that can you also think about how it would look like if you were looking on an object, and if it's curving, and there is not curving, but if you'll see objects behind something, and then you might think, well, why is it behind that wall of water? There must be some like a wall of water, like Niagara Falls in the end, and you're traveling towards it. There is no Niagara Falls. How can it be below the curvature, below the horizon line, but not? Still, there is no edge. That's impossible. Other than if you're on a curved surface, then it's perfectly possible. And you don't need to. It does actually exist in reality. Just have a tinier version of a ball, which isn't the Earth, and you can place a tiny camera on that, and you can do this experiment if you don't have the imaginative power to imagine it.
I'm more interested in natural science. When you're ready to discuss natural science, let me know.
Everything I'm talking about now is nature. So,
okay, do you have an observation that you would like us to discuss? Something that was an observation. It doesn't have to be yours. All right?
Aristotle's observation.
That
the one
I said,
already discussed.
No. Let me be specific. Do you have something visual for us to look at as an observation?
I don't have a YouTube video. If you want to see that,
I didn't say a YouTube video, bro. I
don't have a P900 picture either.
Okay. Yeah, I'm more interested in natural science.
Everything I said was natural science. I'm not going to let you leave on that bullshit quote.
Okay, so show me an example of what you were talking about with this whole Niagara Falls thing.
Okay, so if you were on the top of Niagara Falls...
No. I did not say describe it to me, dude. I said show me.
You want me to show you how, like, things look in reality?
Yeah.
This is so stupid. Okay,
really?
I'll show you. I mean,
anybody else?
I mean,
please.
Do I have to show you a picture? I have to show you a picture of something like being behind like a hump or something, and then proving to you that if it's behind the hump, then then it looks like that.
I am interested in natural science. So if you have an observation,
that is natural. That is natural science. What I'm talking about.
Then show it the fuck to me.
Do I have to show trivial things like simple things like if you go behind
Yes,
a car,
please.
the car will block
Yes,
your
please.
body.
Yes, please.
It's fucking stupid.
You're the one that went down this road, bro.
No, it's your stupid road. You want me to show picture of things that are like, do people breathe? Oh, show me evidence that people breathe.
Okay, so let me ask you this question. What does your hypothetical situation have to do with my claim?
It has to do with Aristotle's claim and how he predicted things. It was my claim.
Okay, what evidence do you have Aristotle predicted anything?
How he predicted things?
No, I didn't say how. My God.
I'm posting an image of what you wanted.
Okay, no. You have made a statement right now that Aristotle predicted things. I'm asking you for any evidence of any prediction Aristotle made. And I must have you blocked because I can't see your picture.
I haven't posted it yet.
Okay. Okay, what does your photograph have to do with my claim?
It proves that when an object is in front of another object and it blocks it from you seeing it. Which I literally have to prove to you because I don't know, it's just stupid to be honest.
No. No, you were talking about Niagara Falls and shit, dude.
Yeah, I mean it's the same thing. It's just another type of object, whether it's
No. If you go back to your Niagara Falls, I didn't think anything of like a car and a guy standing behind an open door. Okay, I was listening to you describe Niagara Falls and shit. Do you have a picture of something with Niagara Falls and shit? Because that's what you were doing with your description and waste of time for the
I'm
past 10
saying
minutes.
if you're on top of Niagara Falls, a little bit, and you're like not standing on the edge, but a little further away, you can't see if there is a tree like directly below the end of the Niagara Falls, because right? Can we agree on that?
Okay, so what I hear you explaining is that you're talking about an observation at elevation beyond the physical limits of the land, and you're trying to get me to imagine reality, which it is. So yeah, I can imagine something beyond the topography of the land being hidden by the land. Yes. What does that have to do? Hold on.
He didn't have the concept of elevation back then.
Hold on. Hold on. Hold on. I'm talking about making observations over water. Water. So why don't we stick to that?
Well, you're not going to have a Niagara Falls in the middle of the sea. It doesn't exist.
Oh my God. Whatever, dude. What the fuck, man?
That doesn't exist.
I'm not talking
you want
about
an example
topography. It doesn't have to be Niagara Falls. You could just say, can you imagine a house being hidden by a mountain? Yeah, the fuck I can. What the fuck does a mountain have to do with making observations over the ocean?
Because the ocean is also a thing that can block whatever you're seeing behind it. If there is something behind it.
Great. Why don't you?
It's not like it's not magical, which is like I assume it's just water, and if you have some like piece of water in front of something else, then you won't see what's behind it.
Yeah, there is an alternative explanation to the description you just gave.
I know that your alternative explanation, but in my example, we were talking about Aristotle. He didn't know what refraction was back then. So from his premise, it follows. That's my whole point.
What evidence do you have Aristotle didn't know about refraction?
I don't have any evidence that he knew about refraction at all, I think, as far as I know.
So, again, you're just making shit up, dude.
No, I can't disprove that he didn't know about it. If there's no
Why are
evidence
you
that he
making
knew.
claims about something you have no knowledge of? You don't know he made a prediction. You don't know he falsified his hypothesis. You don't know he knew about refraction. Why are you making shit up, dude?
Oh, I can't. You're asking me to prove that he did know something. I can't prove you that.
You made
But
the
there is-
claim. Okay, listen. You made the claim he didn't know. Okay? So, what is your
That's
claim
because
based
there is
on?
no evidence of him. There is no evidence of him knowing refraction, and the concept of
Is there?
refraction
Okay, great.
wasn't
Great.
talked about before much later.
Okay, great.
So there is a lot of evidence that he didn't know about the refraction.
Okay. Yeah, great.
Lack of evidence is one of them.
Man? Is there any evidence he made a prediction?
He talked about the way he talked about it, and yes.
The way he talked about it. Talked about what?
The way he talked about how he viewed boats over the horizon. I need to find a quote.
Okay, so you have read a first-hand account where Aristotle is writing in the first person, I, Aristotle,
I didn't say
on
that.
this. Yeah, you said he. You said he.
I didn't mean that it was his
Then don't
own
say,
writing.
don't say what you didn't mean,
But
dude. That's why.
historical accounts.
Oh my god. Okay, find me any historical account that has a citation for Aristotle's alleged observation.
You want a citation? You want a historical article with a citation from himself? There
That would
might
be like
only be
asking
like
what school.
No. Listen. No. I want you to find me any article that uses Aristotle's observation of a ship going over the horizon that has a citation to it from anyone.
What are? Yeah, never mind.
I mean, there are historians who talked about
tell
him.
me.
And I
Don't
think
tell
he
me. Show
worked
me.
at a library.
Don't tell me.
Which he wrote a lot.
Yeah, don't tell me. Show me. I want a citation.
What college did Plato graduate from?
You don't want to get involved
Are
in
you
this,
asking?
dude.
What are you asking?
Well, I'm just
Yeah,
saying.
can we go back to discussing my hypothesis?
Well, first of all, let's talk about what a citation is.
It's a reference. It's a reference to information to support a claim. Okay,
So if
if
a person is the first one to discover a thing that is unrelated to, what was previously known, would you expect there to be citations yet? At that point,
where does the story come from? Where did it start? Like, it's got to be based on something, doesn't it, Grim?
no, I'm just talking about the point. Like, I don't care the ultimate end of the argument. It's just the one point, just so that we can all get a bearing on what's actually being said here.
Okay,
because it's not like I'm disagreeing or agreeing with either party in that aspect.
Okay, so I mean, I guess I appreciate your question to a certain extent. So the point of the matter is that whenever I have looked up this discussion of boats going over a curve, you can come across a dime a dozen articles that refer to this story of Aristotle, but there's no citation. So did they just make it up right then and there? Where are they getting this information from?
Yeah, I can see your point too, right? Like, but like I'm saying, if he's the one who originally, I don't even know if what we're saying, like, if he didn't take a fraction into account, then how is he for sure that this exactly was happening, and why are we using his numbers in the first place? I get that. Or if he even existed.
Yeah, but the same thing should be asked about the Biruni method, right? We can read the story about Al-Biruni. Show me the citation. Where did this story come from? Why does everyone have this same reference and same story, but no one has a citation?
It was like a thing. I agree. It's like a thing I read about the history of the speed of light. At one point in history, when people said the speed of light was this one thing, all the scientists were coming up on their own with that same number, and it was all on their own somehow, as if they were not discussing this together, and they all ended up using their same numbers. But then it changed, and then they all started using that number, and then it changed again, and they started using that number. And then
There was like,
they're always right. So
but
I don't get it either.
But they had like conventions which they all met up and talked together, so it perfectly makes sense that they sort of like use similar things, or like
I
the
agree.
whole.
I agree.
Yeah,
No, listen, I agree. But what I'm saying is, people use it in arguments as these are independent. They come up with these independent results on their own, and it's like, no, they have conventions where they get together and they, decide who they respect more, and they go with that. Like you said. So it's not always necessarily the truth that's gone with. It's the most favorable option at the time. And that's, I think, what the point is about this whole discussion is, yeah, at the time, this may be the more favorable option. And I don't know exactly what the topic ever, it is exactly this flat or round or anything, but electric universe or near standard narrative. It applies to all, right? So, I mean, just right now, it's the better thing, but there's, evidence coming around for different types of, understandings of physics. And
let me say this
again.
Let me say this just real quick.
Yeah.
If
Go ahead. I don't want to say
yeah, if the current science taught that the Earth was concave, I would be just as much against that for the very same reason. I would have the exact same hypothesis. Concavity is simply a misinterpretation of the observation, just like convexity is. The Earth never appears concave, ever. We are simply seeing farther into the distance because refraction has kaleidoscopically changed the field of view. But it's
What about
never.
What about the time? What about the time when George Hanna observes the horizon over eye level?
That's not concavity, because the entire
No
field
doubt.
of view, changes. So I can it's the as far as I can remember from what George showed, compared to the photos that I have, the times where the landscape appears higher is when the landscape is also dropped into the background. So it looks like you're farther away. So it's not just that it raises it up, it also drops it back. So if you can remember that trick of the camera in the movie Jaws, when Roy Scheider was on the beach and he came to the realization that there was a shark out in the water in focus, but tried to give us a visual representation of the shock and horror that Roy Scheider was experiencing by dropping the distance or the field of view into the background. That's what the Aether Band does. The Aether Band doesn't just simply raise the horizon up, it also at the same time drops it back into the distance so it appears farther away.
The strongest evidence I think we have in terms of Earth curvature is the fact that if the Earth is curving, then you would have like not an exponential, but like a cosine function. It would like exponentially increase.
Show me the measurement. Don't show me
in a
any
vacuum,
mathematical
maybe
equations.
in a vacuum, right?
I think that would happen both under some refraction as well. It will also drop.
Well, no, I mean, refraction as we think we understand it. What if we don't fully understand all the optical effects, that it's not just refraction, but maybe some other optical effects that we're still not, you know what I mean? Like
I would say
we have a
there
very
is
large
evidence for
confidence that there aren't these other things, right? But we can't say that there really aren't yet.
We can't say that.
I'm just saying for the sake of argument.
We can't say
not for the sake of winning or losing.
I know. This is what I'm saying. Yeah. This is science. So we can't say it 100%. But we have looked at other things. We have put it like in fucking we have magnets next to light. It doesn't. No shit is happening. We do all kinds of shit. We have
Right,
electricity.
That's false. That's false. Hold on. They found that magnetic fields do bend light.
I read.
Or they've been
I read
materials
that.
that move that
Which would
reflect
make the
through
light bend, right?
Faraday
Yes,
effect.
but then you
Yeah.
have to ask: does it bend? Yes, but how much?
Who cares?
how
You
much
just
is
said
it?
it didn't do it.
What's
You
the
just said it
intensity?
didn't do it.
Well,
It's kind
for
of like
the
you're
sake of
hypnotizing
any,
yourself by saying
for
things
the
like
sake
that.
of, if you need the world's biggest magnet to make light bend a fraction of a degree, then I would say yes, magnets doesn't affect light.
Wait
You mean
a
the
minute.
world's
Well,
biggest
how
magnet,
does
like
the
the
world's
magnetic
biggest
field in the
magnet compare?
atmosphere?
Right. How
You
does
mean
the
the
world's
world's
biggest magnet compare to the magnetosphere? Or how does the world's biggest magnet compare to the magnetic fields and electric fields of the sun? Like, how does the world's biggest magnet compare to Jupiter's? Like, how does the world big? Get out of here with that world's biggest magnet thing. That's just not even. Because I mean, come on.
No, don't take his fantasy
No,
away from him. Let him talk about Fantasyland. Go ahead, talk about La La Land some more.
It's not the
It's
world's
your
biggest
La La
magnet.
Land.
It's just a
So-
permanent magnet. The world's biggest permanent magnet.
Yes,
The world is
but
the
the
biggest
question
magnet.
is, nobody is saying how much it affects it. You're just saying, well, there is this effect, so
On the world.
therefore we should assume everything should be thrown away. If we know that there is an effect, if it's tiny, that it's like you literally have, it's only measurable in a special lab, then it wouldn't affect our observation over Earth.
Well, really? Because if you found one tiny little smidgen of dark matter, you'd be like, voila! Dark matter, it's real. We found it. It's everywhere. It's doing all that. We're right.
Oh my God.
Right?
Why are
I
you
mean, that's
red
if you found
herring
one
now?
little. Well, it's not a red herring. It's an example
Oh,
of how you're being
that's
hypocritical.
rich.
It's a red
That's
example.
rich. Yeah, you guys call out red herrings, right? That's rich.
It is
Well,
because
you'll find that
it's,
they'll do that a lot with me when it comes to the shit I'm talking about. Because those are defense
Yeah, we are
mechanisms
rich
that have
flat
to
earth
be
is
applied. You got to apply that type of tactic.
no,
Otherwise,
I'm
you just
saying
get really
if there
good with the
was a
information
case
and
that
fuck
you
that.
only had one smidgen of evidence for dark matter, then that wouldn't be evidence. But if you have evidence for curvature, I'm saying, well, that could be strong evidence for it light curving from magnets.
Right,
It
so
doesn't mean that it doesn't mean that it's enough to have any visual effect in our atmosphere.
What about if it's an electromagnetic in a plasma? Then would it affect light?
I don't know. You're just asking me questions which I have no idea.
I know. I'm sorry, dude. I'm not trying to put you on the spot. It's the
Yeah, I'm just saying.
conversation itself.
Nobody. You're just saying. Oh, we find
Just
this
talking about the
article
defense.
and read
Yeah.
the ingress, and it says magnetic fields affect light. Does that mean that we should throw away everything?
Well, once you realize that you're throwing away the magnetic fields, even though they do actually do something, does that mean we're
How
supposed to
much?
keep listening to you? That's
How
what I'm
much?
saying. Like yeah, but you don't know how much. It could be way more because you gave an example of a permanent magnet, which is, in my opinion, the very worst way to give an example of electromagnetism bending light.
But they
Because, I
have
mean, where's
the
the
article
electrode?
and they
And where's the
explain it.
medium? Like if you just
And-
imagine that astrophysics, right? And the medium in astrophysics, what they tell us is the medium is plasmas, particular types of gases, electric fields, magnetic fields. So then we're not dealing with permanent magnets anymore, right? We're dealing with a medium that you're looking through, a plasma, crystallization of a plasma to a soft form of matter that they'll now call the fifth state of matter. It's called plasma crystals. Light has to go through those. It's got a lattice structure, and that affects light in ways that we don't understand yet because we just discovered this fifth state of matter that permeates space.
Yeah, but I think you have, as far as I read on it, there are a lot of evidence against plasma, which makes it more difficult to believe.
I would like to see any evidence against plasma.
Okay, I have to look. Then I'll present it to you.
Sure.
Hey,
But-
in the meantime, Grim, I put in the chat a very interesting channel to me. It's a flat Earth philosophy, but he really deals with understanding the flat Earth model in electromagnetism. Now, I wouldn't be able to tell you what he says and how he says it, but I find it very, very interesting. So I put it in the chat for you to just check out, see if any of it like resonates, or if you're like, yeah, this has got nothing. But just for reference.
No, I think no, we did this right. I watched it. I remember this dude.
Okay. I think what he does in terms of explaining the star rotation, for me, was really interesting. So, have you seen those photographs of rainbows from higher up?
Yeah, the
Sky?
whole circle. Yeah.
Right. Think of Orion that way. If you look at a model like, say, Stellarium, and you have Orion transit the sky, it's in the shape of a rainbow, right? It's got 2 legs and an arch, so it's basically a rainbow. And Orion is riding the buffer between the northern and the southern rotations. But my point is, what if Orion is just like the rainbow in the sky, that it is a perfect circle, and then when we see it, we're seeing it like we see rainbows? That blew my mind when I thought of that. Did I break up and not come in clear?
No, I'm just. I mean, just because I don't agree doesn't mean I have to argue with you. You know what I mean?
No, but you understand what I'm saying? Do you understand what I'm trying to communicate?
I saw him like part 2, part 3. You know what I mean? Doing the Star Trail thing or whatever, and it's familiar. I just don't agree with him. I think it's just interesting to see where he's trying to go with stuff, and I like to look at people's train of thought and stuff like that.
But my point is,
That's all.
Okay, great, thank you. So my point is he doesn't bring up the point that I'm making. I came to this conclusion on my own.
Yeah, that's kind of what I was about to say. Like, I didn't, get that out of what he was saying either. So that's why I said I didn't want to argue with you. I'm glad you said that though, because that clears that up for me. Thank you.
Well, yeah, but all I'm trying to get is are you understanding the analogy that I'm drawing?
Yes, that I understand.
Okay,
yeah.
That's all I wanted. Yep, thanks.
Hell yeah. See, guys, it's pretty easy to have a conversation, even with someone you don't agree with, as long as you're polite, right? It's possible that I can do it. It's possible he can do it.
I had a great conversation with Druss this morning.
Yeah, and we had a good one too.
Bet.
What does the CDC say about the Omicron patients? Like 79% of them are fully vaccinated. Was that 4 weeks ago?
I don't think we're supposed to be talking about that on the channel unless he changed
Oh,
his
this
policy.
channel's protected. Oh no, this isn't the Jim Panda. I was gonna say Jim Panda somehow is obviously protected. You can talk about anything they want in there. Nothing ever happens to anybody. So
I mean, I haven't seen anything happen.
Forgot where I was for a second.
That's all right.
Some of the same voices are popping up in here.
Well, Grim, what's
I guess
your
as
opinion?
long as nobody gives me an answer, right? Then they're not spreading misinformation. If I'm only asking questions and no one gives me an answer, technically, no disinformation is being spread. And if we don't say the standard narrative, no disinformation is being said. Because I think nowadays the standard narrative is the one that's been popping up with all the misinformation, but nobody's taken the standard narrative off of Twitter and Facebook. All right, I'm done.
No, that's an interesting point.
Well,
Very quiet in here this evening.
Hello.
What up, Bob?
Every so often, somebody seems to post a question or something in this Reddit that I am I joined it a while back, called oh, let's see here. What is this one called? This one's called Our Flat World. And I don't usually go there and look at stuff or whatever, but I have it joined, and every so often like a post will show up in my feed, and I'll read it, and because somebody has like a question or whatever, and this guy he puts serious in brackets, so seems like he's indicating he's not just being mean or trying to poke fun or something. It seems like he wants a real answer. He says, why is the common flat Earth map an azimuthal projection of the globe Earth map and not something totally different? How do flat earthers know our continents look the way they do on flat Earth maps? And let's see here. There was there it is. Okay, so that's what the post is titled or whatever. So he goes into a little bit more here with the rest of his post. He says, what experiments or evidence do flat earthers use to acknowledge the shapes of the continents on their map? Why don't they think the continents look like something totally different? Wouldn't that better explain differences in flight times and other Earth phenomena? I assume no flat earther has seen with their own eyes the shapes of the continents, so then there must be calculations or deductions that result in shapes of the land masses they believe in. Why do they trust these calculations and not calculations that determine the Earth is a globe? So I responded to him explaining to him that calculations can't determine a globe. Calculations can't determine anything. That's not how calculations work. The calculations label things, they don't determine things. And I use an example of using like measuring some material for a project that you're doing. You measure your material at 4 feet per piece, and you determine that you need 5 of them to cover a 20-foot section. Okay? You just did a calculation. You took the 4 that you measured and you multiplied it by the 5 to get to the coverage of 20 that you need. You did a calculation. You didn't determine how big the section was. All you did was calculate materials. The section is whatever size that it is, whether you do the calculation or not. So the calculation can't determine the size. The size is the size. Okay? The calculation doesn't decide what the size is. I explained this to him and explained to him that basically the 4 and the 20, they're just labels. Those didn't occur in nature. Those aren't something that were naturally ascribed to those things, the pieces or the thing that you're trying to complete. Those are just labels that you gave to him. And basically, I go through an explanation kind of making this clear to him that the calculations can't determine a globe and that calculation isn't verification. It literally can't be verification. That's not what a calculation is. So then he responded and said, thanks for your time and explanation. Maybe I shouldn't have mentioned calculations because your answer doesn't address my question. And he basically tries again. How do flat earthers know the shapes of the continents on their map, the shapes of the land masses themselves? So he wants to know how someone who thinks the Earth is flat, how do they know what shape the continents are, basically? What evidence have flat earthers found that results in these land masses looking the way they do? If the flat earth community has not concluded with this with its own research and exploration, which experts or cartographers or evidence providers do flat earthers trust when told that North America or Africa look the way they do? And so I tried to explain to him the assumption, basically, that he's basing these things off of. And I'll read you my response. I think it's a pretty good response. So what I responded was, you are starting from an assumption. No one knows what the continents look like. Maps and images are all representations of what was seen when it was navigated. No one has seen an entire continent at one time. The navigation isn't based off of maps. The maps are made based off of navigation. The shape of continents doesn't matter in images or maps because it's all simply a representation of instructions on how to get to a place. When you go to the store, you can use a map. The map doesn't need to have correct shapes for the road, the store, the car, the houses, the park area, the swing set, etc. all of those shapes can be incorrect to reality, and the map can still get you exactly where you're trying to go. So in short, why would anyone mess around with trying to draw new shapes when the shape doesn't actually mean anything in reality? And we'll see what he has to say. I mean, he might be actually honestly wondering, why they wouldn't be different shapes, but it's like, and I don't know if it's like a purposeful trick or if it's just like a trick that happens, like people aren't thinking about it, but like it doesn't matter what shapes the continents look like on a map or any other image. It's not important. What's important is if the instructions for something say go this far and then you go that far and you get to the place, then the instructions worked. No matter, it doesn't matter what shape it actually is. What matters is, did the instructions work? You could draw, North America as just one giant circle. And you could just put in your instructions for how to get somewhere. You're at this place on the circle. Go west this many miles, go north this many miles, and you'll be there. And you could follow those instructions and end up exactly where you're trying to get to. And the circle is the wrong shape for America. It doesn't matter.
Are not those two the same thing though?
What?
Like in a conventional map, don't you think if you change let's say you changed America to a circle, don't you think that then your instructions also change into how you, and then you cannot get to places? I don't.
No, why would the instructions change? The instructions are just
That's how maps work.
A retelling of how somebody got somewhere before.
Okay,
so the instructions don't need to change at all based on the picture. The picture is just a visual representation of how other people have already done it. That's all.
Okay, so
it's not like they had the maps before they went there.
Yeah. Okay. Yeah. So let me clarify this thing. We take map. We change America to a circle, and then the instructions, since they are not the shape, the instructions are exactly what? Where are the instructions on the map if they are not the shape?
Sure, what you mean.
I'm not sure what you mean by instructions when you say that we can replace the map shapes and then there are some instructions that you can still follow. What instructions are you then following?
Here, let me go ahead and start a stream here.
If you have a grocery market, right? We don't need to know if the grocery market is in a circle shape or a square shape or a rectangle shape. If the instructions are the turkey's in aisle 3, you walk down a thing, you find aisle 3, you walk down the aisle, boom, there's the turkey. Right?
How does that translate in?
That's basically here. So I'm doing a stream right now, and I'll show you what I'm talking about. Okay. So let's say you're sitting over here. This is you. Okay. Whee! And you're trying to get to the store. Okay. Here's the store. Store. And we're going to represent the store with a triangle-ish looking thing. Okay. The store's not shaped like that. Okay. Now, let's say I want to tell you need to go to the right a little ways, and then go up a little ways, and then go to the right a little ways, and you'll get to the store. Okay? And I say, okay, just follow the squiggly line, and at 2 miles, follow the squiggly line the other way, and at 1 mile, follow the squiggly line the other way, and you'll get to the store. Okay.
Sure.
In reality, this isn't what I look like. This isn't what you look like. In reality, this is not what the road looks like. This is not what the sidewalk looks like. This isn't what the grass all the way from here on the way to the store looks like. This is not what the store looks like. But if you follow the instructions and go this way and then up and then over, you'll still get to the store.
So
the shapes didn't matter.
So that squiggly line is the instructions, right?
Well, the squiggly line is the path that you're taking. Yeah.
Yep.
Yeah.
Okay, so where are the instructions in this picture then? If the squiggly line is the path,
they're right there. So like, okay, so let's say I could do this. I can say first, and we'll say Lincoln, and we'll say Elm. Okay. And then I say you're going to follow Elm Street for 3 blocks, and then you're going to go up Lincoln for 3 blocks, and then you're going to go turn right onto First and go 2 blocks, and that'll get you to the store. Okay.
I see. Yep. Sure.
The store still isn't shaped like this. The road still doesn't look like this, and I still don't look like this. And none of that matters, and you could still follow the instructions using this map and still get there.
Sure. Okay. So if I want to, for example, let's say I'm in Finland and I want to get to Israel, the instructions would be something like, we cannot use Elm Street because streets don't work on that scale. Go towards Estonia, then turn right and, turn left, go towards Russia, turn right, and then go southwards, and then at some point you reach Israel. Is that how navigation then works?
I don't think that normally that's the way they would give the instructions
exactly
like that. That's more of a smaller scale. The way they would say it is go this way for a certain amount of miles, not towards a thing, which is fine, and then go a different way, a certain amount of miles. But that, again, all that does is show my point. It doesn't matter what the shapes are. You're just following miles. It literally does not matter what's beneath you. All that would matter is how far you're traveling. And it still won't tell you what shape the thing is that you're standing on.
So no one ever has done an actual map navigation and used compasses, or because
compass isn't based
someone
on
had done it, if someone had done that, then they would have found out that maps don't work.
Maps do work.
Okay, so the hold on, the maps do work.
Yeah,
maps aren't based on instructions like this then, or are you saying that the maps give instructions go Elm Street and then turn left? That's not on.
No. Okay, maybe that's where the confusions come in. The map itself isn't providing the instructions. Someone uses the map and then gives you instructions based on the map. Okay, but the map itself isn't based on the instructions. The map itself is based on what somebody else has already gone and looked at, and that's what they've put for what the map seems to be to them based on what they've seen. It's not like they had the map before they went to the places. Somebody had to go to the places first and then record what they saw.
And not only that, though, if you think about an atlas that has streets. So let's say somebody's familiar with their neighborhood, but they don't know the street numbers, but they know, okay, I know that you turn left here, but I got to give this person more specific directions. So they get the atlas out to get the street names, and then they give the instructions, turn left in 3 blocks, turn right in 3 blocks. So it does work that way at times.
Right. And when you take it to the bigger scale, you don't use streets. You're right. You wouldn't use streets, but you also wouldn't use country names either. You wouldn't say go towards Russia, because there's a whole lot of landmass that would be towards Russia, where there's a large stretch of land north and south that could all qualify as, if you turn right, you're going towards Russia. So it wouldn't be useful. It's not that it's incorrect. It just wouldn't be useful for trying to get to a smaller spot. If you're trying to get to Russia, that's exactly how you could tell them to get to Russia. You could say, go this way towards Russia, and any stretch along that north-south line that's, however many hundreds of miles where Russia is in that direction, if you turn right, all of that would count as turn right and go to Russia. But usually people aren't trying to just get to a place that large when you're giving instructions like that. That's not usually the case. So if you're trying to get to a specific place, you would give more specific instructions. But those instructions are not going to rely on the map having exact shapes for what you're walking over. It doesn't need to. Like I mean, this shows it. I don't need to have exact shapes for the street, for the store, for the playground that's between you and the store, for the school building, for the firehouse, I don't even need to represent those things at all on the map. It literally doesn't matter as long as you follow the instructions given by the person, as long as they explain to you how to use the map. It doesn't really matter what the map shows as long as it works.
You said earlier that we don't navigate based on maps. Instead, maps are based on navigation.
Yeah, what I'm saying is that the maps didn't come first. They couldn't. People didn't head out into the world with the maps already made of where they were going. That doesn't even make good sense. Somebody must have went there first and recorded what they found, and then the maps were made.
So they make the maps based on how they navigate?
Yeah. What the people found when they went to a place. Yes.
Doesn't that then mean that makes then maps accurate to some degree?
It makes them useful. They work. Like I said, maps work. I'm not arguing that maps, I'm not saying maps don't work. I'm saying that they do work. I'm saying that they work regardless of the shapes that you put on them. You don't need to have accurate shapes on a map, and it can still work.
What if let's say I'm trying to let's say I'm crazy a bit and I want to do some endurance running, and my goal is to run the whole border between Finland and Russia, and Finland and Norway, and Finland and Sweden. Basically run the whole border of Finland to its neighboring countries. Would I be able to do that? And wouldn't I need some accuracy in terms of distances and sizes and stuff like that relating to the map?
What the way I would respond to that is I would challenge you to go to each of the places that are in charge of those countries that you mentioned, and have each of them give you an estimation of where those lines would be, and see if a single one of them matches a single one of the other ones that they give you. I doubt that they would. Okay, because those border lines, those aren't real things. Borders aren't a real thing in reality where you can go walk to it and, oh, there's the line that separates the United States from Mexico. That's not a real thing. It's all on the map. It's all part of the map. In fact, that's showing my point even more. We have lines on the maps that literally don't exist in reality, but we can still read the map and use it. Those lines aren't actually there.
Here's a good example for your border line of Finland, right? How long is that line that encompasses Finland? Huh? How long's the line, bro?
I don't know exactly. I don't remember those figures.
Nobody knows. Here's a little secret. Nobody knows. It's called the coastline paradox.
Where did you get this idea?
It's called the coastline paradox. I didn't make it up. If you're not familiar with it, you can just search coastline paradox and see what it is. Okay. No one knows how long the coastline is of England, for example, or America, or anywhere, because of this.
What if we ask a scientific question about that. Are you saying that science cannot prove the coastline?
Well, according to you, science can't prove anything, I thought.
Thank you. I do know there's some
Thank you,
coastline
what?
paradox, by the way.
But what?
Thank you, what?
Well,
Why'd you say
I'm not
thank
sure
you?
what the point. What would be the
Sorry,
point
Bob.
of trying to measure an entire coastline? You don't need to measure an entire coastline. The reason we use things like maps is because they're useful to accomplish a task. Okay? There isn't a task that requires an exact measurement of a coastline. That's not a task that we need to accomplish. What we need to do is go in the general direction of a certain piece of the coastline so that you make sure you hit the right harbor or you get to the right dock or whatever. Okay, whatever you're trying to do. None of it requires an exact an exact measurement of what the coastline actually is. All you need is a general representation of what direction the coastline's in and a general idea of where it's at, and you can get to the coastline.
I want to go back to something you said just some moments ago. You were saying that if I were hypothetically going to ask for the Finnish government and the Russian government for a map, they wouldn't agree as to where the border is. Now that presents an interesting historical challenge. My grandfather actually lived 100 meters from the old Finnish-Russian border. Are you saying that it's plausible that according to Finland, he was within the Finnish border, but then according to Russia, he was in Russia? Because we don't know where the border is.
Well, that is possible, but that doesn't even need to be the case. For them to show you their borders, there's basically two options. Either they would have to give you a representation, a map or an image, or they'd have to take you out there themselves and show you along the line the border. Pretty sure if you're actually going to convince them to give you the borders, they're not going to take you out there personally and show you the border. They're going to give you a representation of the border. And so the challenge is basically get that representation from each one of those countries and see if any of them match up exactly with any of the other ones. I'm confident they won't, because basically they would have all needed to get the same information from the exact same source and have the exact same person make the exact same map to determine those lines. It's not going to happen. And you don't need it to happen because it's just a general idea.
I think I can actually use the idea of instructions against that. Here's how actually border lines were typically drawn. They would actually use things like rivers. So you would say that, okay, here for this and this distance, the border follows this and this river. And then from this river, it deviates to that direction for this and this length. So you would use
What length? What's the length?
geographical, well, whatever. 30
I asked
miles.
you earlier what the length was.
So
and you didn't.
So for the river thing, all right. How did they account for every day the little bit of corrosion that happens of the riverbank as the water runs down the river?
I don't think they would need to. It's such a minor detail.
Exactly. It doesn't matter. It's not important.
Yeah.
It's so small that it doesn't. There's no task that you need to actually accomplish in reality that would require you to take into account the erosion that happens along the riverbank for those lines. Exactly.
Yeah, and everyone knows where the border is.
So the exact shape of the river isn't really important. But what is important is that there's a river there.
Yeah, and
right?
that river gives an exact shape. The exact shape of the river at that time gives exact shape to the border.
Well, it's not an exact shape. It's a representation of the river on the piece of paper. You won't get an exact shape on that piece of paper.
Well, we
on the
can
map.
get exact shape from the exact actual shape of the river, which is exact because it's physical.
I don't
If
think
you have
that
an exact
you're
shape,
hold on. I don't think that you're understanding what you're claiming. They would have to account for literally every rock, every grain of sand, the tiniest piece of mud we can possibly detect. They would have to account for all of it to have an exact shape of the river. They don't. They can't.
Here's how they can do it. They can look at
They
the river
can't.
and see.
They can't do it.
Yes, but they can get it from the
literally a
actual
paradox.
physical shape.
It's a paradox because
It's
they
not a
can't do it.
paradox.
It's
Let's
called the
say
They can't
coastline
account for
paradox.
every rock. It can't happen. It's humanly impossible for us to account for every rock. Rocks get too small for us to account for all of them. You could pick one river on Earth and take all the history of humanity, and we would still be trying to account for every rock today if we had started as soon as humanity began.
Here's how you do it. Let's see what kind of questions are you asking about the shape of the border here.
I wasn't asking a question. You said exact shape, and it's not.
Yes, but it can be exact.
No, it can't.
If it was an exact shape, let me try this. If it was an exact shape, you would be able to have. Hold on, guys. If it was an exact shape,
I'm giving you.
You'd be able to tell me. Okay, maybe I just won't. Go ahead, guys. Go ahead.
Sorry.
If you have an exact shape, that must mean that you have an accounting for every rock in and around that river. If you can show me the spreadsheet, the Excel sheet, the whatever, the list, where the scroll that has all these, if you can show me an accounting of every single rock in that river, then we can talk about how you've got the exact shape. If you can't show me that accounting for every rock, you don't have the exact shape. You have a general shape.
Yeah, and like I was going to say, if you had an exact shape, you'd be able to tell me how long the line was that went over your border that encompassed Finland. You can't do that. You don't have an exact shape. If you did, you'd be able to give me the length of that exact shape. You can't give me the length of it because it's called the coastline paradox.
Sorry, I had to stop listening. I got the message that I needed to pay attention to. I'm back again. Yeah,
no wonder why I was able to get a whole sentence out. I know. I should have known you were busy not listening. Motherfuckers.
Well, if Theo is messaging me about doing something badly, that takes precedence to whatever the discussion is going on.
Is that training officer?
Geo, as in this server owner, he is kind of thinking that I'm crossing a line, so I need to pay attention to that somewhat.
Never mind.
My apologies.
When you said TO, I watch a TV show sometimes about, or it's fake, but it's like a drama, comedy-ish thing about cops and training officers and stuff. So when you said TO, I was thinking training officer. I think maybe.
Yeah, I was apologizing to you earlier, Jeremy. I was kind of stepping over you.
Now that you're listening, if you have an exact shape, can you tell me how the length of the line that encompasses that exact shape? I'm gonna draw a line around your exact shape. Can you tell me how long that line is?
We don't need to necessarily be able to tell how long the line is.
But if you had an exact shape, would you be able to tell how long the line was that encompassed that exact shape?
Not necessarily. Here's why. The earth, doesn't the actual shape of the river in reality, doesn't it have an actual exact shape? Yet we cannot answer questions about the length of it. Yet we probably would agree that the actual shape of the river is an exact shape. In reality. We just cannot answer all questions about it. It doesn't mean that it's not an exact shape. It's just, it's a matter of our knowledge is limited. The shape is still exact. And if we define
an exact shape
border,
that you don't know the size of because you can't measure it.
Sure.
It doesn't sound like a very useful exact shape.
It's not an exact shape. It can't be exact if you don't know the measurement.
Of course,
that's not exact.
Let's take an example. Let's take a beach. is there an exact number of grains of sand on that beach?
Yes, there is a
Sure,
number
and
of
we could
grains of
count them
sand
if
on
we
that beach.
wanted
Yes,
to.
and that number, whatever that number is, it would be exact. Yes.
Then we could count that if we wanted to. We could get all the
Well, no,
grains
we
of
couldn't.
sand.
We wouldn't have the time.
Yeah, let's take the
If you had
next
multiple
closest.
people in on it, you could get a team
Let's
effort
take the
going too.
closest. Let's take the closest beach to you, Jeremy. How many grains of sand are there?
I don't know, but if we wanted to find out, we
There
could
you
count
go.
them.
It's not exact.
There is an
There
exact.
is.
Hold on, bro. Hold on.
Okay.
Go ahead.
There is an exact amount of grains of sand on that beach, and if we wanted to, I could get a whole team of people consisting of thousands of people. We could dig up every grain of sand, and we could start counting them, right? And eventually, we'd have a number of how many grains of sand there were, right?
You probably wouldn't have enough time, even if you took the whole population of the Earth to do it.
He made my point already, Jeremy. He already made my point, which is yes, there is an exact number of grains of sand on that beach, and it doesn't matter how you describe that beach, it won't change that exact number. That's the point. It doesn't matter how you describe a thing, it doesn't change what it is in reality. So it doesn't matter how you draw the picture on the paper, it doesn't change what reality is. So you can draw whatever you want on that picture, and it can still get you where you're trying to go, and it still won't change reality. The store still won't be shaped like a triangle, the road still won't be shaped like a squiggly line, and the person still won't be shaped like a stick man.
I'm not necessarily sure that the only way that we approach maps is in a simplified manner like that. I think there are more complicated questions that we actually use maps for. And in those cases, that's a simplified understanding.
Well, what somebody chooses to do personally is not something that we could ever account for. You could actually go buy a map of New Zealand and decide that you're going to decide all of your moral decisions based on that map. You could do that if you wanted to. That doesn't mean that you have made the correct moral decisions. That doesn't mean that you've made a good life for yourself. What it means is that you've chosen to use the map to somehow help you decide your moral decisions. So what somebody chooses to use a map for in their own personal life isn't what I'm attempting to account for. All I'm doing is describing what the map actually is, which is a representation of what somebody has already found.
Wouldn't it get terribly complicated, though, if, like, let's think about how many questions I can ask a map, how many different paths I might take, and how many... Isn't it, roughly speaking, infinite? So how would you go about describing, decoding an infinite amount of answers into a piece of paper except using the actual shape of the land the best we can do it?
Let me make sure that I understand. Are you asking if you can use a map for anything you want, then how do you go about using it properly? Is that what you're asking?
I'm saying the amount we can use a map to answer, roughly speaking, an infinite amount of questions, and we get those answers correctly. How is it possible to encode an infinite amount of information on a piece of paper if the shapes aren't correct?
Because they don't need to be correct. It's all on how you use it. The information, how you choose to represent information doesn't change what the information is. It's whatever reality is, that's what it is. However you decide to represent it, that won't ever change reality itself. You can't change reality by representing reality. You can only change reality by interacting with it physically.
Get the information that's... Go ahead, Jeremy, you're trying to get in.
No, I was just going to say, I don't know, Professor Phil Bell or whoever that, I don't know who that was, but there's a guy in GEMS that thinks that space time's the coordinate system. However, space time's bending, causing things to fall. So they don't. This isn't an honest discussion or debate or however you want to put it. It's just not. There's nothing honest about this.
Well, okay, but I brought up the map thing because of my Reddit conversation, and he was asking me questions based off of that. I think it's a thing that a lot of people don't think about. It's probably something that they usually in their life don't even need. I don't use maps a lot in my life. Every so often I'll use like a GPS or whatever, but I don't use maps a lot. And I don't go a lot of places or travel a lot. So, and I think a lot of people just accept the shapes that they've been shown on maps and stuff like that, and that's fine as far as life is concerned, because a lot of times you don't really need to know what shape a continent is. Like it doesn't. Most of the time, you aren't traversing a continent, right? Like almost never, maybe actually never. I don't know that anyone ever like just decides to travel like every part of a continent. That's not a thing. Now you may do a general travel, like, hey, I'm going to the United States, and I want to make sure I visit all 50 states and hit Canada and hit Mexico or whatever. Like you could go to all of the general areas of a continent, and that you could do that pretty easily, using vehicles or whatever. But nobody ever in the history of ever has stepped foot on every piece of ground on a continent. It hasn't happened.
Bob Dole for president.
Don't believe the salacious rumors and headlines. Rumors of my death have been greatly exaggerated.
Hey, Bob.
Yeah.
Would you be interested in doing a video presentation of your concept of cartography? So let me give you a little
I'm
bit
not
of
sure what you
background.
mean by that.
Yeah, that's all right. So right now I have a dormant YouTube channel that I call New Earth Science, and basically what I want to have is I mean, I'm the creator of the channel, and I'm going to also have content, but I want other independent uh, lay scientists to present reality in a way that is new and fresh and consistent with reality. So think of a 5-minute presentation, and you could even make, I'm just giving you an example. You could make 7 5-minute presentations. But each presentation is just basically a snapshot of the content. Like, this is what this is like. Like you could start your first video. Have you ever thought of how they make maps? And then just kind of like what you were talking about. What you were talking about to me was really interesting. I really appreciated the way that you approached the discussion. But that's exactly what I'm looking for in terms of people to participate. It's not going to be flat Earth, but it is going to be contrary to consensus, right?
Right.
So most of us, I think, like you were talking about, most people think that cartography is precise, like it's a precise, right? But
Yeah.
anyway.
Yeah, I think I'll think about it. I'll see if some ideas come to me, and if I can arrange them in a way that I would be comfortable kind of conveying to people in mass like that. I can definitely think on it.
And then you could always use one of those cartoon figures that moves their mouth for you. You know what I mean? You don't have to be on camera
there you
or whatever, right?
I'll just I'll marker up my hand to look like a person move with them.
Yeah.
Wondered how they...
You got put googly eyes on your hand.
Yeah.
That'd be funny. But anyway, anybody out there listening to this, I'm interested in trying to. I've been talking about it for over a year, and nobody either forget or they're just not interested in it. But I think it would be a really worthwhile endeavor to present, like even Grimm, like Grimm could come on and give a 5-minute talk on electromagnetism and how it's an alternative way of looking at the world. You know what I mean? Because like I wouldn't have known about the electric universe if I hadn't even gotten into flat Earth, right? I wouldn't know a lot about these other avenues of education.
Yeah.
So yeah, just think about it. Get back to me.
Okie doke.
Interesting topic, this map making. I actually ended up reading on Wikipedia about the cartography of France, and if this article is trustworthy, it seems that maps are not only based on navigation but also something called cartography, where they actually use measurements, tools, and then do like sometimes people spend 50 years.
What's the measurement they got for the coastline?
Country.
What's the measurement they got for the coastline when they did this cartography thing?
Oh, it doesn't mention the coastline here. Hang on.
You
and
said
it wouldn't
what I
if you're
said
trying
before, though.
Let me do a search for
The maps are based off navigation. That's what I said. The navigation isn't based off of the maps. The maps are based off of the navigation. The maps didn't come first. They couldn't come first. They would have had to somehow know what they were going to before they got there for them to have the maps first.
Yes, that's so you're saying then that this Wikipedia article is fake?
No, I'm saying it agrees with me. What you just said is exactly what I was saying.
Yes, but I didn't say what you were saying. Maybe you weren't listening. I'm sorry. I'm tired.
You said that the maps were based on navigation, right?
No. It seems that the fault isn't that I'm tired. It's the fault that you're not listening. So when I say cartography, is that the same word as navigation? The cartography word starts with C. The navigation starts with N. How are you confusing those two words?
So did nobody else hear him use both of those words? I heard both. I heard navigation and cartography. And
yeah,
whenever you said navigation,
I used it.
You said the maps are based off of navigation and.
Yeah, maybe it's plausible that I used it in, for example, in a phrase that I thought that maps are based on navigation, but it seems that they are based off cartography. Because that's what the Wikipedia article is saying, that they actually use tools. They do cartography, not just navigation.
All cartography is the first navigation. That's it.
Okay.
It's the ones who got there first. They are the cartographers. That's all. They're the ones that are making the map based on their navigation.
Okay. Here's a interesting thing though. These guys that were doing the maps for France, they didn't. It was populated. So how could they get there first when it was it was a kingdom? They were living in the kingdom. There were people there. There had been people there for thousands of years. How could they get there? They got there first. Are you saying that the people that mapped France at the time of Napoleon, they got there first? What did they have? Time travel?
I didn't say they got there first before any other humans.
You said that they got there first. The one people who made the maps got there first.
They're the ones who did the navigation first for the map.
Okay.
Not that they got to the piece of land first. They're the ones who decided what was going to go on the map and what wasn't going to go on the map.
Okay. So, okay, I conclude then that you just used incorrect words. That's fine. So, the people that made the maps, they necessarily didn't get there first, but they made the maps first. That's fine. So they, for example, they measured distances, mapped the coastline. There's actually a beautiful picture of the coastline right here. Gascon, Bretagne, and Normandy.
So is show not happening today, or?
Hey, Geo, if you're there.
Yeah, I'm here. What's up, Travis?
I'm sorry, I didn't hear anybody. Who is this, Geo?
Yeah.
Hey, I invited a Globeflake who's been making comments on my YouTube channel to come into the Discord. He said he was just trying to join voice and whatnot. He said he wasn't getting any responses. So if you want to just keep your eye out, his name is Paul.
Is this Aquila77?
I don't know. I can ask him what his name is. Hold on.
Because I saw that he joined, and it looks like he did the agree command, so he got that, but it doesn't look like he's voice verified. But he was popping in here, so I was wondering if maybe that's him.
All right, I just texted him to find out. Okay, he said yes.
All right, I guess yeah, just tell him to join the VC, and then we can unmute him. Okay, yeah, he just joined. I unmuted him.
Okay.
Hello.
Hi, Paul. It's
Hi.
Travis.
Hi, Travis.
What movie were you watching?
I was just watching Eternals. It just came up on Disney Plus. So.
Was it good?
Yeah, average.
It doesn't look interesting to me.
Not the best.
I'll tell you what is a good science fiction movie to watch, and it's free on YouTube right now. It's called Infinity Chamber.
On YouTube.
Yeah. If you just search
YouTube.
Just search Infinity Chamber, and I mean, I can put it in the.
Yeah, I got it.
Yeah, it's like an hour and 40 minutes or something.
Okay, might give that a go sometime. Like a bit of sci-fi.
So yeah, this is a I don't know, relatively new channel. Geo, how long ago did you start this?
I think it's been about 3 months now, maybe 3.5.
Yeah. So.
Just finding my headphones so I don't wake the rest of my family. Give me a second. Feel free to keep talking. Don't stop on my behalf.
I don't think anything is going on right now, so it's just you. And...
All right. Just me. So who's who in here?
I am. I'm your Copernicus.
Okay.
And then anybody else who's in here is Flat Earth Tests. That's Brian, but he's muted. Jeremy's muted, but he's one of the go-to moderators here. He's pretty sharp. The real Bob Dole, he's a a flat earther. So everybody in here right now, besides you, is a flat earther. But we had a pretty good long running show today, Gio.
Oh, yeah. You mean earlier, like this morning?
Yeah, I mean, I think we started like around 5:30, 6 o'clock, and I think the conversation just kept going throughout the whole day, pretty much.
Nice.
So
yeah, I think I didn't log in till the afternoon. I was so yeah, I probably missed some of that.
Yep. But yeah, I mean, if you just wanted to kind of touch base right now, it's late. I guess you're probably in the UK, so it's midnight for you.
Yeah, I am. 5 to midnight. Yeah.
So it depends on how much you want to, discuss.
To say a polite hello, really.
Yeah. Okay. Well, there you go. Yeah. But yeah, Gio's got moderators in here. If things get out of hand, we try to, make sure that people aren't over talking and abusing each other. So it's an attempt to try to have some concord in a Discord channel.
Fair enough.
So, what field are you in?
Full disclosure, I'm a physics teacher. So,
all right. Is there any particular area of physics?
I studied general physics at university in New Zealand. So
Okay.
I'm a New Zealander by birth. Lived in New Zealand for about 30 years, and then moved across to the UK.
I think I just heard that New Zealand has an actual language. Is that true?
There's a native language, yeah.
I didn't know that.
Yeah, there's the Maoris.
So what's
they
their?
claim to be. Sorry.
Are they Anglo-Saxon? I mean, like, are they?
No, they're Polynesian.
Indonesian, Polynesian. Yeah.
So
I did not know that. For some reason, I guess colonization just totally made me think that New Zealand was full of white boys.
Well, it is, but yeah, it's kind of colonization kind of took over the place. Although I have to say, it's probably one of the gentlest colonizations. The Maori are still, fighting for rights and things, but they're treated a hell of a lot more fairly than some.
Huh.
But yeah, I am very Anglo-Saxon myself, so I've kind of returned to my genetic origins, if you like.
So your origins were British then?
Yeah, oh goodness. If you go the right way, I'm 7th generation New Zealander. But if you go different ways, I'm only like 3 or 4. So which relatives you decide to follow.
Okay.
So yeah, some of my family were on the earliest boats, which is kind of cool. But
were they any significant players in the history, or were they just commoners?
Not really. No. My family are mainly dairy farmers, so my grandfather was pretty big in the dairy industry, but nothing major.
So if you're a physics teacher, then you must what's been your journey with the shape of the Earth discussion? Like, have you been surprised? Yeah, I'm just imagining if you're a physics teacher.
I was surprised it existed to the level it does, if I'm honest.
When did you become exposed to that reality?
I think it's YouTube suggested videos at me, and I'm like, why are you suggesting me this?
That's fine. See, that's interesting because YouTube is known for publicly in the Senate saying that they are actually quashing flat Earth propaganda. So the fact that you The fact that you were minding your own business and YouTube suggested it, that's really interesting.
Yeah, I mean, it was a few years back now. I went through a phase of discussing on people's videos and things, but in all honesty, it gets to a point where, you know, you get to a point where neither of you are agreeing on anything, so, you know, yeah. Just tend to stop.
Yeah. So what was the can you remember what video it was, perhaps? What the first one was, or?
Oh, goodness. That's
I would wonder, Gio, I would wonder if it was one of the prominent channels.
Yeah, it was. It was like one of
Yeah.
those kind of 100 proofs of flat Earth kind of thing.
Okay.
I forget the guy's name.
Eric Dubay.
Eric Dubay.
Yeah, Eric Dubay. That's the one.
Uh-huh.
Yeah, I think it might have been one of his.
Yeah, he does pretty thorough research. He looks for a lot of textual evidence that there were naysayers, you know, well within 150 years from today.
Yeah, I mean, there are people, definitely. I don't deny that there are people who see it from the perspective of there is a flat horizon and therefore the Earth is flat. I mean, there's all the navigation stuff, and you can say yes, they have a flat map, but you kind of need to work on that. You can't really.
Yeah. I don't know that the argument for flat earthers is that the horizon looks flat, therefore the Earth is flat.
No, I know. There's lots deeper than that. I know that.
Yeah. Okay.
But I think that's where it starts for a lot of people. They can't, from the perspective of a human, it is very, very hard to see that the planet is a globe.
Now, what was it? Somebody just said something about yesterday. Oh, we were talking about navigation yesterday. We were talking about celestial navigation. One of our globe representatives was trying to do stellarium and do GPS, and he was just having a hard time with it. But we had, I think, I don't know, a couple-hour debate on that last night. He's Australian.
I won't hold that against him.
Oh, are you guys rivals?
a friendly rivalry.
Canada and the U.S.
Probably, yeah, probably similar.
I'm just kidding. I don't even know if there's any hostility between Canada and the U.S.
You'd back them in a fight, but when it's between each other, that's a different story.
What's the conflict between the two as it is? I mean, like, is it just
normally just sport?
Oh, okay.
Normally friendly.
I'll tell you what, one of the funniest conflicts is Iceland and I think Canada, or it might be Greenland, or I don't know. There's two countries where there's this island that they both claim is theirs, and every time they'll go plant their flag and remove the other person's flag, and then leave them a bottle of like whiskey or wine or something.
Nice.
Like it's the friendliest conflict ever. Yeah. Friendliest land dispute ever.
Yeah, there's certainly some worse ones out there. A friend of mine who served in the New Zealand Army, and they did some peacekeeping in Korea. So the North Korea and South Korea border, and he just said some of the stuff on the border is just nuts between the two of them. There's a speaker radio mast thing on each side, north and south, and they keep making theirs taller, so it's taller than the other guys, and then they'll just add a bit, and they're just trying to outdo each other in the height of these radio masts and things. It's just bizarre.
You mentioned you had seen some possibly Eric Dubay, content. It's interesting to me, people who, will watch the same video and have a different either reaction, either interest level or intrigued or resonance with, what's being said. It's just interesting to me. You could give the same video to 100 people and you're going to have, such a wide range of responses, to the actual information. So, yeah, I'm just kind of curious,
real quick.
Go ahead, Jeremy.
Oh, my bad. Go ahead, Joe. I was going to ask, where'd you hear about us at?
Sorry, where did I hear about this, or where did I hear about
this server?
Oh, that was because I was chatting to Travis. It was Travis. Travis was on a Facebook group called Astronomy and what's it?
Physics and
Astronomy.
Astronomy.
Heard about it through
Physics and
Facebook.
Astronomy.
Okay.
That's the one.
All right. I was just wondering if it was TikTok.
No, we got to chatting.
Is this channel on TikTok, Jeremy?
I've been every day. I leave a comment because I get tons of flat Earth content.
Yeah,
on TikTok.
Are you serious? Are you on TikTok? I'm on TikTok, man.
No, I haven't. I made a video once about the crypto thing. The thing is, I get tons of flat Earth content. So every day I'll leave a comment like, "Hey, we chat about this on the daily. Come check us out at search Earth Awakenings on Discord."
Hey, what's your handle? Because I need to get 1,000 followers so I can go live. What's your handle?
Oh, no doubt. It's easy crypto. Hold on. Where do you even see that at?
What do you mean?
Oh, it's at Easy Crypto 777.
Okay, is it all spelled out? AT?
No, it's the at symbol.
Uh-huh. And then
that's just what it is for every TikToker. I don't think I made that at symbol.
Oh, okay. And so then is it Edward Zebra?
No, Easy spelled out.
Okay. Easy what?
EASY. Crypto.
Okay.
777.
Okay. Easy Crypto 777.
Yeah, I just made a.
Is it like a green-eyed monster kind of looking thing? Yeah, Jeremy. Yeah, it says your name, Jeremy. All right, I just started following you, so now you got to promote my channel, bro.
What would that be in my inbox?
Yeah, if you go to, your inbox, right, and then you say and you see followers. Go up to the all activity and then go down to followers. I should probably be the newest one.
Oh, all right. I gotcha.
Yeah, I started making short little videos about deep thoughts in flat Earth science.
What were you trying to go get at, though, Gio? My bad. Sorry to interrupt. I just wanted to see if I got anyone yet. I don't think we've gotten anyone off TikTok, but.
No, I was just kind of commenting how it's interesting how people can, watch the same video and have a different response, to the information. So, yeah, he was just saying that sounds like you probably got recommended those videos before. Yeah, back in like 2016, 15, 16, and 17. That's when like YouTube was just more like 15 and 16. YouTube was recommending like if you had anything that was even related to flat Earth, if people were putting it it's like the algorithm was working. So tons of people were getting recommended videos for flat Earth back then. But after like 2017, 18, they completely squashed that and they did like a whole shadow ban on flat Earth. So now it's like hard to even find any content on it anymore.
Yeah, that's probably about right.
So is there in your opinion, has there been any reasonable argument or claim for flat Earth that has impressed you?
Not particularly, no. I think a lot of claims can be explained quite happily with classic physics, and a lot of the time I don't see need to re-explain it, and I think that's often the problem, is that you come across. I know that you look at the comments on videos and it just descends into insults because people just get frustrated because from my perspective, I can explain the physics of most situations and how things work, and I know some experiments that back them up, and I know the basic principles that lead to that, and so I can, like I was doing with Travis, I try and explain the physics equations and the things that link together. And it has to start from basic observations of like motion and movement, and then you kind of build on things and build up to a point. And it's hard to do in a chat, and it's hard to do if the other person isn't coming from the same perspective. And I think that's where Travis and I are clashing, is because I come from one perspective and he's coming from a completely different perspective, and we struggle to reach a common language almost of the communication of it. I think that's why people can see the same video and see it very differently. If you are watching some of those videos from a physics and globe perspective, then the answers are different than if you are looking at those videos from the Earth could be flat, and why not? And I think it's very easy to see things from different perspectives in that case.
What would someone need to do in order to establish a scientific reality?
I think the biggest problem that the flat Earth faces in this regard is a complete model. I've yet to see a complete model of how a flat Earth would work with all the observations that we see in terms of, star movements, cycles of the sun and the moon, and all of those things. And there's models which explain bits of it, but then someone else needs a different model to explain something else that happens, and those two models of the flat Earth don't mesh well together. So you've got different people within the flat Earth community trying to make the same models, but their models don't line up with each other because they're trying to explain different parts of it, and you can't often.
Right. Yeah.
And I think that's until you can actually come up with a complete model that allows everything to work.
Is that how the heliocentric model worked? You guys had a full operational model, and then you came to the world and said, "Here you go."
No, it's not. But what happens is they got to a point where a flat Earth couldn't explain what they were seeing, and so the view of the Earth being flat changes to a globe, because the globe allowed the things that they were seeing to work more simply. And then over time, there's more and more evidence that builds onto that, and less evidence that contradicts it. And so according to science and physics, we've got to a point where everything we see can be simply explained by a heliocentric globe system with gravity that works, within the local range according to Newton's gravitational formulas and ideas.
So, what in your mind, if you could create a dream team, flat Earth model building dream team, what do you think would be necessary in order to accomplish that task? Because to me, it seems like a monumental request. So I'm asking you, since you made the request, you know, you said, I'd like to see a full operating model. What would you say is the reality of how that could even be done?
You have to. I mean, it's the same as the nature of all science, and it's the reason that science is so monumental. It's not one person. It's built. It's built over time, and if something contradicts a previous person, then it has to be checked and verified. And if it holds true, then the previous person's idea has to be modified to fit the new idea. And it would be the same for a flat Earth. You have to start with the premise of what you think it is. Like, you know, is it the infinite plane that stretches beyond a dome? Is there a dome? Isn't there a dome? You know, there's so many.
Yeah, but don't get too far ahead. Don't get too far ahead. I'm asking simply.
Yeah, so you start with the basic premise of right. The Earth is definitely a round circle. Then, so it's essentially a flat.
Wait. I'm sorry. I'm sorry. I really want to be more specific. I don't want. I'm not looking for you to answer in terms of theory. Okay. When you talk about, when you talk about the request, of a full operational model, I guess what I'm just trying to, like, let's say you were going to do an elevator pitch to get, support to do something, right? So try to give me a very brief elevator pitch in terms of like what it would take.
Yeah, I get what you're doing. So in that case, what I would say to the community is you basically need to get together who you think your best players are, and you need to, in order to be taken seriously by everybody and anybody, you have to come up with the best model you can that fits everything that we see and experience in life.
Okay. So one of those models I would imagine would be a model of the continents, right?
In terms of, you mean spacing and distances between? You mean that?
Right. I
presume we're meaning the same thing, yeah?
So how would okay. So in my mind, I think that would have to be done from scratch.
Right. So you'd want to redraw maps and remap.
Well, every map is a distortion. Every map is a projection. Okay.
Yeah, of course, because you can't.
So, right. Okay. So if that were going to be one of the things that we were going to say, okay, look, somebody somewhere is going to say, you didn't do this in your model, so let's make sure we cross all our T's and dot our I's. Yeah. So in my mind, right. But hear me out, though. Hear me out.
Yeah, carry on. Sorry.
How long do you think it would take to map out? Right. So look. So right. Yeah. That chuckle to me shows that this is not going to be done in 4 years, right? So to say that
it's been undone.
To say that we don't have, okay, hold on. To say that we don't have a working model, to me, is a little bit ludicrous, because I'm driving a tractor trailer 60 plus hours a week. I would love to dive into atmospheric refraction research, but I can't sustain myself full time and do that, right? So think about this, right? So all of the big names, Newton, Copernicus, Galileo, in my mind, or even I'll say Michelangelo, right? These guys were commissioned. That is, they were paid to do this research, right? So that's one thing we're not going to get.
Do you think they were paid to be biased though, or do you think they were?
Oh no. I'm
paid
not
to do
talking about
genuine-
no. I'm not passing judgment on bias or prejudice at all. My point is that those scientists weren't just simply hobbyists.
No.
You know what I mean?
They've all. So my, like I say, the time you need and the effort you need is monumental. But the problem I see is that there was a flat Earth idea, and we have changed out of that because of the evidence that people like you mentioned put together. So we have shifted away from that model because there were things that didn't work.
Right. So
you have to go back to those first things that were figured out that didn't work. So one of the first ones, was it Copernicus, was it, who did the retrograde motion of Mars? How do you explain that Mars tracks across the sky and then reverts for a while, goes back the other way, and then goes forward again? So you have to, first of all, start at that point and contradict where it started going wrong in terms of the flat Earth model into the globe model, and start at that point. Because until you deal with those early things that stopped the flat Earth model, how are you? You've got to undermine the science right from the beginning.
Yeah. Okay. So are you telling me that, in your opinion, and it can either be your opinion based on evidence or it can just be your opinion based on correlation, it doesn't matter to me, but is it your opinion then, since you brought up the retrograde motion of Mars, that is the beginning, the primary foundation for the heliocentric model?
Yeah, you were talking about the heliocentric model, yes, because when he did that, he came up with several theories about how the Earth could move in order to produce that motion of Mars.
Right. Okay. So it seems to me, though, that he already had an opinion as to what the Earth was.
Well, yeah, you say that. But one of his first ideas, though, was that Earth was still at the middle, and everything was orbiting it, but Mars was orbiting something else. So he had an idea that Earth is in the middle, and Mars is on a circular orbit, but has a circle of an orbit on that orbit. So a bit like a moon orbiting a planet around the sun.
Yeah.
He came up with an idea that would make the retrograde motion work of Mars orbiting some unseen thing around an orbit around the Earth. So he had an idea that could have worked for a flat Earth and a Earth-centric model, as opposed
geocentric.
to geocentric. Sorry, yes, that's the word I'm looking for. Thank you. So he had an idea for that, but then he also went, well, wouldn't it just be simpler if Earth wasn't in the middle and this was happening instead? So he actually had two propositions, and then other evidence starts to pile onto that pulls it towards the heliocentric model. And so that's why I bring that one up, is because it's he did have several notions.
Okay, so what I hear you saying then is that he already had a concept that the Earth was the sphere.
No, not necessarily. Well, did he at that point? I don't know. That I'm not sure of.
Okay, so then when you say, though, that he did have a concept of geocentrism, what would the Earth be then?
I don't know. I'm not sure at that point what he thought the shape of the Earth was. I've never actually.
Okay, that's fair enough. Okay, that's fair enough.
Most of his work was about what was at the center of the orbits and what was orbiting what.
Right.
Because the strongly held belief at the time was that it was geocentric and we were the center of everything. Because we are that arrogant that we like to believe that. But
no. See, I don't pass judgment on that aspect. Like,
we are.
I don't think
even physics was still arrogant. We're the most arrogant of arrogant things. We are as physicists. Because we like to say that we are the center of the universe, and that's.
Well, I what's interesting is the adventure that I'm on now that began with Flat Earth. Flat Earth was my very first conspiracy. I was not into conspiracies before that at all. So everything now, though, that I have come across has changed my entire worldview, my entire epistemology. So before I was a flat earther, I was a Christian.
Right.
My being a flat earther has nothing to do with my not being a Christian at the moment. But my point is that I'm now an anarchist.
Okay.
Okay. And by that I do not mean that chaos is the way the world should run. Okay. I don't believe I'm a pacifist.
Right.
I don't believe that there should be no rules. However, I do believe that there should be no rulers.
Okay.
Okay. So
I'm not far off you on that, to be fair.
okay. So all of that to say, I am not one who is going to trust my rulers now who tell me what history was.
Right.
So, again, to go back and research, like the questions that I was asking you, I wasn't trying to catch you out. I was trying to understand, what you believe, where you're coming from, how you would answer these questions, because that's how we can progress with this conversation. So, in order for me to, research the questions I was asking you, like I would want to know, okay, was Copernicus a geocentrist? Okay, what does that mean? So if he did believe that the Earth was a sphere, then the retrograde motion of Mars, in my opinion, is tertiary, because he already believed the Earth was a sphere. So that's the evidence. That's the evidence that I'm going to go after, because that is the major premise. Because he already believed the Earth was a sphere before he got into the analyses of the heavens with the retrograde motion of Mars. So that's what I'm saying in terms of, for me, I'm not going to argue or even worry about proving or explaining a tertiary premise. I'm going to go after the major premise.
Okay, but fair enough. So, who are we going to blame for the first notion that it was a globe?
Right. Exactly.
Do you go ancient Greeks? Do you do the whole, stick with some shadow? Is that where
Look,
we're heading?
so the Eratosthenes was my very first research into the topic, because it kept coming up in the videos that I was watching. So, and we had this discussion earlier today, but about Aristotle. So, my issue with Eratosthenes is, and I'll just be honest in terms of the first 5 tabs that I went through. They were all educational sites. One was a homeschooling site.
Oh, yeah.
One was a high school, and then the other were collegiate. Okay, university. Okay. The one thing, even though it was college or even though it was university to homeschooling moms, they all told the same story with no citations. Even the university had 0 citations, so I couldn't research any of their claims. To me, that was a big problem. So I'm supposed to just believe these articles written by EDU sites, and they don't even cite their sources, and it could have been cut and pasted from, like, how am I supposed to know the university didn't cut and paste what homeschool mom put up? Like, they could have just I'm serious. I'm serious. They were the same story.
But the story is relatively simple, so
my point though is, where's the source? How can I even find it? I still haven't been able to find it.
Yeah, as a former Christian, and that's what I am as well, you can say the same thing about the Bible. Where is the evidence that this is a genuine text with origin? And it's the same issue, that it's delving so far into our past that it is murky. And there isn't, It's not going to be a piece of text on the internet, is it?
So the thing, right? But see, here's the thing that I would discount Eratosthenes because Eratosthenes already assumed it was a globe, so we can't use him as a primary source.
So how can you do his work better in order to show that the sun is local?
Well, first of all, right now I'm not making any claims. I'm just trying to research the claims that have been made. So when you said, how far back would I go? I'm trying to say right now at this point, I'm going to eliminate Eratosthenes. Why?
Right.
Because he already assumed it was a globe. Okay, so then we have to go even farther back than him because somehow he already had this idea that it was a globe. So where did he get it from? So this is the infinite retrograde motion of scientific discovery.
Yeah, but
right?
My statement with this is the same as it was before, that science is about finding the evidence for what is happening. So, sorry, that probably came out wrong. So you look at the evidence that happens, and if it doesn't fit the model that you had, then something is wrong.
Again, though, right? But with the Copernican retrograde motion of Mars, there was already a model. So again, I'm questioning the model. So I have to go back because they didn't have pictures of NASA back then. Pictures from NASA. So I can't use use those.
Something else must have convinced them.
Right.
Given somebody the idea that it wasn't
exactly.
flat.
Exactly.
So why did they even have that idea if
Right.
there's no evidence?
So, yeah. I mean, I don't remember my, middle school education with a pristine recollection to say, I don't remember what story I was told in terms of, like, I don't remember Eratosthenes being a part of my heliocentric education. I can say Galileo, I can say Copernicus. I don't even know that I would say Pythagoras was a source. It would have been, it would have been Copernicus, really.
We teach very little of it. We don't teach the history of discoveries very often at all. And I think that's one of the downfalls of what we do. We don't teach the process that we've been through to get to where we are. And I think that is one of the downfalls of education, because the kids, it's like computing. They just assume that computers have always been the way that computers are.
Right.
And they don't realize the development process and the things that have got us to where we are.
Yeah.
That's very true of science as well. And we don't emphasize enough the process that goes through to get to the points we've got to.
Absolutely. So that's an interesting correlation. One of the things I have a master's degree in Bible. So one of the things that I understood in my graduate studies was that I wasn't a part of the process of, let's say, the Council of Nicaea, when they're hammering out the doctrine of the Trinity, right? So I'm almost 1,500 years beyond that, so that I have the conclusion already.
Yeah.
Right. I wasn't given the text and they said you figure it out. Right. Yeah. I was told this is what the text is. This is how you know Jesus is God. This is how you know blah blah blah. All that stuff. Right. So that was one of the things that I understood early on. For me, was like, man, I'm actually at a I think a weaker position, because I've just been handed this and I don't know what the process was. So actually, I wrote a paper where I tried to come at it from that perspective of actually addressing the claims and, trying to figure out how I would work through the process. You know what I mean? So that was an interesting, exercise for me. But I think that you're right. I think that it is an absolute travesty that that history isn't, not enough time is spent on that. Even Yeah, I could say so much more. So we've got some people in here who are listening. I don't know if anybody else wants to jump in and interact at all. I don't want to,
yeah, sure.
Hog the mic. Just for the peanut gallery, Sean G. I'm not scared of anything, man. So if you wanna talk, jump in the voice chat, man. I'm absolutely not scared, bro. That's for whatever.
Is there a chat somewhere alongside this?
Yeah, are you on your phone or?
No, I'm on a computer.
Okay, so right above it says live stream.
Yeah.
Yeah, he's the last comment, 734.
Oh yeah. Just going back to an earlier conversation, is it?
This is a long-standing battle.
Okay.
But Bob Dole, you want to chime in at all?
I just got back a little while ago. I think I might have come in and part way through the conversation.
Yeah, we're just talking stuff, whatever, anything that Paul has said or whatever, Copernicus, scientific method, talking about first principles kind of stuff.
Not yet.
Okay.
I just very recently, I had myself, I had my headset off and stuff. I was doing something else, so I just very, very end of that conversation or so, just maybe last several minutes.
Yeah.
That said that.
Yeah, I'm working in the background and sort of quietly nodding along with everything that's being said. I would like to continue listening to the primary source of curvature, though. That would be interesting to nut out.
So, Paul, how far back would you go to try to establish the primary source for?
I don't know. I'm not sure if it's even the Greeks, to be honest. The other cult. I think it has to be astronomy, surely. And to me, it would be watching rotation of stars. But I don't know.
So you think that the rotation? So are you saying that? I think you said for me it would be the rotation of stars. So are you telling me that if you were 2,000 or 3,000 years ago standing on the surface of the earth and watching the rotation of the stars, you would draw the conclusion that the movement of the heavens determines the shape of the ground?
I think that would be my first questioning point. Yeah, if I was keeping record of things, because you've got stars on the horizon that are setting for half the year, and then they come back. So you'd be wondering why that happened, and trying to come up with some justifiable reason as to to why there's this slight shift in what you see. Like Matariki, that's the Maori name for it. The Seven Sisters Pleiades is a constellation that you can see both in New Zealand and in the UK because it's on that horizon boundary. And when it rises, that's a cultural significance to New Zealand. And so for the Maori culture, they were very big on studying the stars for navigation, and they based their calendar about when that set of stars rises. And so as a culture, I've actually got no idea whether the Maori would have believed it was flat or curved or what. But certainly they used those for navigation. And so they must have understood something about the shift and cycles of those stars to be able to navigate the way they did. Because they were navigating across the Pacific Ocean to find new islands, and they could find their way home and bring more people and all sorts. So they were incredible navigators across massive bodies of water, just following stars. So I cannot believe that the Greeks were the only ones that are staring at the stars and working out these cycles and patterns.
Yeah.
And so that's
Okay.
that's the Greeks have got the recorded history, as far as we know, and not all cultures have that. So it would be a hell of a study, but I think you'd have to look at all the cultures and go, right, who did what and who thinks what and what are the founding beliefs.
Yeah, one of the things that I've always been impressed by when I think about this discussion is how I'm not able to completely wipe my mind clean of what I've already been told so that I can start looking at this from a completely neutral position.
Yeah.
And I think that's unfortunate. I mean, that's one of my criticisms. Yeah. I mean, that's one of my criticisms even for people who are still religious and Christian today, especially in this arena, is to say, because one of the things I think as flat earthers, we rail against the indoctrination of the system, right? We're indoctrinated. We had this model shoved down our throats, and from the time we were one, we had solar system, wallpaper and all this kind of stuff. So, but the reality is, even if you're a Christian, you didn't discover anything on your own. Everything you believe about the Bible, you were told this is what the Bible means.
Yes.
So, I mean, I haven't had anybody come to me and say, oh, you know what? I totally understand what you're saying, and I agree with you. I have just as much resistance from Christians when I challenge them as I do from the globe side.
Of course, yeah.
But
then you see, Christianity's got a similar problem in that not even all of the Christians can agree on what they believe. So you've got all the branches of Christianity, and there isn't one consistent message. The Catholics are different from the Jehovah's Witnesses, who are different from the Mormons, but they all apparently believe the Bible. So, yeah, you're quite right. Depending on which one of those cultures you grow up with, does define your beliefs.
So let me piggyback, and again, if anybody else is listening, by all means, say something, because I'll just keep talking or whatever. But so if we look at what you said in terms of you think that if you were to try to establish a scientific evidence for why you think the Earth is a globe, you would look to the movement of the heavens. One of the things that I've suggested, again, and I can't do this without assuming certain things. So if I were to place myself on the water, on the ocean, and I would, in a sense, chase the sun, and let's say I could pretty much keep up with daylight. You know what I mean? So that I'm never in the dark, so to speak. If the dark's behind me and the daylight's in front of me, and I was able to do that on the water, I think my conclusion would be that the sun is absolutely above the Earth, moving. That would be a natural conclusion that I would understand, is that because I'm traveling over water, all I'm simply doing is traveling in a horizontal direction, and the sky and the sun is always above me.
Yes, but that partly assumes you're on the equator as well, if you're saying that.
Well, that's why I'm saying, in terms of, I understand that the ability to chase the sun is hampered by the fact that we have these pesky little things called continents, right? So, I mean, I understand that, but so it has to be a hypothetical,
well, it doesn't though, because
an analogy.
You could fly a plane. You could fly a plane and do a similar thing.
Why would your first starting point be looking at the heavens to work out?
Because that's all you had. I mean,
got the Earth. You got the Earth to start off.
Yeah, but they weren't going to be using seismic equipment to measure earthquakes, were they? That's, you know, you can feel the Earth rumble, but you can't. You've got no instrumentation to record that or measure that. So that's, to me, that's a modern piece of evidence for a globe. But if you're putting yourself back in ancient culture, you don't have laser sights. You don't have a lot of the physics theories and equations and stuff that we've got now. You don't have the history of measurements that have come before you. You don't have, so the only thing you can do is look around you. And if you, like you're saying, if you sail on a boat and you look at the sun, well, you say, well, the sun just disappeared in a line straight over that way. So why isn't the sun just moving a straight line across the plane? And the whole, perspective vanishing point thing into the distance, and then it's gone.
You say seismic equipment. So this seismic equipment penetrates the Earth, goes all the way through to the core, which apparently, and then out the other side.
No. So one of the evidences that I would give for a globe, which I don't think is often well enough considered, is that when an earthquake happens, so New Zealand is prone to earthquakes, in the same way as Los Angeles and things like that. When an earthquake happens on the Earth, those waves go in all directions.
Yeah.
Right? And so on the surface of the planet, you can pick up those waves from that origin point. And so you can do a simple analysis of how long did it take to get to all of our seismic stations from that first epicenter. So you're not scanning into the Earth as you kind of are in a way, and that's something else, but you are just picking up how fast they get to each of those points from where it started. If you map that out, it's always radial across from wherever it is to wherever you detect it. And so if it happens in New Zealand, South Africa is going to feel it before England feels it, in terms of picking it up from seismic detectors on the surface. So how do you do that if your planet is a disk and South Africa and New Zealand are about opposite on your disk? I'm calling it a disk.
But they're on the same ring.
Yeah, but in terms of distance, you're going around the circumference, aren't you, to get to, or straight across the middle, I guess, would be the shortest point.
But the rings are separated. So there's a gap between the rings.
What do you mean by the rings?
Well, the rings of the flat plane. The inner, middle, concentric, they go out.
Yeah.
Don't you know this?
So I'm saying that New Zealand is on the furthest outer ring, right? What you're saying?
Yes.
Yeah. So where's South Africa compared to New Zealand on that ring?
On the same ring.
Yeah, but how far around?
Well, it's irrelevant. It's on the same ring. So therefore, it's going to feel things before something that's on another ring.
But the wave's got to travel around that ring. What I'm saying is,
yeah, that's right.
Yeah. So how far is it around that ring?
It's not a matter of distance.
Why isn't it? Because waves have a measurable speed. You can measure how fast an earthquake
moves. But they go through a medium.
Yeah. Exactly.
And different medium change speeds.
Yes, and the medium is the crust of the Earth, and there's a very measured speed at which the earthquakes travel in that crust.
Can I ask a clarification real quick? I'm trying to understand. So, when you say ring, what do you mean by that?
Or if you want to call it latitude lines vaguely, you can look at it like that on a flat plane. Think of the Earth underneath being essentially divided.
Okay, so when hold on, I'm sorry. So when Paul was saying, or you, I can't remember who said it. They're on the same ring. When you say they are on, what's the other they? Like we're talking about New Zealand, right? Having an earthquake, and you said, is it on the same ring as
continents?
Okay.
continents. So
Okay.
like rings are more like akin to tectonic plates, if you like.
Okay.
You know, it's just a different way of thinking of the way that the crust is set up,
Okay.
as
All right.
opposed to the way it's postulated in the books.
Thank you.
And you're saying you don't think that the earthquake can jump across the rings to the next ring in, the next smaller ring, or is that's going to be more difficult and should take more time? Or
Yeah, well, it's just that there's a gap and there is medium. I don't know how big the gap is and what the medium is between them, but there is a medium change.
Don't you think we'd be able to see that and measure that if we?
Well, yeah, but wouldn't we be able to see and measure curvature as well, which can't be definitively shown? Oh, okay, fair enough. I can test that.
Well, I mean, there's people that have tried not to, and they have. So
Okay, you're telling me we can definitively show curvature with a physical measurement, not some optical photo or a calculation with a theodolite.
okay, yeah, okay. So you need a beam.